I'm James Gosling, and this is a Star 7.
Hello everyone, and we are glad to welcome you at the second day of Devoxx Ukraine online. I hope you will enjoy it as much as you did yesterday. Just a bit of organizational information before we start. You are watching this streaming from your personal user page. The user page contains streams for 3 tracks. You can switch between the tracks at any time during the day. Each stream has its own chat, so you can communicate with the speaker and with each other and also see some important announcement from the org team in this chat. But please note that speakers will not be able to see your questions to them in the chat during their talk. So if you want to ask your questions, feel free to join the special Q&A Zoom rooms. The links to these Zoom rooms you will also find at the user page. At these Zoom rooms, you can communicate with the speaker after their talk, ask the questions, unmute your video, audio, and communicate personally. Also, in the right part of the screen, you will find the information about our partners, the companies who supported this event this year and make it happen. Our partners has prepared a special interesting quizzes and raffles for you, so register for them and the winners will be announced at the closing ceremony today in the evening. Okay, we are glad that you're here and we are ready to start. I would like to invite to this virtual stage our first speaker today, Dr. Heinz Kabutz. Good morning.
Hello, how are you?
Hello, we are great. How are you?
I'm great. This is the third time I'm speaking in the Ukraine, and
Wow.
It's the second time I'm doing it virtually. So
Wow.
not the first time.
Yeah, where are you connecting from? I see a beautiful
I'm
landscape.
from Crete. I'm actually on the beach right now. I thought I'll quickly just get my camera up and and speak to you.
Yeah. Okay, thank you so much for supporting our event this year. So the mic is yours. Please start your talk.
All right, great. Thank you so much. I'm really looking forward to this. So, so we're going to look at thread safety, looking at 3 different parts of thread safety: phaser, stamped lock, and var handle. And I've got a Twitter feed which has lots of puzzles in it. And these puzzles hopefully will be interesting to those who are easily amused. And here's a question for you. In Java, which mechanisms of waiting are compatible with fibers in Project Loom? Of course, I tweeted this a while ago, and it's now called virtual threads. But the question remains the same. Which of these ways of waiting is compatible with Project Loom? You can either use wait, right, synchronized wait, or thread sleep, or thread.onSpin wait, which got the most votes, and an infinite loop, right? And I was doing a course for a company once, and they told me, Java's really slow. And whenever they're doing exercises, they kept on doing these spin loops, like the last one, the for infinite loop. And I said, well, Java's going to be slow if you're going to have spin loops running all over the time. And You can see now that democratic choice on technical questions is not always the best option, because the one that got least votes is actually the correct one, thread.sleep. Otherwise, you can't. They don't actually work together with Project Loom. So if you're interested, join me on my Twitter feed. I think you might find some fun bits there. So the first class we're going to look at is the phaser. Now the phaser is an interesting class. It is a class which is it's a little bit tricky to understand, but it's easy to use. Whereas other classes like countdown latch and cyclic barrier are easy to understand, but harder to use. And for example, with the phaser, you can change the number of parties over time, which you can't do with the countdown latch or the cyclic barrier. And you can, at any time, add new parties, take away parties. It's very flexible. You can also decide how many phases to go through, what to do once the phases are done, etc. What's also really interesting about the phaser is that it, from the beginning, was a managed blocker. Now that means when it's a managed blocker, it's compatible with the fork join pool. So you can pause, and if you don't have enough threads left inside the managed inside a fork join pool, it will actually construct new threads to keep the parallelism high. So this is a really nice little class. And I'm going to do a little demo. Let me sit down for that. It's easier to type sitting down. I've never managed to do what Venkat does, which is stand up and type. I can do it on my walking desk, but not like this. Not whilst I'm giving a talk here. So I'm going to do a demo, and the sources are available inside my GitHub repository. Look for the branch talks 2011-07 Devoxx Ukraine, and you'll get it all there. And so what I've done here is I've got a task, and the task measures how long it takes before the task actually starts. So I've got a joiner run, and the joiner is a way that we will coordinate for all the threads to start at the same time, and then I've got a task run that just does the task, which is going to be an empty task. And what we're interested in here is how close together do the threads actually start their task. So I've got a start time here, which is my system nano time, and so I'm just measuring what the time is when we all start, and then I compare how does the time compare across all the threads. And so this code is all available on my GitHub repository. If you're interested, fork it, have a look at it, and play around with it. And so the co-joiner has a method run waiter and run signaler. So for example, if I have a wait notify co-joiner, I would do something like this. This is now the old wait notify code. Nothing really new about that. We're going to make a private final object monitor, for example, equals new object. And then we're going to have a private, let's have a Boolean as well, ready equals false. And then inside here, we'll say synchronized monitor, and we'll say while not ready, monitor dot wait. So this is currently not compatible with Project Loom, but hopefully in the future it will be. And then the run signaler will signal that we've all arrived at the same time. And so this will wake everybody up and say, hey, come on, there's something to do here. And so this will be, here we will do the following. We'll say, again, synchronized monitor, and we'll say monitor, we'll first say ready equals true, and then monitor dot notify all. It wakes everybody up, and they say, oh, we're ready, great, let's get out of here. Now, when you write code like this, the first thing you'll notice, and this is something which is really frustrating to lots of programmers, is this interrupted exception. What are you supposed to do with that, right? So, oh man, okay, because actually what I want to do is I want to do an uninterruptible wait, which means if you interrupt me, I don't want to lose that information. I want to keep that information, but I also want to, I don't want to lose it, but I want to keep on waiting until I'm done with my wait, until ready equals true. So the way to do that is something like this. You're going to have a Boolean interrupted, and you reset your current interrupted status to be false, and that's what interrupted does as well. And then I'm going to surround this with here I'm going to make this inside like this, and then I'm going to say, so it's a whole bunch of extra code we need to do, try catch, and I'm going to say interrupted equals true. And then once I'm finished with my wait, I'm going to say, if I was interrupted, then I'm going to say thread.current thread.interrupt. We call this a self-interrupt. It's like sometimes when I speak, my thoughts interrupt me, you know. So that's what this does, self-interrupt. And you can see it's a fair bit of code to do this. Now, and what this will do is it will try and coordinate so that if I've got a bunch of threads, that they all start at roughly the same time. So all they say is run waiter, and then we say run signaler, say, hey, everybody, wake up. We are now starting our fun. And that's going to be inside our task tester. We're going to run this, and we're going to have 20,000 times do a test for a bit to see how this works and how close together these all start. So another one you could do is to do no waiting at all. To say, well, we're just going to randomly start. So there's no waiting, there's no coordination between the threads, and we would imagine that this would be pretty bad in terms of getting things to start at the same time. And I'll just do those two first, and then we'll do the other ones in a moment. So I'm going to comment out the ones which I don't want. So I'm just going to have none and just these two for now. So we'll say /star and // and we'll run that, and you'll see that sort of what results we get for the none cojoiner and for the wait notify cojoiner. Now, what the numbers tell you, the maximum is the maximum time between when the first thread started and when the last thread started. So the closer together they are, the better coordinated everything is. That's the max. And you can see here the max doesn't really seem to be that different between, okay, after the first one, you ignore the first demo. So it doesn't seem to be that different between, for example, the none cojoiner and the wait notify cojoiner. But if you look at the total adds up all the differences between all the runs between the start and the end, and in fact, all the other ones. So, and so here you can see a big difference, and actually, the wait notify is worse than doing nothing, right? So if you want to coordinate your start, you synchronize your watches, your wait notify is actually worse than just saying, well, just whatever happens, right? So this is how those two work. Let's do the volatile. No, in fact, let's do the countdown latch cojoiner first. So here I create a countdown latch, a private final countdown latch equals new countdown latch. Now I've got the values in the constants, how many I need. So it's going to be constants.parties. That's how many parties I'm going to have. And that actually I'm using the number of hardware threads divided by 2 minus 2. So it's going to be, on my machine I've got 8 cores. So it's going to be six parties all trying to start at roughly the same time and see how close together we start. And so the run waiter is going to do the following. We're going to say latch.await. Actually, you know what we can do to make it a bit easier? I'm going to just make it a countdown latch of 1, just to make it a bit easier. So I'll make countdown latch of 1. I'll say run waiter, latch.await, and run signal that says latch.countdown. So I'm just going to have one number I'm waiting for, and the waiter says, okay, we're all waiting for this one signal. So I'll use the parties in a little bit. Now, again, I've got to worry about this exception. So how do I make it to be not in an uninterruptible wait? Well, we have to do something like this again. We're going to have to say Boolean interrupted equals thread.interrupted. And then while true, we say latch.await. If we get interrupted, we say interrupted equals true, but we keep on waiting. If we ever manage to come out of wait without the exception, we're going to say return. That's how we exit from here. And then after we return, we're going to say, actually, no, they're not return, but break rather. Break. And then we can say, if we were interrupted, we're going to say thread.current current thread dot interrupt. We re-interrupt ourselves again in order to not lose that interrupted status. All right, so let's try that as well and see if that's any better than the wait notify and the none. And go back down here, and that's this one here. Get rid of that and put that there. So it's a count on latch joiner. Run that as well. And so this is all about coordination between multiple events. And you can see that the count on latch joiner isn't much better than the wait notify co-joiner. There's one thing which it does better than the wait notify, in that it is actually compatible with Project Loom. Sorry. So it's compatible with Project Loom, whereas the wait notify is not compatible with Project Loom at the moment. Maybe it will come in the future. So let's try one more, which is a volatile spin conjoiner. And here we're going to make simply a private volatile Boolean ready equals false. And here the threads are simply saying while not ready, and it is spinning. And here we say ready equals true, right? So they're just spinning like crazy. Is it ready? Is it ready? Okay, ready, go, let's go. Great. So this is how this one works. And let's try that. Oh, I also added to the test all as well. Let's put that in here. This is of course going to munch up my CPUs like crazy. I wonder if this audio system will work, if I was able to transmit to you. And you notice now that actually that one's the best so far, right? You're getting like 200 million versus the none, which is 500, and the other two, which is like 1.1 million. And these numbers are really important, the total. It's the total difference between all of them, the coordination. And so that's the first part, which is interesting. The other part, which is interesting, is to watch how easy it is to write the code. All right. So that's the volatile spin conjoiner. There's a thing you can do. You can say thread dot spin weight on spin weight. That's been there since Java 9, and I don't actually know what it does. I don't think it does anything at the moment. I think it does something on some architectures, but I've not managed to find a conclusive example where I really found a big difference. And I don't think this is really the use case for it. But the idea is to not completely kill your CPUs, but it doesn't show any difference on the demo. And then we've got the phaser. Now, this is the class we're talking about. And the phaser, we're going to say private final phaser, phaser equals new phaser. And here we're going to have the constants dot parties. So these are the total parties that we want to have together. And we're going to make it +1. You'll see why in a moment, why it's +1. The run wait will say phaser dot await arrive and await advance. That's going to wait. Now, what about interrupted exception? Well, all that saving of the interrupt until later is done internally. This is a more modern way of writing the code, and so this is a little bit better. And then run signaler is going to do the following. We're going to say phaser dot arrive and deregister is probably the best one to use. There are a whole bunch you could use, and that's what I'm saying. There are more options, and because there are more options, it's sometimes a bit more tricky to use. But overall, it should be better. So this is the final one, and we should see, if everything works well and correctly, we should see that the numbers are the closest together with the phaser, and it's easiest to achieve what you're trying to achieve with that. So let's try that again. That's the last demo. And we can see now that the numbers are, oh, look at that, 42 million. That's 27 million. Even the maximum is smaller, and all the numbers are much closer together. So there's a vast difference in the performance, and there's a vast difference in the ease of use. And it has a whole bunch of things you can do with it. There's one thing which phaser doesn't do very well, and that is it doesn't manage to you can only have 65,000 parties, right? And I can imagine when they wrote this when they wrote this class, they said, well, how many parties do we need? Well, what's a good reasonable maximum? They said, well, no one's going to have more than 10,000 threads. So why would we have more than that many virtual? Why would we have more than that parties? Just make a maximum of 65,000. No one's going to have 65,000 threads running at the same time. So we should be fine, right? And of course, now we've got Project Loom, and we had on our server 4 million threads running at the same time. And I tried to do some demo with some experiments with phaser, and I had to build a hierarchy of phases to make that work. So I mentioned that the phaser is a managed blocker, and that means that the fork join pool will be able to create additional threads if you block any of the threads using the phaser. And this used to be the only class in Java 7 that was a managed blocker, but they've extended that to a whole bunch of other ones now. Could be Complete Future. Java 14, they've actually done the abstract queued synchronizer, and that automatically gives you the reentrant lock, reentrant read write lock, counter latch, and semaphore on our automatically also managed blockers. So that's really good news. And in Project Loom, they've gone a bit further. They've also got the link transfer queue, the synchronous queue, and the selector import. So I've got a gift for you. So all of those listing live, it's only for those listing live. I've got a link for you. Click on that, tinyurl.com/dvx2020. And there you get a gift, but that gift expires at the end of the talk. So once you've got it, you get it for life, but you need to click on it now, otherwise you don't get it. So if you're watching the recording, next time come to my live talk. There you go. Set your alarm clocks and wake up early and come to my talk. There you go. I'll leave that link up so you can see it. All right. The next one I want to look at is the stamp block. And I think I'll stand up for this one again. And this is a Java 8 synchronizer. And it solves some problems that we had with other synchronizers. So if you've got a reentrant read write lock, for example, you can get starvation in certain circumstances. You also couldn't upgrade a read lock to a write lock. You could downgrade a write lock to read lock, but you couldn't upgrade a read lock to write lock. And so you couldn't do that. Also, with the reentrant read write lock, you can't. If you're busy reading, you will stop somebody else from being able to write at the same time. And this is a pessimistic read, which means we actually are stopping somebody else from making forward progress. The stamp block is not reentrant. That sometimes makes coding a bit more tricky. And the good use case for it is if you've got multiple fields and there's some invariant across these fields, and we want to enforce that invariant, so we don't break the invariant. If you've got a very simple class with just one field or multiple fields but no invariant across those fields, then using synchronize and maybe volatile for the fields is easier, and in many cases will be faster than using a stamp block. Another thing with a stamp block is that it allows you to do some very clever code, but the idioms are more difficult to master. You can, when you get a stamp block, when you lock it, you get back a number and you use the same number to unlock it again. And the one thing to realize there is that the stamp block doesn't remember who has locked it. So it doesn't have a map or something like that of the last person who locked it is this thread. That means you can actually split the locking and unlocking across between threads. So if you've got, for example, a resource that you want to lock, you can take a stamp block, lock it, take the stamp, keep it along with the resource, and then later you can unlock it again from another thread. So you can use it in a sort of asynchronous framework. This would actually work. All right. Now the stamp block is a very rich class, lots and lots of methods. And for example, you start with the method write lock. The write lock method returns a number, and it's a number which is never zero. Zero would mean that you couldn't lock it. So this will block until it achieves the lock. and the value is never 0. And then we also have a try convert to write lock. So if you've got a read lock, you can try convert to write lock. It might work, it might not work, but you can try. You can also unlock the write, and that checks that the stamp is for a write lock. Now, this is for write locks, and we call these the pessimistic exclusive locks. Pessimistic means if I'm writing, no one else is allowed to do anything. Exclusive means, and now I'll block others. Exclusive means that only one thread can use this at a time. So it's to be used for writing. And then we've got the read lock, and the read lock is again pessimistic, non-exclusive lock. So if I'm busy reading, no one else can write. Other threads can also read at the same time, but no one else can write at the same time. And I can say read lock, which gives me back a number which never 0. I can try and convert an existing lock, for example, a write lock to a read lock. That should always succeed. And I can unlock read, and I can say unlock, which will unlock either read or write, doesn't matter which one it is. So these are sort of the methods you would expect to see, and they're not that different in functionality to a normal read-write lock. And then there's this new one, the optimistic non-exclusive read. And what we do is we say, try optimistic read. It gives you back a number. This number might be 0 or not. It might be 0 if somebody else currently has a write lock. You'll get back 0. And then we've got a validate. The validate checks whether the stamp is still valid. In other words, I would get a read lock, get an optimistic read, get the number, get the stamp. Then I'd read the fields into local variables, and when I get to validate, if somebody else in the meantime has asked for a write lock, I need to assume that my date has been corrupted, and I'll have to read again or redo or something. So this is how you'd use it. Now, the idiom looks like this, and I'll go through it one line at a time. And this idiom here is actually from the original Java 8 document, and they have changed things a bit in Java 11. They've got a better idiom, which I will show you a little bit later, and I will also explain why the Java 11 idiom is a bit better. So here's optimistic read. The first thing we do is we try optimistic read. So we get a stamp, and we are being optimistic, so we're hoping that that's not 0. If it's 0, then somebody else is busy writing, and we maybe shouldn't actually even try, but I'm being optimistic here. So I'm then reading from the fields into local variables, into local fields. But we need to be very careful here, because sometimes if, for example, our fields are pointed to arrays, we could end up with an array index out of bounds exception if it changes halfway through my read. So you need to be very careful. We need to be aware that when we're reading, we're reading possibly dirty data. And it's okay to have dirty data, because at the end, we will simply redo it differently, but we don't want to cause an exception in the process. So here's my sl.validate stamp, and what I do is if somebody has written in the meantime, or if stamp was 0 to begin with, then I'm going to now do something else. So I then go and get a read lock, and the read lock is going to this is a pessimistic read. So it could be that what I've got is actually correct, but I'm assuming it's not correct. We want that to happen maximum 10% of the time. Maximum 10%. Ideally, less than 1% of the time should you have to go down to read lock. That should be fairly seldom occurrence that happens. So ideally, it should never happen. But if it happens, well, it should happen very seldomly. Definitely less than 10%. If it's more than 10%, you're better off most likely just doing read lock to begin with, or going to a different mechanism that is non-completely unshared data, thread local data. So now I read the state again into the local fields, and then I unlock the read, and then I process the data that I've just read. So there's my final code. Let's look at another example, actual example of this. And I live on the island of Crete, and this is the beach I run on every morning when I'm home, which is now, of course, all the time. And we've got lockdown from this morning, so if I want to go to the beach to go for a run, I think I'm allowed to. I'm not quite sure. I don't really want to test it, because if I get caught and I'm not supposed to do something, it's €300 fine. So I don't want to pay that. But I have to send an SMS to a special number and then wait for them to reply, and then I can go for my run. So not before that. And but we had this crocodile walking around Crete. Now imagine this tropical island. Well, and there's a crocodile walking around. And they try to catch this guy. They even gave him a name. They called him Cephas. It's a very common Cretan name. And they try to catch him. And eventually he died in the cold winter months, but they couldn't catch him. So imagine you're trying to walk from one place in Crete to another, and there's a lake in between, and there's Cephas the crocodile is in between from point one to point B. And so in other words, you want to go in a straight line past the crocodile pond, and you want to not end up as crocodile food. That's good. If you accidentally end up in the jaws of the crocodile, that's not so good. That's terrible, right? That's horrible. We don't want to be eaten. That's not so much fun. All right. So this is what we want to see. And that's bad. The first one's good, second one's bad. Now let's have a look at how we could refactor this position, or a normal position, to use stamp block. And before I start, I'm going to just run it to show you what it looks like before we go and start the refactoring. So let me quickly do that. And so put a slightly bigger. There we go. And good. So I'll check all this code in at the end of the talk, not right now. So here's my position, and at the moment, it's got an X and a Y. There's an invariant between X and Y. We know that. So that's something to be aware of. But at the moment, it's a synchronized for the move by and a synchronized distance from origin. So if we run this code with position test, if you run that, you'll see some interesting results here. Now you can see the distance from origin is called like 38 million times. Let's warm up a bit. Let's let it warm up. So the move, looking at about 5 million times. Whoa, this one was good, 24 million. It's getting warmed up a bit. I'm running this on Java. Which version of Java is this? It's Java 11. Let me just change that. I should have used it in Java. I'm going to use the most recent Java version because things have changed a bit. So let's go to Java 16. Let's do Java 16, and I'll just do the SDK default. Let's try that. I'm going to run it again with Java 16. And we'll see. All right. Now, what these numbers mean are the following. The first thing is how many times I called it within 1 second. So the move, you're looking at about 20 million times. And that looks pretty consistent. The distance from origin is between 35 and 40 million times in 1 second. Now, what this is over here, this is compute time over elapsed time. That's user time over elapsed time. This is system time over elapsed time. And the system time is what you'll notice in your CPU graph as being the red bits. So that's the red bit. Well, if you set it to be red, I don't know if it's red. And it's a bit hard to see on this machine because I'm also running the screen sharing software and the video broadcasting, all of that at the same time. But that's what this is. And so here you can notice I'm spending about 14%, 70%, 20%, 25% in system time. So it's a big chunk of time. The best values were these, 22 and 42 million, and the worst times were 10 million and 33 million. So that's the best and the worst of times. And a lot of time was spent in system time. So we'll put in these values. Synchronized would simply be this. All right. And now we're going to do the same thing, but with a stamp lock. So we're going to say the following. We're going to say, instead of synchronize, we're going to say, make a stamp lock up here. So it's private final stamped lock SL equals new stamped lock. There you go. And then inside the move by, we need to simply say long stamp equals SL dot write lock, because it's an exclusive lock. Then try, and finally SL dot unlock write of the stamp. Now, I know we could just just leave out the try finally, but I think it's good to put it in because you just never know where in your code you might get some very strange exceptions happening, and so let's rather put it in just to be sure. And then the second one is distance from origin. This is we're trying to work out where we are, and here we need to have a double current x comma current y. All right, and what we want to do is to get a stamp. Long stamp equals SL dot optimistic read. We then read into the current x and the current y, and then we say if not stamp dot validate SL dot validate the stamp. If somebody has written, or if it was 0 to begin with, then we go and we read it again. So we need, but now we're going to do it inside a read lock. So I'm going to just copy and paste this code. Oh man, that was stupid. Okay, make it a stamp equals dot read lock and dot unlock read. All right, and then here we're going to read current x equals x and current y equals y. So that's how we're reading it again. And then when we use a hypotenuse, we're going to say current x comma current y. So this is from origin, and I'm always nervous running this code because even without doing anything, you can see how much my system time is, because I'm doing the screen sharing and all the other stuff. And this demo might not work too well. I'm always sort of making excuses before I even start. Let's try it out. But our system time should be quite a bit less on both of them. So you can see that the system time on the move, for example, is down to 3%. Distance from origin is also like 3-4%. So it's gone down by 10%. Well, it's gone down not by 10%, but from like 25% down to like 5%. So that's quite good. That's quite good. And we might also get better performance here. But as I said, it's really difficult to do that type of a demo here whilst I'm busy showing you this. You'll have to try it out yourself. So this is with the stamp lock, and the distance from origin is actually slightly worse here. And what can happen is that you have too many times that we fail the read lock. Now, if we had more time, we would go into this and we would count how many times have we actually failed, and how many times, and maybe retry a few times to do the reading. All right, so this is how you could do it. I'm going to check this in what I've done so far, code so far. And the reason is that I'm going to make another change in a moment. Now, there's something which smells bad about this distance from origin. And what smells bad is that it actually, I'm reading the values twice. First I'm reading them over here, and then later I'm reading them again once I've gone past it. And that's a little bit smelly, because you don't want to have the same logic in multiple places. And then something else which smells is that the reading and the actual action has a big disjoint. There's a lot of code in between that. And it's like you're reading it here, using it down here. And it's better to have code that belongs together, to be close together, not all over the place. So in Java 11, there's a new idiom that they put into stamp block. It looks like this. And instead of writing it like we did before, we try optimistic read, we get the stamp. We then have a labeled break here, retry holding lock. And then we have a for loop, infinite loop, right? But the next step is to say stamp equals sl.readlock. So they're basically 3 different routes through this code. The first route is you call stamp and it's equal to 0, all right? So somebody else is busy writing. You go in here, the stamp is 0, so you continue retry lock. So you simply go back to the for loop. You now get the read lock and you continue, right? So then you've got the read lock, you can get the state, validate will always be true because it's the read lock, and then you'll go to the finally, and if stamp lock is read lock stamp will be true, and you simply unlock again. So that's the first route through, is that the stamp is 0 to begin with. The second route through is the stamp is not 0 to begin with. Now, it's not 0, the stamp is 0, is not 0, so you read the state into the current state, but in between all this, somebody else is writing. So somebody else has written or has gotten the write lock, so by the time you get to validate, it's no longer it's no longer actually valid, and this is false. So we continue retry lock, we jump back to the for loop, get the read lock, and now try again, same as the previous one. And the third possibility is that you get the stamp, it's not 0, everything works fine, you get here, it validates perfectly, so no one has asked for the write lock in the meantime, and you then simply process that value. And we're done. We don't unlock it because it wasn't actually locked. So there are 3 options. Now, when I first saw this algorithm, my hair burst into flames. I was like, what? What are they doing? Come on, this is not Java. This is worse than C. This is like basic. I used to write when I was in school. Come on, this is terrible. Go to 1. Come on, what is going on here? But it's a bit ugly. But there's an interesting thing, and that's you've got the reading of the state in one place, not 2 places, one place, and it's really close to the process method. So I actually like this. The only thing I would probably change after doing some performance tests is to take away the first if stamp equals 0. And the reason why is that we're being optimistic, right? And the less code you've got in between the try optimistic read and the validate, the less code you've got in between there, the better your chances for winning the race, and therefore you normally have better probabilities and you better performance as well. So that's what I would do differently. Otherwise, I think it's quite cute. So let's do that again. And I'm going to try to this. Oh, sorry, that link is wrong. That's supposed to be this other link. Oh, that's also wrong. John, we made a mistake. I've got my one friend, and we were looking at this last night, and the links are the branches are the wrong ones. But I think you're smart enough to figure out what the branches are supposed to be. That we're not in Peru, we're in the Ukraine, right? So just remember that. All right. So let's have a look at that, at refactoring that, and we'll see how that works. And here's how we'll do it. I'm going to just copy and paste this. I'll call this Java 8. And now this is the more modern way. And we want to, first of all, we start by saying long stamp equals sl.try optimistic read, and then try, and finally, if sl dot is read locked, I think there's, how did I do this now? I can't remember. Yeah, that's right. Oh, you can also say stamp lock dot is, I did that way as well. Stamp lock dot is read lock stamp, then sl dot unlock read of the stamp. That's sort of the classical approach here. And then I put my retry what do you call it, retry holding lock. That's here, and we have our for loop. And what we do is we say stamp equals sl.readlock, right? And then if you want to, I don't think you need it, but if you want to, here you could say if you would first see if sl dot or if stamp is 0, then continue retry holding lock. As I said, I don't do this. I don't do that normally. So that's what you don't need that one. But then you then afterwards you then do the possibly racy reads where you do double current x equals x and current y equals y. But then afterwards you say if not sl.validate of the stamp, you'd continue with the retry holding lock. Otherwise, you would say return math.hypotenuse of current x comma current y. So this is how you do it. This is the other algorithm that you'd use, and you'll find the performance is going to be very similar to the other one, except that the difference is that the actual structure of the code is a bit better, despite the label, a bit better. And you can, of course, with this structure, it's quite easy to incorporate retries as well into the code. Right. In fact, distance origin seems a bit faster, so that's good. You're getting better performance, but that could just be random. It could just be random because I'm doing all this other stuff in the machine as well. It's not a quiet system. All right, so that's the stamp lock, and I believe I've got a room afterwards. We can have more discussions about this if you've got questions. Another little structure we've got, which has been around since Java 9, is the var handle, and this allows us to do additional clever code using compare swap and compare set. And compare set is really tries to change a field, and if it's able to, it returns true. Whereas compare and exchange is a classical compare and swap, which returns the value that was there. So we could also use that for our position. So let's try that as well. And how do we do? We did not too badly. That wasn't too bad. So this is now the new version. But as I said, I'm not going to give too much credence to this because, well, actually the move by worst is the same, and the distance by origin, okay, the worst is a bit, no, it's actually, the best is better. No, both are better. So distance is a bit better. Seems to be, but that could really just be complete fluke because there's a bunch of other stuff happening on my machine, so I can't really test only that. It's just a demo. Let's have a look at how this would work. So this is now our position again. And if I wanted to do it with a var handle, I would need to create a var handle to be able to change XY. But we can't change XY together because these are two different fields. So I would have to do something like this where I make an array out of XY equals, and then I would say inside here, I would say XY equals new double array of X comma Y. All right? So that's how I would create it. I'd also make it volatile. And then the move by would have to try and write it. And if it's able to, that's great. Otherwise, you'd have to just try again until it's successful. So we're going to do this. We're going to say double array current comma next. And we always need to create a new array for what's coming next. So that's going to be just a new array of size 2. And then we're going to say do. And we're going to say next, first of all, double array or current equals xy. So read the current value into current. And we're going to say next 0 equals current plus delta x. And what have I done wrong? Current 0 plus delta x. And next 1 equals current 1 plus delta y. That's how I change the state. and then I'm going to try and write that into the fields. I'm going to do while it's not successful, I keep on trying. So while now I need my var handle. So the var handle, imagine you had it's a bit like an atomic reference, but it's a bit different. So here we're going to make a private static final var handle xy. It's normally the capitals of the field, and you initialize like this. You say xy equals method handles dot lookup dot find var handle for class position dot class, and the name is going to be xy, and the type is going to be double array dot class, and that's how we create our var handle. But of course, that could throw an exception, so we're going to do a try catch on that, and if any exception occurs, any reflective operation exception, we're going to simply say throw new error e, because we know that that field is inside here, so it can't possibly not work. It has to work, right? So then we're going to say xy dot compensate on this. We're expecting that the value of xy is still equal to current. We're going to set it to next. If it works, great. Otherwise, simply try again. That's moved by a bit more work, but it should be better in many cases. Then the distance from origin is really easy. We simply say double array current equals xy. So read the point into local variable, and then we say hypotenuse of current 0, comma current 1. All right. And now we run that position test, and we can compare that to the stamp block. And many cases will be better. So let's see. That's going to run nicely. Chuck, chuck, chuck. The system time on the distance of origin is almost nothing. It's like 1%. That's very, very little. And you can see that the distance from origin is pretty good. I would actually thought it would be better, but sometimes I get disappointed. But anyway, it's good. It's very consistent. The move is better, and the distance from origin is better too. Look at that. Look at these values. These are fantastic values. So that's great stuff. This is with the position. I think actually what's starting to dominate is now not the axis in the fields, but the hypotenuse. That might be what's slowing us down. So there we go. It's always good when your bottleneck goes away. There's also a compare and exchange. It's a bit more complex. I'm going to skip this part. It might be faster, it might be slower than using compare and set, but this is how you would do it. So yeah, I said I'm going to be around for a bit. If you have any questions, pop them into YouTube, I guess, and ask them there. But don't forget to get your gift, because this gift goes away once the show is over. When the show is over, then there's no more gift, and that'll be a great pity if you miss it. I've got a newsletter called Java Specialist Newsletter, and I've been writing that for close to 20 years, and it feels like I've written one every month, but it's not true. I've missed quite a few months actually. I realized I missed about 45 months, which it's like I missed like 4 years of writing in total. But I've written sometimes more than one per month, so that's also something which you need to put into that account. So it's many. It's over 300 in total that I've written, and yeah, that's it from me.
Thank you, Hans, so much for your talk. And dear participants, please join the Q&A Zoom room with Heinz and ask your questions. And as you mentioned, yeah, the coupon is valid 1 more minute, so don't miss your chance.
Is it 1 more minute? Okay, there we go.
Yeah. While we see your slide, 1 more minute. Yeah, and please join the Q&A Zoom room and ask your questions to Heinz just in a minute. Thank you so much for supporting Java Devoxx Ukraine online. Thank you. Yeah, dear participants, and in a minute we will have a presentation from our gold partner, NX company.
Since 2002, NX has been a trusted software development partner for global industry leaders and Fortune 500 companies. NX offers expert solutions in cloud computing, data analytics, machine learning, business intelligence, IoT, and other tech domains covering various sectors, including fintech, telecom, media, healthcare, manufacturing, and more. Numerous industry rankings recognize the company, such as Global Outsourcing 100, Inc. 5000, CRN Fast Growth, Clutch, and Good Firms. Also, NX is a place for professional growth and exciting career opportunities for more than 1,100 experts. The company hires talent remotely across Ukraine and offers a flexible work format to choose between office-based, flexible, and fully remote work. NX is one of the most active employers in Ukraine, according to Dole, as it constantly has around 100 open positions. Join NX. Grow your career with one of the fastest-growing IT companies by your side.
Hello, we are glad to welcome our gold partner NX company and its representative Maxim Polomarenko, Director of Software Development Office. Hello, Maxim.
Hi, nice to meet you. Hi, everyone.
Nice to meet you.
So I'm happy to be at the conference and have a chance to talk to you, share information about our career growth and opportunities at NX. But as I was asked by organizers, just a quick reminder that we are also having a contest and this beautiful toy. So while I'm speaking, you still have a chance to register in your personal cabinet and maybe win this nice prize. So a few words about our company. So today NX is one of the fastest growing IT companies in Europe. Between 2016 and 2019, we grew by 330% and reached 1,000 professionals. In 2020, despite the worsening business climate, we still keep growing and reached 1,100 people. NX has also formed a strategic partnership with a variety of global industry leaders, including such recognized names as Libara, Currency Cloud, Fluke Corporation, GoGo, TuneIn, several Fortune 500 companies, and over 100 medium large-scale businesses. Only small number of them are currently on this slide. And we hire talents remotely across Ukraine and the world. The company has 7 offices in EU and United States. In Ukraine, we have 2 large offices in Lviv and Kyiv. And for those who used to work office-based, now we have a new system of working, and it proved to work. This flexible working schedule, office-based for those who work 4 days and more and have dedicated place, flexible with shared place, and fully remote for those who enjoy working from home and still have benefits of all company services attached to them. Also, we are building NX hubs across Ukraine, uniting our communities in the cities where we are represented. Our vision for the future is to have 1-floor office space in 5 cities instead of 5 floors in 1 city. So we are starting with Dnipro, Vinnytsia, Zaporizhzhia, Odessa, and going to be represented in other cities of Ukraine, where our community really grows. A few words on how the professional growth is working in our company. I am the man to talk about it because we are responsible for the experience of engineers and the company. So it all starts from the day one when the engineer enters the company already having assigned the level after the interview, and he or she starts to learn career opportunities. Then they choose core competence from the profiles available, and all the profiles are deeply described within our competence model. They set up their career targets to level up and have the tools for instant and qualified feedbacks. These are performance appraisals from their teams and on-demand technical evaluations, which are conducted by our specialized expert trained for these purposes. The expert goes through the whole detailed competence model and gives feedback on any gaps found out, and also mentions the ways to cover those gaps to speed up growth. And we have lots of tools to speed up that growth. So these are personal development plans, competence model with the links to the best resources to learn new technologies. Also, trainings and mentorships available here, as well as external certifications, which we fully support from global vendors and providers. Those who receive promotions, they actually not only promoted by technological level, but we also invest heavily in leadership skills, because with the new opportunities goes some additional responsibilities. So leadership skills is something our engineers also gain with each level up. And once they are promoted, they have opportunity to share their successful experience with internal tech talk platform. Also, they contribute to expert services, the same mentorship, expert networks, and also they may participate in R&D, pre-sales, and many other opportunities. That's all works on demand. Going back to Java community at NX, we have quite a few people from Java crowd here. So about 100 engineers by my latest calculations, and this includes web development, backend development, as well as Android. And they are spread across, I think, more than 50 projects with which have some kind of Java technologies. To name a few prominent names of those projects is a Fluke electronic test tools manufacturer, and they have very interesting technologies there with microservices, microkernels, as well as hexagonal architecture, and they integrate with PLC, SCADA devices, IoT, enterprise mobility. Very interesting tasks and challenges that they solve. Also, I can name Libara, a well-known British telecom, which we have about 12 agile teams working on, and some of them are Java directed. They develop a range of very different solutions, starting from Hybris CMS and also including very complex and challenging integration tasks with messaging payment solutions across different countries of Europe. And to name another prominent name, this is TuneIn, audio streaming platform. Probably you use it also. And our Java team is working with high-load APIs there. So that's definitely interesting to work with our Java projects. But we not only work, we also have fun. So we still have team buildings despite we keep social distance from each other. For example, in August we had company day online. Each of us received small packages with gifts and had an opportunity to raise a glass of wine, beer, or any other drink and stare at eyes of hundreds others simultaneously celebrating online. This was a new and very exciting experience. And we are one of the most active employers in Ukraine, according to the DOE, and we constantly have around 100 open positions. About 20 of them are in Java direction, so stay tuned. And check out our career website to find something interesting for you. Also, you can recommend your friend for an open position at the company and get bonus. All our hot vacancies have special referral bonus or referral bonus labels. And thank you for your attention. Visit our social media channels. Find out more about our lives, work, and here you can see and use the links about our Java NX communities and hear what people say about Java here and the company. So thank you very much and have a great days here at the conference.
Thank you, Maxim, and thank you once again, NX company, for supporting Devoxx Ukraine Online this year. Yeah, and dear participants, I just remind once again to register for the prize raffle from NX and be the lucky ones to win their special prizes. Okay, and we are back and ready to continue Devoxx Ukraine Online. Welcome our second speaker, Jarek Ratajski, connecting from Switzerland.
Hello, hello.
Hello, good morning, Jarek.
Morning.
Morning, how are you today?
I'm great, and how are you? How is everybody?
Oh, we are so excited that we started the second day of the conference, and thank you so much for supporting our event and agreeing to give even 2 talks, not 1 but 2 talks. So what's the topic you're going to present now?
As the title is a transaction is a monad, and it's basically just the functional programming in enterprise applications.
Okay. Okay, the mic is yours then. Please start.
Okay, so hello everybody. I hope you see my screen. So that's my talk. Transaction is a monad. Just and yeah, it's really a pity I am not there in Kiev like last year. I really had a great time there. So yeah, but the time is as it is, 2020. Thank you for that. Not really, but yeah. So transaction is a monad. Well, but before I get into the details, a little bit of myself, very little. I live in Switzerland exactly, and right now here, yeah, again, I would rather be in Kiev, but yeah. And I'm software developer. I call myself sometimes wizard because this wizard is more for being a necromancer, keeping alive old system that should be already dead or actually are dead, but they don't know, nobody realized. And I call myself an architect. I work for Ingenious GmbH, a small company where we are doing stuff, consulting in banking and insurances and companies like that. Okay. My talk today will start with happiness. Okay. So why? Because as a developer, I like actually my job because it's a lot of fun. And for me, it's kind of like the same experience I had in the past with, I don't know, in a kindergarten when building castles of small blocks, designing, creation. That's a lot of joy. And I think most of you as developers have this, understand this pleasure. That's really a thing, yeah? That's why we like to spend so many hours in front of our computers. We like this pleasure. And then happens that you have this picture in mind, how great system you build. You put yet another block onto this, and everything starts to fall apart. Yeah, it just happens. Yeah, and then you get into the start race, which is longer than even the recent elections in USA, and you just go and you couldn't find where is this problem actually now the joy is slowly disappearing, evaporating. And then you even maybe see the reason of a problem, but it looks like this: class cut exception, data source DT cannot be cast to data source DT. Oh, well, that's really helpful. Yeah. So, and we start to wonder, and we obviously sometimes the fixing of a problem is actually a challenge, and I don't know how many, but I actually love challenges. But not when there is too much. Not when every step I do, I get deeper into the swamp, and I go slower. That's what I don't really like. I think most of you don't like it. And I remember seeing the developers just talking. They would rather be septic tank cleaners or do some, I don't know, the real garbage collectors, on the streets than doing their job, because that's even now sounds nicer. How can it happen that such a wonderful job becomes a nightmare? So I still remember my good old times, my first Commodore 64 computer, when everything was so much simpler. I was really horrible developer at the time. I was young, I was learning, but the things I was creating were way simpler. And the tools were horrible, but simple. Everything was so easy to understand, exactly like those blocks. So programs were short. Unfortunately, this world is gone. Even though we have better tools and we have better computers, the complexity of the things we build is unscalable, not comparable, harder, bigger. It's not even the same world as Commodore 64 or 80s or 90s. We have tons of dependencies, layers, really complex domains, and you can no longer just do this: print a code, on paper, and just go through this code and find a bug, which was sometimes really funny. And it's just not doable anymore. And the problem is, so how to not have these problems? How to not being forced to spend hours on debugging productive incidents? That's the thing most of people in our industry trying to solve. What can we do with that? So, and constantly I hear from people that we just have to be more careful. And then I have this picture in my mind, developers in a lab carefully developing, this one line by line, everything perfectly clean. How cool would that be? And they say you have just to be careful. It's just with every line you write. And I say no. That's not the way. That's not actually what I want to do. Not that I like dirt so much. I just know the reality. And reality is that I know that, do I like it or not? Sometimes I write really critical code when I'm not fresh, because I was just fighting 12 hours with something else. And, then we have someone to help me or someone else with a review. But this guy was also doing 10 big PRs in last 10 hours. So it doesn't really help. And then there are testers that check if the code works on some test environment. And because deadline is coming, then everything goes. And then we have even tools. It's incredible how many companies have invested in tools like Sonar or other quality checking tools. And they completely ignore that those tools always show that everything is red and more red and even more red than that, like infrared. It's just that everyone got used to that. Because at the end you have the boss telling, exactly, that's the time, you have to concentrate on quality, because we have demo in 1 hour. Okay. So my idea, and tons of people, is because the world is like it is, maybe we need to have better tools. Maybe we have to make a computer our reviewer. Maybe computer has to take more of these responsibilities, especially for repetitive tasks. And that's actually why functional programming is so popular now, because it solves some of this problem. Not all, but some of them. Because it helps with, for instance, local reasoning. What is the local reasoning? If you don't know this, it's basically, as a humans, we are very bad and juggling in mind with too many details. We want to have like a small amount of elements we are thinking about. So for instance, in this piece of the code that I am presenting now, we have some array list, which just add few elements to this, and then we calculate average at the end. And funny, on a production, the average was 10.5. If the local reasoning works, you know that the error must be in calc average function, because it takes some input, these values, from array list, something must be broken there. So you get there, it's a simple code, and actually you realize, oh, it looks valid to me. And then you test it, and it actually works as expected. So then you realize, oh my God, because this is a mutable list, and you just passed it to some other thread, which is sometimes randomly doing some changes and adding stuff, and now your local reasoning doesn't work. So in order to solve this problem now, instead of getting to one function, you have to go through like hundreds of lines of code, and your life is misery. We don't like it. So that's how many of us has learned to not mutate. And that's how in the past we learned other things that we shouldn't do. They work on a small scale, but when we have more and more complex problems to solve, they are horrible tools. And you cannot be just careful enough. That's, for instance, how most of us stopped using GoTo. I still remember this moment when when I read this article. That wasn't really original article, but something else in the press that GoTo is a code smell. And at that time I was basically basic and assembly coder. And okay, in assembly GoTo is just jump. And I couldn't understand, like, how this is my basic building block. How can you even code without it? But then there was like even people saying, no, when you are careful, GoTo is a cool thing. No, because you are not careful. You won't be careful. You won't be fresh always when you write the code. Don't use that. So the same thing later, I was like C programmer. I still remember that time. And I slowly learned that I need something like encapsulation, because I'm not always writing code when I can just carefully look at each line. I need some restrictions, constraints, encapsulation. That's how I get, how to say that? I was tricked to use object-oriented programming. I liked it. It worked for me for years. It still works, yeah, to some extent. Encapsulation and stuff like that. That's a cool thing. Although actually this is not only about object-oriented programming, but basically that was a lesson. You just don't manipulate everything. And then this is like, there were many things I learned to actually not do. But that's, let's say, recent years. Don't mutate. Because if you are careful, if you have time, it works. But if you do it on a scale, it's a problem. So last but not least, of course, we learned to do tests. And we have not unlearned yet to not write tests, but I will maybe address this. And tests are helping us. It's the additional job we do, but tests allow me to be less careful. That's a cool thing, actually. So in a JVM world, we are still way more lucky than JavaScript developers or PHP developers, because we have static types. We have type system that help us in not making stupid mistakes, like putting string where a function expects integer and stuff like that. This is a cool thing, and we are so used to that in Java that we underestimate it. Typically, we have this encapsulation. Tests are popular, and that's what I see in code. Slowly, we use more and more immutability. For instance, a lot of Java developers switch to Kotlin, which allows you to make immutable classes easier, have some immutable collections. So some of Java developers switch to immutable collections from Vavr, really great library. And that's a huge progress I see. The problem is, now there is a next step to make. Because and that's a lot of my talks are about, we have fantastic frameworks that actually are a problem. Why they are a problem? They are partially trying to solve the same thing as functional programming. That we concentrate on a business logic, on less stuff, and a lot of infrastructure work is done behind. We don't see it, we just concentrate on business. The problem is the way the fantastic frameworks, mainstream frameworks in Java are done, because they use a lot of things from runtime magic, manipulation of classes, and this leads to strange problems. And yesterday there was a talk about it, for instance, on this conference about JPA. So let me present you, for instance, typical small problem in JPA. So you have this entity group, one-to-many users, then you have method get users. What can go wrong here? So you have another method, business method somewhere, that takes a group, this entity, then calls get users, then does something for these users. What can go wrong here? If you don't know, let me introduce you to something called lazy initialization exception. Now you probably remember this moment when you had this like, yeah, get users. Maybe no one called it before. Maybe it's lazy and I am now, after the transaction is finished, or I am even in a different thread, or someone called parallel stream. And some people say, oh, who would be that stupid to call parallel stream when you deal with JPA? Yeah, you know, it's like when our mainstream frameworks forbid us to use threads, then what they do even do in year 2020 when we have such nice tools. It's like something went wrong here, obviously. And I haven't even started on Jakarta or Spring. But basically all of these problems come from, yeah, the idea was good initially. Like the let's write clean business logic and have infrastructure in behind, don't care about it, make it automatically by a computer. The problem is it happens in a runtime in a very fragile way. And a way that it's hard to analyze. For instance, I love this. When you have two annotations like cached and secured on a method, what is actually first? First is caching or first is security? Because maybe the admin will log in and value he sees will be cached and displayed for all the other users. Yeah. And by the way, this you can find in documentations and in code what's actually the real order of this, but it takes a lot of effort. It's actually where local reasoning is broken. And every time you have some combinations like this and you start to wonder what is actually happening, you have a problem because, yeah, you have to rely. It's probably done in a correct way. If you want to check it, there is a lot of code to go through. That's basically a problem of leaking abstraction, yeah. Now the question that some of people state is, can we even code with all this runtime magic really on production and still be efficient? My answer is that we basically must. And the thing is that, now my trick, I was doing code in Scala before. I was doing even some code in Haskell, although in Haskell not really productive. And I realized in these worlds, you just don't use magic and still everything works. So Scala actually works on JVM. So why can't we use the same toys from Scala that are basically happening on a compilation level and reuse them in our Java or Kotlin projects, yeah? So, for instance, some people say, oh, you need a framework in order to just do simple REST services. That's how you actually write simple REST service without a framework. This is something I would rather call the library or a tool. So Javelin in that particular case, there are many of similar. Just 2 lines of code, public static void main, no class path scanning, no magic, and you have REST service. Oh, this time very simple, but you can create as complex as you want with WebSockets and all that stuff that it's needed. Yeah, and it works without magic, and it starts in a second, or even less. Yeah, depends how fast it's your machine. This is really cool, and we have alternative frameworks. I'm glad I won't cover it today because I want to show some more abstract approach. It's the same with DB transactions. So I still remember this moment when it happens to me. I say that I don't use any major frameworks to control database transaction. And then everyone's reaction is, yo, so you write a lot of this code, and that like everyone thinks like I'm doing like connecting to database with a connection string, starting a statement, like prepare statement, setting auto commit to false, blah, blah. Then in case of exception, I'm doing rollback or commit. No, even 20 years ago when I first learned JDBC, I wasn't coding like that. Because I already was a developer, let's say, with a couple of years of experience, almost 10, I knew that repeating the code is not a good idea. And even at Java 1.2, there were tools to solve this problem of repeating this code. Yeah. Today, we can solve it even more efficient way because we have lambdas. So for instance, that's a thing that actually is coded in JOQ library, which I do love as an alternative to, for instance, JPA, because it's not leaking that much. I have never actually, I don't even see where it leaks. So basically it means that it's a really solid, stable, doesn't depend on any runtime magic. If you want to have a transaction, then I pass this lambda, which takes a database connection, does the stuff, returns a value. And there is a special method called transaction, which basically handles this lambda. It opens transaction for me, closes, does commit, and all that stuff. I don't have this code. I don't repeat this code. It's there in this function, which is a function that takes a function that takes lambda, something we in Java world get used to with a starting of Java 8 with lambdas, but it's been there for a while. We can even do more next step, but if you have two functions, we can compose them and have other functions. I will show you in a minute how it works. Funny thing is that this was known in object-oriented programming as a couple of design patterns, like strategy, decorate, template method. Nowadays, you can forget about these patterns, these particle ones. All of them are just instances. They are examples of higher order function that takes function. Why would you learn so many different ideas where all of them can be described by one more generic concept? That's it. So that's how cool it is. So for instance, you want a security. Then you create this function, secured, that takes a function from request to some t, and then has a second argument, a role that has to be checked. Then what I do, I simply get user from header and check if it has a role. And then finally, I call the original function. But look at this. I don't really do it here. I return a function. So it's kind of a lazy now. I just say, if I am having this function that just does a business logic from request to t, I pack it and give you back a function that does this plus checking of security. And now this happens, let's say, with the help of a compiler without any magic. Yeah. So I have function that takes a function, returns other function. Because maybe I will have another thing that takes a function, again, that does something on a request and return t, and returns other function, but this time with caching. If the query strings are the same arguments, then I will use the pre-calculated value. For instance, here I'm, let's say, pretending that I'm using caffeine cache. Yeah, it would look like this. And then finally, if I'm building with this library like Javelin, my REST service, I just put here my code, and then instead of writing annotation, I just use function calls, cache and security. It returns me the function that actually has both of them, this security and cache. And I even see in which order, and it's easy to debug, and no magic is involved. And in case something fails, you can easily debug the stuff, because the problem, for instance, is not somewhere in bytecode manipulation, which is hard to really debug. And if you test it, you actually test the same code that runs on production. You maybe do that with a, I don't know, in-memory database or something. But it's a really cool thing. So the problem is, it's not a solution to everything. By the way, this is more my, let's say, level how I do stuff on production right now, and more or less people understand that. But not always we have this HTTP request in a context. And for instance, maybe you want to build something more generic, that we have a service and get user data, and now we just don't want to create a function that takes HTTP requests something. I want to have this more generic. Then there may be a solution would be to create something like abstract user context, which would be like, or security context or something like that. And so that on a web layer, it would be HTTP request. On a service layer, it would be something which has just user inside, etc. That is an approach that works. And you can do that. People do that. But it has some limitation. There will be a moment when you build a bigger project, you will start to fight with compilation error, which, by the way, is still better than have runtime errors. So when compiler shows you an error, it's not your enemy. It's actually your friend saying you are trying to do something wrong. And I now stopped you, and I will help you present this error so that you don't put error on the production. It's really your friend. The problem is sometimes you are really, you have enough of these helpful messages that are sometimes a couple of screens long. You want to use something that doesn't involve so much thinking about types and function, etc. So funny thing is that this thing is called a monad. Yeah, that was a trap. This is the moment where I started to talk about monads. And I started with, because I assume that tons of you don't still know what a monad is. So this will be like now 5 minutes or maybe a little bit more about what a monad is, just by example. So you'll probably remember this piece of a code that you can find in the system. User service get user from DB, user get group, group get owner, etc. And then send a message to the owner of group that user is doing something wrong. The problem is this code actually should be commented that on any step there is some implicit side effect, and maybe null, maybe exception, something can happen. So if you want to write this code in a secure way, you would have to do a lot of null checks, which is, by the way, completely stupid. Now the code is even more complex than at the beginning. So maybe it's now more secure, but oh, come on, you don't want to read this code. It's just it's messing the business logic with some infrastructure problems. So is the way, of course, you already should know it, that there is a way to that. We just rewrite original function, not get user from DB returning user, but returning optional of user. And we do that with all the other functions. So that's the typical code you get. After that, you just replace if with is present. And some people, I hope, yesterday there was a talk about it. It's not really that great. It's already better than it was before, because now the problem is explicit and compiler is helping you. Compiler is exactly now showing you where you need this if, or where if you consequently use optional, where you don't have to spoil your code with if checking, null checking, let's say. So this is a step better, but this is just not smart. In order to be smart, you must learn that optional has this operation map that allows you to manipulate the thing inside, and I hope most of you know. But actually the real operation is that you are looking for is not map, because map in that case will lead you to something like optional or optional group on a step 2, and then you would have optional of user, which would be really horrible to work with. So the solution for that is that there is a second method called flat map that allows you to stay on one level of monad. So if when the map would lead to optional of optional something, you just use flat map and you have just one level of optional. How cool it is, yeah? And then your code can look like this. And now all these if checks are actually now inside. This is an infrastructure now. The ifs are inside of optional code, but it's all there without magic. That's awesome. So optional is kind of a side effect, and I have shown you the power of monads. By the way, maybe you wanted to describe what can go wrong. Not that just user doesn't exist, but doesn't exist because, yeah? And nowadays, tons of people would use exceptions, but why not use other monad, this time called either? By the way, this is, for instance, included in a Wave package, which this monad has either user.thing you want to, but in case the user doesn't exist, it shows what went wrong. By the way, you don't not only you can use it for errors, but basically that's typical use. So either your object or description what went wrong. Funny, if you do that, your code would look more or less the same. With the small difference that now at the end, here it's not in the code, but instead of try catch, you could basically check if that there was actually performed, but maybe there was error, and what kind of error was that, and display it. This is really cool. So formal definition of monad I will skip. That doesn't help at all if you are learning. Definition of by code is quite simple: flat map and off. So basically monad plus some loads. But we don't have enough time to discuss that. But if you see flat map, that basically shows you, oh, you have a monad. Probably. It should behave correctly. By the way, not all monads in JDK, like optional, is a little bit broken, but we don't cover that. It's more or less good enough to be treated as monad. Now, what a monad is by comparison, like some people say metaphors are horrible, but I like this metaphor. I remember if you are scared by monad word, M word, I was once scared by container word. That was at the time I was learning C++, and there was some idea of containers. At the end, it appeared to be quite simple. When I have list, vectors, sets, array list, whatever, those are all containers. So I have some type like a string, and then I have some container for this type. That's how I describe that, because I don't care how it's actually organized in memory, linked list, array list, whatever, or set. The important part is that is something above my type, and it's like multiplicity. So container is something like a type plus multiplicity effect. And by the way, it's exactly the containers are more or less monads, are monads, like list is a monad. So a monad is just one step of abstraction above a type plus some effect, not only multiplicity. So missing data like optional is a possible effect. Fail exception is an effect. Asynchronous computation, you remember, completable future is a monad. Multiplicity, so lists, streams especially, are monads. Transactions, I will show that. And even dependency injection can be written as a monad. Okay, but once we started into the theory, a little deviation. Now for, let's say, in a way, we go deeper. Maybe you've heard the word functor. And functor is something less than a monad. So something actually more generic, higher in the level of hierarchy. So functor is basically something that just has a map, doesn't need to have flat map. If it has flat map, this is a functor that is a monad. If it just has map, this is functor. Some people call it mappable. In reality, in programs I write in Java, Scala, or Kotlin, I don't really remember if I ever have functors that are not monads, but potentially there are such. Funny, that was an interesting thing. There is something between functor and monad, which is called applicative functor, which is crazy because, you know, it's if functor is something that has a map and monad is something that has a flat map plus this map, what can be in the middle? So there is something. And this operation, you can actually, this is probably the best idea to write it, which is called both. So you have, for instance, two optionals. You can have one optional after this operation, which gives you pair of these things. Why it's important? Because applicative functor allows you to describe things that run parallelly. So for instance, if you have multiple HTTP calls, that all of them are totally independent. You don't have to wait for one to start another. Then you actually can code this HTTP call as an applicative functor, because maybe you start hundreds of them, and at the end you want to get a list of 100 results, but you can parallelly call them. Maybe you have the same thing with database transactions, that you have transactions that do not really need to be dependent each one on another, but you just span hundreds transactions, each of them is independent, and at the end you have list of hundreds results. Maybe some of them even failed, but that's not your problem. You just wanted at the end the list of these results. So So that's a thing you may, if you want to be practical and know a little bit about theory, if you have something that goes one by one, you chain it with a flat map, that's a monad, that's like serial computation one by one. The results from a previous step I need in a new step, then you are doing a monadic computation. If you can make it parallel, then it's applicative functor that you can use. And basically all the monads are also applicative functor, not always just very performant. So to the point of this talk, coding transaction as a monad is very simple. That's one of the many examples, and you can find some on the network. This actually is more or less from a system I built some time ago, coded in a Kotlin. So you have map operation, flat map, and pure. The important part that inside of this is some kind of a private property from handle to A. Handle is just the database connection, but as you would do it in JDBI. And JDBI is basically JDBC done in a proper way. So it's kind of a low-level framework. So I would say this is a step, one step farther than what you use in JDBC template. Now you can code it in a smarter way. For instance, like this, select new job is transaction. Here is my, let's say, logic on a database, and then I flat map with a second transaction. And my code before was done in a way that both transactions actually will be joined, and the final action, final code will be done in one database transaction, which, by the way, is not the only possible way to code that. But typically, most of the people would do that. If I wanted to span multiple transactions in parallel, not actually depending one on another, I would probably add this both operation to my transaction monad, but in reality, I never needed it. So, and the same can be done with other effects like security cache, diagnostic monitoring async. I won't cover this because I don't have that much time. And the world is really great. The problem is that you have a lot of flat maps now in your code. It would be better, and it is better if you don't code in Java or Kotlin, but you, for instance, have at least Scala, where flat mapping can be abstracted because you have something called form core comprehension, which is basically designed as do notation in Haskell, so I'd rather call it do notation, and parts of the problem are solved, but not all of them, not even in Scala. Because sometimes we have finally this future from secure, from transaction, from optional, from int. And then I have maybe that it's actually even lucky. What if then I have future of maybe optional of secure, etc. Sometimes flat mapping, combining this can be a challenge. And now we are more or less the same problem as with function composition. We are now fighting a compiler instead of doing our business logic, which again is better than having error on production, but uncool. So that's the problem of stacking monads. And this is one of the biggest problems that people actually are trying to solve. So there are solutions for that. One of the solutions is to use monad transformers. I won't get into this, but you may hear about it. Monad transformers basically allow you to manipulate your stack. For instance, you have future of int. You can now create future of option of int using option t monad. So if you have monad transformers, you can, in any place of code, lift. Okay, there are different names for that, but you can actually fit your monads to, let's say, one common notation that you just needed in the piece of code so that you can use flat map. The problem is, first, monad transformers do not even work in Kotlin or Java. At least I don't know any sensible way, because they need a little bit more sophisticated type system. And second, even in Scala, for instance, or even in Haskell, they are not that great at the end. Some people hate them with passion. I won't cover that because actually I never built any sensible system with monad transformer. I only experimented a little bit. Okay, and that's it. So what is an alternative? I don't know. There's for sure a name for that. I call it almighty monad. So maybe instead of having this future or something, maybe when I am designing a system as an architect or lead developer, I will start with writing just one monad, which has inside handling of all our things that we're gonna use, caching, JDBC, maybe HTTP, something like, put it all together in one monad and keep it. Even maybe use the optionality effect or stuff like that. It's doable, and people do that. It's like, say, kind of a my stack monad, and people even name it according to the stack they use. I don't know, maybe okay, C3. Okay, I've forgotten the correct final names. I've seen it, but basically, like if you use this stack, maybe vertex monad, whatever, then you just call it this way. Maybe a reactive monad. By the way, Flux and Mono from Reactor are kind of this almighty monad, although that's a little bit different approach. So, and that's the way that works. But again, it's not funny, because when you start the system, you would have to write this monad, and then you would have to care about it, and you have to maintain it. And maybe then you realize that you have 3 systems, each of them have very similar code, like this huge monad description for the system, and you just actually you would rather have it solved in one place. So there are alternative approaches, and I recently experimented with one in Kotlin, because there are, let's say, more or less ready solutions for Scala, but I wanted to use the concept from Scala, mostly from this extensible effect projects, like having more or less the same things that this provides. Or partially I was looking at the quite recently popular project Zio, and on the other hand, I wanted to make it as simple in use as Spring, which is, let's say, from completely different world. And that's how I created a crazy experiment, which is called Ni. And it looks like that. So that's your enterprise project now. You have annotations, and you don't know what is first, cache security or transactional, and you have manipulation of bytecode which fail with every new Java version. All that strange ideas can happen, and all that starts slow. And if something doesn't work with transactional, you have to get to where the framework starts and what's happening during the start of our application, that this transactional annotation is not visible, etc., etc. A lot of nightmares. But what if you write it like this? New, pure, effect secure, effect cache, effect transaction, and then your code. More or less, it's the same as before. And this is now a monad. This monad I just called Ni, just a name, which basically has results. So each monad always has which type is there. At the end, I will have a list of user data, and then which kind of error can happen. This additional parameter that can be posted, and that's my, let's say, environment. Partially, if you read about Zio, you will see that I was heavily inspired by this project. So this is not a talk about Nimonad, but I just wanted to show you alternative that I create. By the way, this is now more or less experimented. What is Ni? Ni is just a monad that inside has these small effects, and you can combine them easily, but flat map is written once. So it's like really a solution to a lot of problems, because you don't have so many errors, so many compilation problems, but you still have a lot of fun and advantages of using functional programming and monads. So there is this kind of a research project, and I stress research. Don't use it for production. It's used for fun only at the moment, and I don't even know if that is going to change. But maybe I'm presenting that because maybe someone will be in a company that they will have a lot of time to invest in similar solutions. And at the moment, I don't really know similar approaches in Kotlin, but at Scala, they are already, let's say, mature, and maybe someone will just create. Yeah. So I'm going to conclude this talk. So functional programming, basically we use to not be so stressed, to not be that careful, to have a compiler, especially this functional programming with type system, to have a compiler that will check a lot of the potential errors that we can make. And there are some steps we do in that. Like first step, I hope everyone of you does now, tries now, already tried, is immutability. This is a logical step, and it gives a lot. So whenever If you start using immutable, for instance, structures and immutable collections, one day we'll get back to this old code with array lists, Java util, and you will realize how horrible now you are, because you see that it's not coding anymore. It's walking through the minefield. Everything can fail. You just don't want to do it anymore. Yeah. So that's how you actually accept that immutability is a natural way. Yeah, and that's a safe way. You feel safe when you don't mutate. Then the next step is forget about fantastic frameworks sometimes. Try higher order functions because they are easier to test, easier to compose, and you rely on compiler, not on some magic bytecode manipulation and stuff in a runtime. Yeah, that can fail, that can work differently during tests and during production. I've seen multiple things that, for instance, force you to check more code than just the function that you are describing, like, for instance, in case of JPA. But when you go to this step, you will find a natural evolution of this. That next is learning about monads. It's not that you most of you now maybe use optional. That's a monad. But the thing is, like, when you are designing a system, you don't even think that's your architectural concept, a monad. But one day we will get there. And then you will get behind. Like, you learn that monad is one thing, applicative functor is something else, and functors, and you will compose projects in this way. Yeah. And that's our step. So, because at the end, the goal is simple. When I'm committing something on Friday, I shouldn't be afraid of putting that on production, because if it compiles, if it goes the basic tests, it shouldn't fail. It should not fail. Yeah, I should concentrate on business logic, and my tests should concentrate on testing that I implemented the rules as described by the business. But I shouldn't test if I am closing database connection. That should be provided by infrastructure, for instance, by monads. Finally, we'll have less occasions to less possibilities to make bugs. And yeah, the compiler is kind of your reviewer. Sometimes you are angry on him because he shows you red messages, but that's his job, to point you where possibly is an error. And that's also important, exactly as I stressed. You will need less tests. You will need only those tests that describe, like, acceptance criteria, the business logic, not all this infrastructure stuff. That will be done once, maybe for your higher order functions or for your monads, and that's it. Not when you test do the invoices are summed correctly. Yeah, that's it. And that's probably, thank you, that's the end of my presentation, part one. And okay, part one, this is my presentation about monads. In 15 minutes, I think, I will go to the presentation about I will go even to assembly. So that will be a huge jump and deep dive into something completely else.
Thank you for so much, Jarek, for this talk. And yeah, you have the next talk on the next topic. So, dear participants, Jarek will join the Q&A Zoom room and will answer your questions after the second talk. We have some minutes left till the end of your slot. So, if anyone has any questions, just type them into the chat or connect to Q&A Zoom room and talk with Jarek after the second talk. Okay, thank you so much. We will see you in a couple minutes. And now, in a minute, we will connect the presentation from our platinum partner, EPAM company.
grow. You grow when you have a desire to become better, to learn new things. When you listen to a webinar, a conference, a talk, go to courses, dozens of courses, then you are the one who speaks. You grow. You grow when you get up to speed. When you focus on your work, on your customer, on your team, then you become a part of something big. When you raise the bar and take responsibility for your work, whether good or bad. When they ask you for advice. When you create a small revolution or speed up an evolution, then you grow. You are growing because growing matters to you. You keep at it until it's just right. To be honest with yourself and others, to further educate yourself, to become an expert. And if it matters to you, it matters to us. APAM, focus on your growth.
Hello, and we are glad to welcome the representative from EPAM, Andrei Kucherenko, Chief Software Engineer. Good morning, Andrei.
Good morning. Yes, my name is Andrei Kucherenko. I've been working in IT for more than 18 years, and today I'm going to talk about advanced engineering. Let me start about small self-intro. My areas of interest are front-end development, back-end development, mobile development, clouds, IoT, and other. Also, I'm mentor, speaker, curator of mentoring programs, trainer, author of open source projects named GSCPD. It's tool for copy-paste detection in programming source code. And yes, I work at EPAM and I'm advanced engineer. Today I will talk about advanced engineers. So let me describe the problem. What we know about programmers' career path. We know that programmer starts as junior, next step is middle, and next senior, lead, and that's it. Pension and well-deserved rest. That's probably what engineers had 50 years ago, but now you can become lead engineer in 25. What should we do next? There are several ways to grow. Switch to manager or architect, or leave leave IT at all. And many good engineers have faced the problem. Until recently, there are no development paths for real engineers. That is why we have the advanced engineering track now. Who are advanced engineers? Advanced engineers are really the best engineers who can solve business problems, who can write code, who can teach, lead, and mentor other engineers, who has influence to engineering communities. They are best experts in their areas and have wide vision of related areas. The best engineers who enjoy solving any problem in engineering way. We have different advanced engineers in EPAM. Some of us has a deep knowledge and contribute to extremely interesting and important open source projects. Some of us extremely wide skills in extremely wide skills in technologies and easily switch between different technologies for solving business tasks. Some of us are the best trainers and mentors. So I'm going to say, don't stop to grow as engineer. You have opportunity to grow engineers all your life, and for that I suggest you to join the EPAM team and grow with us as advanced engineer. If you have any questions related to advanced engineering, you can write to EPAM. Contacts you can get in the chat, or you can find me directly and and I will describe what I know about the track. And so my name is Andrei Kucherenko, and I'm from EPAM. I think that's it from my side. I'm ready to uh, to, to answer.
Thank you. Thank you, Andrei. Dear participants, if you have any questions to Andrei, you can type them in the chat, and Andrei you can answer these questions there, or you can connect with him directly via Facebook or any other channels. And of course, there is a link to the EPAM Master Program at the user page under the EPAM section. So please follow the link, and you can find more information about the growth possibilities and learning possibilities at EPAM. Thank you, Andrei. I hope you will enjoy the rest of the conference together with us. So thank you for connecting.
Thank you. Have a good day.
You grow. You grow when you have a desire to become better, to learn new things. When you listen to a webinar, a conference, a talk, go to courses, dozens of courses, then you are the one who speaks. You grow. You grow when you get up to speed, when you focus on your work, on your customer, on your team. Then you become a part of something big. When you raise the bar and take responsibility for your work, whether good or bad, when they ask you for advice, when you create a small revolution or speed up an evolution, then you grow. You are growing because growing matters to you. You keep at it until it's just right, to be honest with yourself and others, to further educate yourself, to become an expert. And if it matters to you, it matters to us. APAM, focus on your growth.
Okay, dear participants, welcome back, and we continue Devoxx Ukraine online. Our next speaker is Jarek Ratajski. We are welcoming you back to the online stage, and Jarek will present his second talk. Jarek, welcome back.
Hi.
Hello. Hope you had some time to rest after the first talk and you are ready to inspire people with functional programming and assembly during the next hour.
Okay, yeah, I am ready.
Okay, let's start then.
Okay, hello. So it's now a second session of mine today. It's a great pleasure for me. Although I still say, I must accent, I would rather be in Kiev doing that talk and talking to all the people directly, but it's okay. The life is as it is now. So an hour ago, I was talking about monads, function composition and stuff like that. And this is very far away from metal. However, if you join a functional programming community, you will see that tons of people are actually deeply interested in assembly, in the low-level stuff. And that's not accident. It's not that we want to only do higher abstractions and totally forget about the machines. We sometimes cannot forget about them. We would like to forget, but yeah, I will show you why so many functional programmers actually are interested. So, my name is Jarek, maybe now a little bit. I started with Commodore 64, and then I was doing some Amiga with assembly and C, and I switched to C++, and then suddenly came Java, JavaScript, recently more Kotlin. I work for engineers doing consulting for banks, insurances, and such companies in Switzerland, so a lot of Swiss francs, I like it. Okay, so motivation for this talk is more or less this. Mythical slow solution. Sometimes, and I think many people of you have seen that, you present some piece of code and then someone says to you, oh, isn't it slow? Oh, this would be slow. And then you wonder why it's even important thing here to talk about it. And then for sure, as a developer, younger or more experienced, you've seen tons of statements about performance of some constructs in a language. This is slow, this is fast. Streams are slow, for loops are fast. Yeah, that kind of. And as a developer with, now, is it for 30 years, almost 30 years of experience, starting from basic, I have seen these statements from the beginning, like basic is slow, this in basic is slow, like this construct, or C language is slow. I still remember when I was writing code for Amiga that writing a C code was considered to be writing in a higher level language that is incredibly slow compared to assembly. And I even remember this moment when someone was showing me that post-incrementation is slower than pre-incrementation. And obviously I should always use pre-incrementation. There is such thing. Or the collections are slow in C++, or Java is slow, object-oriented programming is slow, functional programming is slow, and all that stuff. Or monad transformers are slow, if you are into monads. Okay, is it all true? And in this talk, I'm going to explore this kind of statement. It's like, I'm not answering these questions directly, but I will show you the tools and some things to think about whenever you are faced with such statements. Long time ago, life was simple. That is a piece of the code maybe I was writing exactly 30 years ago. Fibonacci in assembly on Commodore 64. Yeah, that's a very primitive version. And I remember from a book that I even still have this book. It's now barely readable. That there is this branch if equal. So if something is equal, you jump. That if the branch is taken, so if it's true, it takes 3 cycles. If it's not taken, so it goes to the next instruction, is 2 cycles. And the branch basically in an assembly is either you do a loop, for loop or kind of looping, so you can't do much, or you do if statement with a branching. if it's if statement, then maybe sometimes you just can rewrite this if statement in a way that instead of doing these 3 cycles, you can do 2 cycles, just you negate the condition. And I remember the time, and it was like piece of art to actually rewrite if statements, like logically if statements from assembly, in a way that they take less cycles. And it was like challenge. Absolutely for nothing, because I can tell honestly, almost 100% of the code I was writing back then had absolutely no problems with performance. Okay, if it had, this 1 cycle wouldn't even fix it. But yeah, that was nothing, critical for millions of people. They were just stupid games that, okay, worked more or less, yeah. So now more funny, this behavior, I continue even on my Amiga, and it was like, higher school of coding to do branch smart. But then came new Motorola. I never had this CPU, but I read about this CPU like beginning of 90s, and then I realized something in the description that contrary to all the previous version of this CPU, now if you jump with a branch with conditional, it's actually faster than not jumping. Which means all this handcrafted assembly code, like hundreds or thousands, I don't know, developers were writing in the past, is now even slower than just regular simple code people write. How funny is that? Because we were just targeting specific machines, specific version, and now people having better machines that actually maybe they exactly want to have as fast possible application as fast application as possible, they actually slowed down by us to be a little bit too smart. Yeah, well, Motorola, you're such a troll. Yeah, and that's how I more or less learned that the premature optimization is, the root of all evil. Yeah. So the problem, performance myths, the statements that people spread in network, social media, between colleagues, that not really are not typically precise. If they are valid in certain contexts. Maybe they were exactly valid in the past. That lots of performance myths about the things that were true in 90s in simple computers, but that are not true anymore now. Or that's even the most important thing. If they are true, they are absolutely not relevant to the observable performance of your project, of your application. Yeah. So, and there is a big cost of this performance myth. Rarely it makes that, what I showed, that you wanted to craft a faster code and you ended with actually slower. Mostly what happens that people prefer less readable solutions, or less flexible, less abstract, just in order to win mythical CPU cycles that not actually are there. And developers lose focus. They focus on this, performance tricks, or just not using good abstractions, just writing, simple code, and with the possibility that this will perform faster. Yeah, and they just cannot really use their full skills as a developers. And there is a reason for that, why this is like, no one is particularly evil, but as a humans, we love numbers. So performance benchmarks are really cool thing to market anything, to compare stuff, because how can you compare, is this code more clean or is more readable? This is really hard task, and actually quite often I'm involved in such discussion. This is code better, and you have no good measures for that. Okay, there are some, but none of them like fully acceptable. But when it comes to benchmarks, you just show the numbers. Okay, my code is like this, but I'm 3% faster, and now it sells. It sells because you show the number. So to the point that maybe a lot of you want to state now, so is functional programming really producing a slow code? Because that's something probably most of you have heard and some of you believe. And maybe that's even true. So I actually, this talk initially I did for Scala, and I found many articles about performance of Scala collections and monads and things like that. I adapted this to be a little bit more Java oriented. In some pieces of examples, there will be Scala written, but yeah, it doesn't really matter. It's the same about Scala or Kotlin or any language. Yeah? And the main example I have rewritten to Java to be more familiar to regular developer. Okay, the problem is when we talk about performance on the JVM, that's not an easy thing. So you have in Scala here, think for a moment, you have Java or whatever language that works on JVM you can have, right? And we have this code, and this code is compiled to bytecode by Scala C, Java C, whatever, Kotlin compiler. And this bytecode looks more or less like assembly, but it's not assembly. It works on the JVM runs it. And this JVM is not a simple thing. It's a machine that has complex stuff inside, compilers, GC particularly, so garbage collector, and it's not really interpreting, contrary to what tons of people believe. It's not really interpreting. It's sometimes interpreting this code and then finally really perform some assembly instruction. But for any critical part, it's actually compiling it by different, more and more aggressive compilers to the assembly pieces of assembly code, which finally are executed on the CPU. And the CPUs that we have now are not the CPUs that we had in 90s, like 386, 380, or even this Amiga. They are very complex. They have this multiple level of caches, speculations, etc. So those are complex machines. And to make this picture even more complex, there is OS, that operating system that basically touches and changes all this stuff, how they work. Like you don't exclusively have CPU, JVM. It's not the only thing you have to take into consideration, because JVM on different operating system will behave differently, etc., etc. So analyzing that, making statements how the code would perform on this complex picture is actually hard, because all of these elements can change something. Yeah. So the given piece of code, if you put in isolation, can perform completely differently when used in a little bit different context. Like the code around is different, the operating system is different, the JVM is different, etc., etc. And that happens. So in this presentation, we'll go deep from a very simple piece of code, but we'll go deep from that. And this presentation is not about putting you some benchmarks, because benchmarks are lies. It's not about presenting you the numbers, but about showing you the tools that you can check those numbers on your own, because that's important. If you know how to validate these statements, you can in the future be ready for discussions, for real discussions. You can validate if someone is lying. You can take a benchmark and maybe see that it's actually not really correctly written, etc., etc. My statement is, unfortunately, I would say all the benchmarks are lies. Some are bigger lies, some are smaller lies, but they are lies. And they, quite often when I look at my benchmark from the past, no matter how many even weeks I spent to make the fair benchmark, after I learn some things in a year or two, I learn this wasn't really fair benchmark. That's reality. Yeah. That's also a sad story, because somehow there is no good. There's no. I don't really know how to write perfectly fair benchmarks, but I will show you how to spot imperfections. So let's talk about immutability. That is step number one in functional programming, and a lot of developers believe that immutability makes you slower. And there is a lot on that topic, but I will show something which is simple but extreme. Let's imagine immutable calculator. So actually it's kind of summator. So you have a private property total. You start a calculator with, for instance, 0, and then you have method add, which creates a new calculator, but with a little bit different changed accumulator, this total. Added some value. And then you have just additional method get to extract the value. This is like immutable calculator. How cool. Contrary to that, mutable calculator is very simple. Method add returns void. Void is something in the functional programming that we hate. How can something be void? It's just a reason for all the mistakes people do. we'll never do something void. But yeah, if we do void, then we actually can have potentially faster calculator. Is it faster? Let's measure that. So the measurements starts with writing code for measurements. Like, yeah, maybe we care, and now for this presentation, we concentrate on how much time does it cost, how much CPU. So a lot of people, and I find it even now, will write measurement this way, like immutable calculator, start nano time, do some addition, and then print this time. That is how you not write any actually benchmark, not only in Java, but especially in Java on the JVM, but not even in C++ or whatever languages. In all the other languages, like which are statically compiled, this leads to less errors, but still to some errors. In Java, this is totally broken on the JVM. This brings you number that mean absolutely nothing. So what is the point? In JVM, actually, and most of have this just-in-time compilation, and the idea is that most of the code is not time critical. So maybe let's concentrate and aggressively compile only these pieces of codes which do matter. Which pieces of code matter? Those that are called often. So we can rewrite benchmark in a way that we simulate that we often call this piece of code, like maybe 10,000 times. And after we do that, there is a hope compile JVM will understand, oh, this is a hard thing. That's, by the way, hence the name hotspot we sometimes use, yeah? And if it's hot, then maybe we'll start measuring and they will print. And this time, this will be a little bit better. The numbers that will be presented here are a little bit better. And I won't show you because it doesn't really matter. It's still not cool. What we can do, you can actually validate if just-in-time compiler in JVM works. There is this flag, print compilation, which prints you more or less something like this, and it says, yeah, immutable calculator was like init, that means constructor, then add, and what is this tree here? It means that the level 3 of compilation was basically done here. Then here was level 4. It means more aggressive, more or less means the higher the number, the more aggressive compilation went here. But what is important, here it is a println statement from the code. It means that actually this end of warm-up was after all this compilation have taken place. Which means, more or less, could be that we measured the code that was actually made as fast as possible by the JVM. So maybe we are measuring something at the actually optimized level, which is good. But the best option is not to write this kind of measurements on your own, because there are more problems to consider, tons of problems, and I don't have time to even cover them. But it's best to use a tool with a documentation which describes typical pitfalls. And this Java micro benchmark harness, that's the tool. So it takes care for you about JVM warm-up. And if you look at the documentation, which will tell you how to, for instance, prevent something known as dead code elimination. So sometimes when you, I will show you an example, yeah? And it has documentation that covers a lot of potential problems. So if you use JMH and you read the documentation, there is a huge chance that your benchmark that you will write might have sense. There are additionally, I don't know how many, but many examples to JMH inside of the project that you can take a look, and they will show you how to test typical stuff. So that's how the testing code would look in benchmark. And for instance, important piece of code here is this black hole. Black hole, whenever I calculate, at the end, I send my results to black hole. Hadn't I do that, had I forgotten about it, what could have happened is that there is an optimization in JVM that says if no one actually cares about calculation, then we don't have to do them. So then it can happen then that your benchmark shows incredible good numbers. If it's so, think that maybe you haven't used a black hole and JVM has totally optimized your call. It means nothing is actually working here. Yeah, so you're having good numbers because you calculate something that was completely like commented by compiler. So here we have two examples of mutable calculation test, immutable, more or less in the same numbers. One important thing is when you do benchmark, you have to wait for your benchmark. If benchmark takes less than a second, it means there's a huge probability that you are measuring some accidental spikes done by your operating system, etc. So you have to wait sometimes minutes for your benchmark to be sure that it shows something that it's repetitive, that at least the numbers are not accidental. So now going back to this code, I hope you remember this immutable calculator, mutable. What do you think will be faster? When we run it on an OpenJDK 1.8, will be difference visible or not? And that's a good question. Answer to that is when I do this test, and by the way, this benchmark is somewhere on a GitHub. I hope I have here link. If not, I can share it later. Immutable calculation test actually was almost 10 times slower than mutable. So it would say, oh, mutability costs a lot. But now some of you may think, okay, I explicitly put here a number 1.8. Maybe a newer JVM is better in that. Is it? So well, maybe we'll see, yeah? Maybe version 15. And if you look at it, kind of not really. It's not really that it matters, this change that we see here. Yeah, a couple of percents better. I think it's accidental. By the way, those numbers here were taken unprofessionally. Like I didn't want it to wait incredible amount of time to have a really proper benchmark. So there's a huge variance, but it is about tools, not about numbers. Okay. So don't take it too seriously. But yeah, the truth is similar. Okay, so new JVM doesn't help. But what if I actually take this JVM, Graal? That's a huge thing. Now I have numbers which are more or less the same. Immutability in Graal, in this particular case, doesn't cost at all. Wow, that's a huge thing. Okay. By the way, I did a little more tests, but I don't have time to now cover everything. But this is something I decided, okay, so we have numbers. Never be satisfied if you have numbers. That's number is not an answer. It's the start of adventure. Because now it's interesting. The JVM, like classical ones, OpenJDK, they are not good at immutable class calculator. I say not generally just on this piece of code. I've seen they are not really good. But for some reason, Graal is so much better. Why is that? You should answer this question. You should know. If you don't know, then saying just the statement Graal is just better is probably misleading. You will just spread something that, again, will be maybe sometimes true, but not always, and people will take us as a truth, but they will then make a stupid even performance mistakes, yeah? So we have to inspect that. And how to inspect the JVM, what's happening? There are tools for that. One of them that you can check is, for instance, Java Flight Recorder. By the way, I don't think it works on OpenJDK, but it works on Oracle JDK. And there is like a license for that. Basically, it's a commercial thing, but if you do it for development purposes, researchers, you can use it. So what is a Java Flight Recorder? Is a kind of agent that puts all the meta information about the JVM that potentially are relevant. Some kind of event log that describes what's happening. And okay, there is a complex license. You have to analyze it. You want to use it, but forget it. We don't have time. I'm not a lawyer. So Java Flight Recorder is a low overhead. That's a very important thing. So it's like it takes events, takes measurements, but doesn't slow you down. So a lot of the times when you debug something, when you do profiling, you will see that your program becomes way slower. So point of the Java Flight Recorder is it shouldn't make your application visibly slower. It's okay. It depends, but typically it's actually fulfills this promise. So it more or less works the same speed. It means that you can look at the events, recorded times of the functions, and take some assumptions above that. So when I put here like how to enable flight recorder, maybe you will need to call this before. Yeah. So let's say that we've actually run our code with this flight recorder. We recorded this. This will be saved in this my recording JFR. And there is the second tool, Java Mission Control, which is basically graphical interface to browse such recordings. And here on the left part of the screen, I have Java 8 recording. On the right, I have GRAL recording. And maybe first thing I haven't shown the menu. There are multiple dashboards here that you can browse, very detailed. I went to the method profiling, and I haven't really seen anything interesting. So there must be a problem in a different place. This is not about Java Mission Control. There are specific talks about Java Mission Control. I recommend you watch it. I just show sooner or later you will go to this screen, which shows memory usage, and you will see that in a JVM 8 there was like huge consumption of a huge operation by garbage collector, like more than gigabyte. And in case of GRAL, nothing was happening there. Like there was no actually allocations after some initial start of the project. Okay, interesting. So I might now have a hint what can happen here. Yeah, but maybe you don't have this flight recorder. Maybe you are just have the problem. The thing you are measuring happened on a production when you have OpenJDK, something like that. There are additional tools you can use. JPS is simply like you dump which Java processes you have with JVM arguments. But what's the point? You will get these numbers. Those are bits of Java processes. And if you have this, you can call, for instance, JStack. There are additional ways to do this same, but JStack is just a standard tool. It will print you the stack traces of all the threads on this Java process, which might point you what was actually called at the moment you were running that. In our case of immutable calculator, it won't help much. Same as method profiling. And by the way, now contrary to what Java flight recording is doing, this is very sensitive to something called a save point. So basically, when you do a snapshot of all the stack traces, you will never get fully, fully realistic results, because these codes will never stop in some specific place. Basically, whenever you have highly CPU intensive computations, the JVM, okay, the last version, let's say up to 8, wouldn't stop and would just continue this computation and only will print the stack trace after this computation, which means you will never observe some things. Now it's a little bit better with the new versions of JVM, but that's a different thing, yeah? But in this particular case, that wouldn't help you. There is an additional tool called JStat. It's basically statistics. So, for instance, you can connect to existing JVM process, and you can print usage of garbage collection. So this was this kind of calculator I connected, and I've seen that there is constantly something happening on this young generations. And now, in the case of GRAL, nothing is happening there. So more or less the same result I've seen in Java Mission Control. So there is some memory usage. For some reason, GRAL doesn't really allocate anything. But why? What's happening there? Of course, you can go to answer this really, you would have to go to the description of optimizations GRAL does. Particularly, you will find it yourself in area called escape analysis, as far as I remember. But you can just go to assembly and see for yourself. So there are those JVM options, which basically all Oracle inherited JVMs have: print assembly and print. And by the way, you never use only this. You must use this basically because there are two syntax of assembly, AT&T and Intel. And if you see for a couple of seconds AT&T syntax of assembly, you will hate assembly to the end of your life, or you can go mad, or lots of things can happen, or you will think that there was a fraud in elections. So a lot of bad things may happen to you. But just look at assembly with an Intel syntax because it's so much cleaner and more readable, more popular in the books. So yeah, use this. By the way, that's not only this. There is an additional library you have to put into JVM. But if you are looking at JVM, my assumption is, at assembly, my assumption is that you are smart enough to find the DLL or shared library and stuff like that, because it's described in many places on the internet. If not, I can help you because, okay, that's actually a place where you can spend a little time. I just don't want to cover this. I want to show the results, but it's a little bit tricky. Just remember that. So, but finally we'll get something like this. So as before, we had this print compilation. So we had display, we had information when the method was compiled. Now we additionally would have information compiled to what? Assembly. And when we have that, so let me be honest with you. I can write assembly. I sometimes, okay, very rarely, like once per 2 years, I write assembly code just for fun. Not much, like a weekend, nothing useful, just to have a little bit of fun and see what's like in a modern processors, mostly like that. And still, it doesn't help me. If I am faced with this, and this is incredibly simple assembly, it's hard to find familiar things, especially that you won't see just this, 20, 40 lines. You will see megabytes of output, because that's the reality from a real project. So even from this calculator, I just extracted few lines that are interesting because they exactly show immutable calculation test here performed. And that's exactly this code, but I had tons of other stuff. And it was even more complex because this immutable calculator was there many times. But what is important here, that this is the jump instruction. This is starting with 0, basic x. Okay, this is but you have comments which line is this. Okay, I will show you in a moment how it's better. Here is incrementation, so that was our loop. Here is addition, and that's it. So you will see that in our code, now I have some kind of a loop. Actually, okay, I haven't really printed all the code. I have some code, some loop, I have some additions, but I don't have anywhere just a call to new method and allocations. And that's the thing. And by the way, if you write on hand assembly for more or less doing the same, you would end with very similar code. Now it's a little bit more stupid things here happening with registers, but this is almost the same code you would write if you are doing this loop in assembly by hand. Yeah. So this means that Graal was really, really smart to completely, optimize and throw away all these allocations and actually compile this code to the same form as mutable calculator would have. Actually, as normal for loop without any objects would have. Just an incrementation like summation on a long. This is cool. However, looking at it from this perspective on these dumps is very, unpleasant. There's a better tool, JitWatch, which allows you to, on one screen, see this is my Java code, this is my byte code, and this is my corresponding assembly, really one-to-one. So JitWatch actually shows all the stuff. So it's tool, I would say, almost like Java mission control, but it uses dumps from a machine. Not really this flight recorder, but this dumps from assembly and from compilation. And you can analyze your code this way. Now it's way easier to find the stuff, yeah? Where is this add? Where are the loops, etc. So that's the point. So, and what we can actually now confirm that in the code, in the final code of this method, there is nothing like, so in the bytecode, and that's important, in the bytecode, we have this all new, but the bytecode was changed to assembly that doesn't do any allocation, which is cool, yeah? So if we have some time, I will just show you this. If you don't understand what's happening, I will try to put it very simple, but this talk originally was for Scala, for a statement that monad transformers are slow. And monad transformers is something even beyond monads, very high, in abstraction levels, yeah. And people know and accept, basically that if you use monad transformers, your code will be very, very slow. It's even slower than using immutability, because, for instance, immutability is kind of a default in Scala. And by the way, when I had this code in Scala, it was even better performing than this in Java, but because I could do also immutability on a for loop level, and still the code was fast. Yeah, but this is a different story. So I won't get to the details, but here, let's say I'm doing something. I have some list of users. Some of them I can find, but only optionally, and some of them I cannot find if I find by ID. So this is like typical case for optional. And now with a library Scala Z, I just want to show how it would perform if I use classical approach, having stacked monads. It means task of option. Task is basically there is a future. This will be happening in the future, that there will be optionally and user. So asynchronously, I can get optionally and user. And compared to that will be a code that basically uses monad transformers, and it's a little bit simple, but more complex in a way it works. But when we compare the performance, what we see, yes, monad transformers were slower, but high margin, not by a high percent. It's not twice as slow in this particular case. So the statement that people present is actually something that is more or less true. I would agree with that, but it is not valid in all the contexts. Yeah. So for this monad transformers, but we are not covered that. Don't go into that. This is a Scala thing. Remember the thing: find user by ID and return optionally and user or something. What if we used null in Scala? Don't use optional. Don't use any asynchronicity. Just use null. How would that be? And now interesting. On the JVM8, it's so much faster. So just not doing any functional programming here, doing just null, it appears to be way, way faster on the JVM8. Yeah, it's a pity actually, but it is the truth. This is a reality. But in reality, we don't typically find user in some collection in memory. What we do, we find them in a database. So let me put the real database to the picture. Let me edit. And now our thing look like that. That's the context. So, come on, null was faster. Monad transformer was slower. But it doesn't matter if you are already calling the database. This is the huge problem. Maybe you should think about removing the database of the picture, but this is really a point. I see it the same in Java and in a Kotlin, that people care about micro-optimizations. Don't call it just cache this, I don't know, this call something. When a line later, they process huge table in the database. And at the end, no matter what they do with a performance on a micro scale, they might save 2 cycles, but it wouldn't be measurable actually. So this will be like small person and sometimes really not visible at all. So here I even compared database with plus monad transaction, yeah. But nevertheless, solution to that was, if you have the database and you want to make it faster, maybe for instance, there was just something maybe you should use here was a very smart query with a where statement, etc. So solve the problem on SQL level. And now it's interesting how it looks like now, yeah, optimize the DB solution. So, and that's my goal of this part of this presentation. Look at the problem from your application perspective. Maybe you would have to make the problem smaller. Like, this is my service. This is now called. Like, we call this service 1,000,000 times a day. So what's happening from the start to the end of service? Put that into measurement. Profile that. There are great tools for filing. Monitor that. There are great tools for monitoring, like Dynatrace, JProfile, the tools that can help you and visualize what's happening. And then fix what is really a problem. Maybe, and by the way, quite often we developers assume the database is a problem. This picture confirms that. But my experience shows that quite often not. It's like we like to solve the problem on a database, but sometimes the database is not really guilty, although we like to make it guilty. Yeah? So the point is that we can even go, by the way, here it doesn't really change much if we go to Graal. So also interesting. Sometimes we even have to go to deeper than assembly. Okay, I have a couple of minutes still. So for instance, this is now Scala. Sorry, I haven't rewritten that. Scala 4. And by the way, for loop in Scala is not a really for loop. It's more iteration. But nevertheless, it's kind of, we have two-dimensional array. And we do a classical task that you will see on many conferences when they describe you how CPU works. This is a classical example. And in Scala, basically, to be more low level, you don't use for, you just use while loop. And again, I just go row by row, I add something from this array, and then produce result. You see, JMH also works with Scala a little bit differently. That is our corresponding black hole. If you return something, it goes to the black hole. But then we do something else. We transpose while and reverse. So we go backwards, and we go column-wise. So instead of reading row by row, we just go column by column. And you will see this example multiple times on the presentation, that this is way slower to do that because of the caches. And how can you measure that? You start JProfiler, but with these parameters, prof. And by the way, again, you will have to install additional program on your machine, maybe some additional packages for your kernel, but it will work. It will present you some numbers. And yes, as other talks show, while with transposed and reversed like walkthrough was actually slower. So while was the fastest, for because of the Scala 4 is written was a little bit slower, but this while was the slowest. Yeah, and then you will have a lesson about latencies of caches of CPU, that if you go byte by byte, the things land in the cache and are very fast read from the cache. And this is actually optimal approach for reading stuff into dimensional arrays, go row by row. And then you can, this is exactly JMS hprof thing. And here is the thing loading from L1 cache. This is exactly this transpose. We've seen so many loads and almost 70% of cache misses. Compared to the standard solution, where normal while, where there were only 12%, like 13% of cache misses. So we see that because of cache misses, one is better than another. This is a classical thing. But now, funny story. I recently read, I couldn't confirm that the new Intel processors actually will be able to find out this pattern and optimize it for you. So maybe, and I'm talking about Xeon processors. I couldn't confirm that in the documentation. This is, let's say, this is just a gossip. But maybe there is some truth in that. So I haven't this kind of processor, so I couldn't confirm. But maybe in 2 years, someone will be presenting this classical example, and then you will open your laptop and show that there is no difference. That will be a huge thing, yeah? Because CPUs are becoming faster. Then they see that a lot of us, just because of some reasons, we wanted to iterate in a different way, and then can optimize that for us. So I haven't covered in this talk garbage collector problems as ahead of time compilation, tons of JVM options actually that you can use to inspect more what's happening, or even tune your just-in-time compilation and stuff like that. Because this is a huge topic. The benchmark I presented in numbers were lies, so I presented numbers as on my machine, but I never really cared to really isolate this machine, etc., etc. And always assume that most of the benchmarks are more or less done unprofessionally, or there is some unfair thing when you compare, done unintentionally even by the authors. What I wanted to show you were the tools. So when you see a benchmark that if you see some numbers, ignore them unless you can prove them on your own, because there is a source code. You read about libraries that are used. So for instance, so that you know that you not misuse the library. I remember 20 years ago, someone showed me we don't use prepared statements because they are way slower. And by the way, reality is that in most cases, they are not faster, they are not slower, they are more or less the normal statement in JDBC. But if you do really broken benchmark, they will show as way slower. And that's like really, you have to analyze and look, if you compare two solutions, you have to read a little bit how they work, what are bad and good practices, so that you really compare them fairly. And finally, a benchmark that the result you can put like, this is a guide for me. I will use that in this critical piece of code because it's faster. And I know why it's faster because I've analyzed the differences. No, like it is faster by 30%, but who knows why? If you know the difference, you can prepare yourself for the future. So for instance, you will know that maybe in the new JVM, it's just because there is a bug in JVM. I had such examples. Like it's a bug in JVM, will be fixed in the new version. Does it make sense to make your code less clean just to, while you wait for a new JVM version, which will be released in a month or two? And then this bad code will stay. So this was talk not about numbers, not about that much functional programming, but about tools that these tools typically I don't use in my daily business. I use them mostly in problem solving. I involve them, I actually present some benchmark I have on my GitHub, mostly when someone says me this generic statement, and I want to show, oh no, that's not actually always true. That's sometimes true, and see for yourself, yeah? That's how I produce most of the benchmark, just to prove that someone is wrong on the internet, yeah? But if you know these tools, you feel more comfortable because so I try this in free time, even if you don't need it, because when you will need it, you won't have time to learn how JProfiler, okay, I haven't shown the professional tools like JProfilers. You will never have time to learn it when there is a real production problem with a performance, yeah? So you have to be prepared upfront. And better try on your, pet system that you can really heavily inspect and debug than on the real production, which is always more complex, yeah? So real maybe problems I had on the production, I still remember my lesson from when I was a junior, when I seen a very, very complex code written like, in Java, that was Java, but written like a low-level C with byte manipulation, byte shifts and bit shifts and stuff like that. It was really horrible to read. And the funny thing is the developer of this piece of code haven't realized that whilst fighting so much for cycles, he's accidentally reading a whole database table. It's really, this is for me a really typical case of how someone fighting for cycles becomes so defocused that he is doing a huge performance error. And then this code was such a nightmare that it wasn't really visible. A really simple thing is synchronize, so locking. I had multiple times static method synchronize, which was even a static method for just put some lock information into the file. But it was, because it was used through all the system, it was slowing it extremely, like all the time, even on a huge machine, there was only one thread actually working. That was an interesting lesson. Yeah, and so, but nevertheless, always when you see something, many times I said, oh, I found static synchronize. This slows down this system. So I remove this synchronize, I rewrite the code so that's still safe without synchronize, and bam, there's no difference. Be prepared for that. That's why we have benchmarks that we want the repetitive numbers, because we repeat and we see if our solution really fixes the problem. Yeah. Hashcode equals bugs, so where hashcode equals are very written in a bad way, inconsistent. That leads to a lot of funny performance problems, which are sometimes only observable on huge data sets on production. JVM problems, bugs with meta-space garbage collectors, that's something that I've observed a few times. And that's particularly a problem because sometimes you have to do a huge workaround and even change the architecture of your system. We had this case. And locks, deadlocks, basically. So actually the problem is that the system performs very slowly, but if you analyze, there is no I/O, no CPU, nothing is happening. You have cluster of F machines that are doing nothing, and the system is slow because there is some kind of a cluster lock. That's a typical case, yeah. And in many of those cases, that's the thing that people that do performance audits also confirm. Many of these problems can be just spotted by using JStack, even though JStack is not perfect because it has some potential problems that will not show you anything. Remember the save point problem that's discussed on other talks, yeah? So this is so. So this is the end of this talk. Remember that, we are talking about changing world. Things that are now slow might be faster in the future. So be careful when you make a huge statement generic, because it might be not true in the future. Because compilers and CPUs are designed to perform human readable code actually faster. So they analyze what we as humans write typically, not as a hacker's code, but typically, and make these patterns faster. Yeah. And last but not least, it's like, okay, it's not even the last, like you don't concentrate on micro benchmark, concentrate on the things significant from the system point of view. So like if you have a service that's heavily used, measure what's happening in this whole service. Don't concentrate that one construct is slower, because maybe it's slower, maybe it's 100 times slower, but it's once called and it's different between 1 nanosecond and 100 nanoseconds doesn't really make a difference for the whole system point of view. And because of caches, quite often it's absolutely not measurable. Yeah. So, and at the end, if you are presenting some code and someone says to you, oh, you have to rewrite it because, oh, it's crazy. It's nice, functional code, clean, but it will be slow because you have to do loops. You have to ask, do you have really benchmarks of that? Can you prove me that it's important for the speed of our system? Like, ask this question, because mostly people that will bother you about performance, they don't measure anything. They are just repeating generic statements, which are mostly not true. Yeah. So thank you. And yeah, I will be in a Q&A session ready to answer more details. Yeah. I have more code if you want.
Thank you. Thank you, Jarek. Thank you for joining our event today, and thank you for 2 talks you conducted. Dear participants, please join Q&A Zoom rooms with Jarek, and he will answer your questions on both talks, first and second. And Jarek, I hope we see each other next year and the lockdown will be ended by the time of the next Devoxx, and we will be welcoming you in Ukraine.
I definitely miss Ukraine. I'd gladly be there. Yeah. So thank you.
Thank you so much. Dear participants, and I remind you that you can vote for the best talk and the best speaker using the mobile applications. The links to the mobile applications you can find on our user page. So just download, install them, and select the best speaker and the best talk. The results of your voting will be announced at the closing ceremony later today. And now stay with us, and we will have the presentation from our gold partner, InfoPulse company.
Welcome to InfoPulse, the place where we not only get professional experience, but also make friends and share common values. And what's more, InfoPulse is about the company's top management, who is on the same wavelength with everybody and knows each specialist personally. It's about victories in business and in your favorite sport. This is when you feel at home while at the office. And you can combine business with pleasure. For instance, studying foreign languages while watching films. This is when you look for ways of completing the most challenging tasks together. When you can get creative without leaving the office. Where you can find time for improving your physical and mental health. When you understand that most of the time which we spend at the office is not only about business.
Okay.
Hello.
Hello, hi.
Hello, how are you today?
We're perfect. We're with you. So obviously we're good. And
Okay,
you know,
great. Great.
yes.
Yeah, what have you prepared for us today?
Oh, it's a good question. So since I'm new here, I couldn't come with empty hands. So I prepared a small game for you, Ainura. Are you ready? And for you participants, our dear participants.
Yes, I'm ready. Yeah.
So I hope you know the who would rather game.
Sure.
Okay. So who would rather know the name of each specialist?
Oh, that's easy. This is our CEO. This is
Yes.
true, guys. He knows every single name in the company. He has a very good memory.
Oh my God.
This is
And motivation. I couldn't find such motivation myself. So the next question. Who would rather stay always open and honest with our specialists?
This is also easy, Maria. Very easy. I would say each infopulsar, because this is our culture. This is what we encourage our employees to do. So I would say every single infopulsars.
Okay. And who would always stay flexible, stable, and open to new changes, even during difficult times?
Your questions are too easy. I think it's Infopulse, guys. Infopulse is a stable family company. Okay.
Yes. So,
okay. Yesterday, Maria, you missed our presentation of our history and how everything started. I already asked you some questions, so I think you know everything.
Yeah.
But today, I think it's a very good time to kind of dig a little bit more into our project. We're delivering IT services into various departments such as banking, financial department. We are collaborating with Big Four, bigs, fintechs, automotive.
And could you remind me, please, how long we have been cooperating with BICS?
Yes, Maria, I think this is our longest cooperation so far. We are partners for about 30 years and counting.
Oh my God, it's such an honor. Yes, but you know, we provide really high quality technical support, and we create different technical projects, but we always remember about the purpose, about the main mission of our projects. That is why we are known for good social projects, and even during this hard time, we help our country. We provided more than 2 million hryvnias, with helping to fight the coronavirus, and it is called the Track of Health. And you know what is more? We also are pretty good and culture supporting of our country.
Yes. We talked a little bit about our traveling of employees and culture, and I'd like to elaborate a little bit more on that. I would like to say that InfoPulse is encouraging every employee to develop his personal skills as well as professional skills, of course, and broaden horizons because sky is the limit. Yes, and also we offer all kinds of different trainings and mentorships. By the way, Maria, did you have a chance to use one of our trainings?
Of course, you would not believe me. I participated in training of creating speeches, and I hope I'm doing great. Oh my God!
You're doing very great. So you're practicing right now.
Yes, guys. Thank you for being with me now.
Yeah, and I actually started learning Norwegian with InfoPulse.
Ooh.
Yes. Good day.
And you know that's a bit about our projects, and back to our cooperation with Ukrainian government. We created a gift for our students, for our members, a STUS online museum. All of you can now check it on website. And what do you want to say about our company? Last word.
I think as yesterday, I encourage each and everyone to visit our website for more information about our social projects, about how we can all help our countries fighting this COVID situation, and also, of course, please check our vacancies because we have open positions in different.
And you know,
locations.
we stay open for you.
Yes.
And always open for communication.
Sure. Feel free to contact us on social media.
Thank you.
Thank you. Thank you, InfoPulse, for such energetic presentation and for providing more information about your company and, of course, for supporting Devoxx Ukraine Online this year. And dear participants, I encourage you to register for InfoPulse giveaway. You will find the link at our user page, so register and the winners will be announced at the closing ceremony today.
Sure.
Thank you, ladies. Have a good day and stay with us.
Bye.
You grow. You grow when you have a desire to become better, to learn new things. When you listen to a webinar, a conference, a talk, go to courses, dozens of courses, then you are the one who speaks. You grow. You grow when you get up to speed, when you focus on your work, on your customer, on your team. Then you become a part of something big. When you raise the bar and take responsibility for your work, whether good or bad, when they ask you for advice, when you create a small revolution or speed up an evolution, then you grow. You are growing because growing matters to you. You keep at it until it's just right, to be honest with yourself and others, to further educate yourself, to become an expert. And if it matters to you, it matters to us. APAM, focus on your growth.
Okay, dear participants, welcome back to Devoxx Ukraine Online. And we are ready to continue with our next speaker, Igor Dmitriev. Good morning, good afternoon, Igor.
Yeah. Hi guys, how are you?
We are very excited about the second day of the conference. And how are you today?
Yeah, never better. I'm also excited to be here.
That's very energetic. What topic have you prepared for us today?
Yeah, so actually I'm gonna talk about continuous delivery with Spinnaker.
Okay, that sounds very interesting. Guys, please type your questions to Igor in the chat, or he can join the Q&A session after the talk. And now I welcome you to start.
Okay, thank you so much. Appreciate it. Okay, guys, thank you so much for joining my talk. I really appreciate it. So let's roll because we have just 50 minutes, I believe. Okay, let's start. So I am Igor Dmitriev. I have been working in IT field for like 8 years. Like give or take. So my current role is engineering manager and solution architect at SPD Ukraine. And I also took part as a speaker at different IT conferences. And like in overall, I like sharing my knowledge. And it's really a pleasure to be like, part of Ukrainian IT community, not just Ukrainian IT community, right? And if you would like to reach me out, you can do it at least via like LinkedIn and Facebook. Here are my contacts. So let's roll. First thing first, let me add some context. So currently, as I already mentioned, the company I work for is called SPD Ukraine Outsourcing Company, and one of our clients is Morningstar. So it's like a leading and really biggest company for like investment research and and stuff like this. So when, by the way, one interesting fact for you is that if you go to Google and try to Google like 20 USD to euro, you can see, like it says data provided with Morningstar. Yeah. So, and actually, we have, relatively new applications. They're all like mostly monoliths. So, and maybe the oldest project that we have is like 2 years old. So, and we try to follow NoOps culture, we don't have any DevOps engineer. And to be honest, I believe that in the era of managed services, like, we have platform as service and infrastructure as a service. So I don't think, it really makes sense, and it shouldn't exist. Like, I'm talking about DevOps as a position, as a role. Guys, try to be an engineer. So it doesn't make sense to all this stuff, because we're all engineers and our main goal is to solve business problems. All the story, like when we have a ops guys, some dev guys, and they focus on different aspects, right, and different priorities, and they have a conflict by a reason, just get rid of ops guys, no ops, no problems. So that's the way how we work, and the culture that we try to follow. So, and right, as I already mentioned, that our main goal is to deliver like a business value, right? And in order to do that, we need to to have a motivation and have a great and get a really great tool to do that, to deliver our code, right? And let's talk about some company constraints, because we have company constraints and due to security and etc. So, and currently we have a standardized tool. It's called like Jenkins build tool that we actually use to commonly at Morningstar, and we are in cloud. It's on AWS. So, and what are the requirements to that, continuous delivery tool? Yeah. So, automation is the key, right? I would like to have this ability to click the button, and I want to get my code deployed to some environment, like station production anyway. And if something goes wrong, I would like to easily revert it. And it would be nice to have, to deploy a custom version just to select a tag or some version, right? It would be really nice. And everything should be scripted, because I don't want to manage it through UI, because nowadays it's really kind of really hard to manage. And it must be secure and not expensive. I don't want to spend a lot of time and money on doing this. And it should be available and stable, right? It's really important, because I don't want to personally manage the stuff, because I'm lazy, I don't want to manage like CI tool. And yeah, you may ask questions. So we have Jenkins, right? Why can't we use it? Jenkins is mostly like great in talking about CI stuff, because yeah, it's great, but it's mostly like script based, because you need to manage all your custom scripts and etc. That's why it's not really suitable like for us. And okay, that's here. Spinnaker comes to the rescue. So what is Spinnaker? Yeah, we just decided to try it out. Why not? And Spinnaker is a multi-cloud continuous delivery platform. You can deploy your application to AWS, to GCP, to Kubernetes, to Oracle Cloud, and etc. It was originally invented by Netflix, and like the idea is that Spinnaker builds on like Netflix experience, right? And you can just take this tool and and do the same stuff as Netflix do, and you can just work in the same manner. It is with minimal effort. That's really great. And it has built-in deployment best practices. That's really also important, because I just need to follow this best practice, and that's it. And has integrations like continuous CI, continuous integrations like Travis CI or like Jenkins, right? You can also integrate it with a Docker registry. It also has some messaging integrations like Slack, Twilio, and monitoring like Datadog, New Relic. So it's really great that because you can integrate the Spinnaker with many different applications. It also has House Monkey and role-based access, and it's open source. So it's super awesome. Yeah, because I really love personally open source, and it has a big community, and community is getting bigger and bigger. So, and there are a lot of companies that are already using it. So you may see just a small amount of those companies, and you can say, okay, those companies are using it, and that's like why it's worth using it as well, right? It's that's the way how it should work, I believe, right? Because and okay, I think that's a time for demo. Let's get our hands dirty with Spinnaker. And today I'm going to show you like a small demo with Sprint Clinic. I believe most of you must have heard about that. That is like a pet project of Spring. So let's go. Okay, so I have a Spinnaker deployed here. Let's log into Spinnaker. Okay, this is like a home page, right? I log into Spinnaker. We have application, everything from applications. So you have a pet clinic application. Let's go there, and it takes me to the cluster. I will, let you know what is a bit later. So let's take a look about, it has some menu on the left side, pipelines, clusters, load balancer, firewalls, tasking, etc. So, everything you should do, before you start using Spinnaker, you should create some infrastructure. We use Terraform for that purpose, and all you need is just to create a load balancer. If I go to my project here, and tells you, by the way, everything that I'm going to show you today is on GitHub. So you can just, check out the project and repeat everything by yourself. So we have a load balancer, right? And we use Terraform to provision our infrastructure. If I go here to infrastructure folder, we have Terraform, we have modules, and we have load balancer. If I go here, you can see that, if your name of your load balancer starts with the name of your application, it will be accessible in Spinnaker. That's the way how it works. And okay, so then let's go to pipelines. So as you can see, I have something already here, just to economize time. And let's take a look at this. Okay, I have a deploy to staging pipeline. So, where you can see there are all different stages, and let's start from configuration. This is a way how you can trigger your pipeline. So as you can see, there is an automated trigger section. And I just would like to listen for some Jenkins job. You can see, there are different types, by the way. You can just enter some Artifactory, cron job, that can be triggered from pops up, from webhook and Docker registry and so on. I have a Jenkins, as I already said that we use Jenkins for CI. Yeah, let's take a look at that. We have Jenkins, and we have only one job here. It's called publish artifact. And, it's kind of the way how it's connected. And, you can also get some context from that job. You can, to use some parameters from Jenkins here. This is like, how I integrated the stuff. I just try to get some parameters from build properties file. So let's try to change something. If I go to my load balancer and show you my application also here. So as you can see, I'm already here. Like I have home page, I have some owners. I can just route owners by last name, I believe. Yeah. And, let's change some like welcome message. Okay, pretty simple, it's typical. Okay, welcome page. So let's change it. Welcome Devoxx 2020. Okay, let's push it to master. So never do this on production, but anyway, I'm home alone. I can do this. Like welcome Devoxx. Commit push. Yeah, here we go. I'm gonna change welcome message. So as you can see, let's refresh. So this like pipeline is gonna be kicked off because I have a webhook configured here. You can see my pipeline's running. So what do I have here? I have a like checkout project stage. Like then I just release some jar artifact. I create a git tag just to link my like code repository with an artifact. I build a jar and then I build a RPM package. So basically, currently I'm going to show you demo how to deploy to EC2 machines. But yeah, just a heads up. So I'm also going to show you like Kubernetes integration as well. So hipsters don't leave. Yeah, that's going to be part of my presentation. So we built a jar. So then I would like to pack an RPM package. This kind of a native OS image. So I'm going to deploy my application to a Linux machine. And that's why I want to install it as a native OS image. Then I need to archive this RPM package in order to be accessible to Spinnaker and publish artifact to some YAM repository hosted on S3. So, and let's get back to the stuff. We have this configuration. I think it's clear. And what's next? We have create AMI a new AMI to deploy. It's a bake stage, as you can see. You have bake stage. So here is how you can configure your backend stuff. So basically, Spinnaker leverages Packer. It's HashiCorp Packer tool. It's really great, to bake some, to create some AMIs, and you should specify regions that you would like to deploy. So currently, we deploy to multiple regions because we have this fellow routing policy, Role 53 routing policy. We deploy to multiple regions. And you can, some bake your AMI and share it across, different environments. You need to specify some basic parameters like package type, and some additional parameters like YAM repository. And let me show you how you should integrate your Spring Boot application with Spinnaker and all this stuff. If I go to my backend folder, we have I use Gradle. So here is I'm using Nebula. That's actually a plugin that was created by Netflix. It's created to to let you create a RPM package, like a Debian package. As you can see, I have a package configuration here. You can specify package name, pet clinic. As you can see, the same as here. You can do some description, like operation system, like Linux architecture, type, release version, etc., etc. And you also need to add some configuration file. Here, we use systemd. So guys, no worries, it's sounds insane. But this is a way how you can create a service from your jar. So you just need to specify some parameters like on failure start and etc. How to run your application and so on and so on. And you can also add some additional files to that RPM package. So it's kind of like Spinnaker. Just needs to use it to install on your machine. So you can wrap your jar and add some additional files. For instance, we add also new relic config files to that package. So if I get back here, this is the way how you can configure that Packer configuration. Let's move on. So here we have deploy. So by the way, as you can see, I have some notification here. So as you can see that my pipeline has been triggered by Jenkins because I have this trigger enabled here. So as you can see, it's running. And how to deploy my application. So here's the deploy stage. I can add some deploy configurations. This nice UI pops up. So you just actually need to select your account. And by the way, this is a very powerful feature of Spinnaker, because you can just have, Spinnaker is actually a centralized view to all your application, application-centric view. So it means that you can have access to your applications to different environments, because you may have two different AWS accounts. And, we have non-prod and prod, and you may have centralized view to all your infrastructure. And Spinnaker just tries to abstract from this stuff. It kind of provides you ability to view on your your environment from application perspective, not from infrastructure. So here you can just need to specify the regions that you would like to deploy to, some account, subnet, some stack, etc. Strategies. This is really powerful because you can select deployment strategy, like Highlander or red-black. It's commonly named as blue-green. And you need to add some parameters like load balancer, like firewalls, instance type, some additional configurations like user data, key name, and etc. etc. So I think we're done with it. So the next step that we added is just wait. So why do we need to wait for some time? So actually, whenever you deploy your applications, so if you're using blue-green deployment, it means that you will have a new version of your application at the same time. You'll have two versions, and you need to make sure that everything works as expected, right? You don't have any outages, any bugs. You just need to make sure that everything is fine, and then you can just destroy your blue environment. That's why we need this wait. So, and you can add some additional stages, you can trigger some Jenkins jobs. For instance, you would like to run your end-to-end test or something like this against pre-prod environment, something like this. You can also add some manual judgment. If it's used for security purpose, I don't think it's really valuable because we don't use it. Why should we restrict someone to deploy my application to production, etc. I think if you have it, you have a flow in your process, because in our teams, everyone can deploy to production. Okay, remove the stage. We just need to wait, and then the last stage is that you would like to destroy the previous environment, old service group. It means that you would like to destroy the blue environment. Okay, let's take a look at the stuff. What's going on? Oh my God, this failed. I didn't expect that. And return ball. Yeah, it's really nice. Demo purpose, yeah. Okay, let's try to rerun it. Instance. Yeah, by the way, this is the way how you can specify the specific versions that you would like to deploy for through bake. It's really weird, but as you can see, this is how your build bake stage looks like. So these logs are retrieved from Packer. It's really weird. Server return roles, something like that. I have never seen it before. So anyway, so I think it doesn't make sense to show you, but I can prove that I had some successful deployments. And so, okay, what else? So if I go to infrastructure, or to cluster environments, this is how you can get all your information about your infrastructure. This is how your developers can jump on this page and see what is actually currently deployed in your environment. So Spinnaker is not just tool to deploy application. It provides, as I said, application-centric view that if I just click on it, you can see which version is deployed. I can click on the build, it takes me to the corresponding Jenkins job. I can see, everything's here. And, it's Spinnaker versions, all stuff for revert purpose. I can go in here and you can see some launch configuration to see what is image ID, image names, instance type, and user data. I click here, so everything is here. It's nice. And yeah, I can see some commit message version. So it's really nice because I can go to Git and check out the version and just match it, build link, and etc. etc. So, and by the way, there are some additional features. Let me just check to deploy. If you can also restrict the execution of your pipelines, there is a restriction execution specific time windows. You can, for instance, you don't want to have your application deployed like, at night maybe, because you just need to make sure it's can be down and you just want to sleep well. You can just say, okay, I would like to restrict it restriction window. So I only want to allow to deploy my application from like 1 to like 4, right? Or like 6. That's okay. I don't want to do this. Okay, 1 second. Let me check if I didn't miss anything. Tag Nebula, follow Packer, green, window, Nebula, customs page, cluster built on 4. Yeah, execution pipelines. I don't want to change it. It's running. So, and here you can see, like your bakery details already set, right? Which versions. And if I go to deploy, for instance, let me show you here. Spinnaker actually really transparent. You can see everything the Spinnaker is doing under the hood. If I go to task status, you can see what's happening. It has like false cache refresh, wait for up instancing, and so on and so on. You can also take it to the source link and get some additional logs here and see some status, deployment, and so on and so on. Okay, execution pipeline. And maybe the last thing that I need to show you is that, currently I configured everything like manually through UI. So, but that's not cool, right? And I can actually have it as a code. Let's go to, we have a pipelines. If I go here to deploy to staging, I can have this like export as a pipeline as template. So when everything is fully configured, it makes sense to manage everything as a code after that, right? You just need to configure UI to make sure it's working, and then you can create a, this is like a script. Let's go and name it properly, deploy to EC2. And click save. Okay, it's saved. So, and which is really great is that you can share it with other teams. That's what we do, because we are the first team to Morningstar that starts using Spinnaker. And when, we got the hang of it, we just shared our knowledge to different teams and they started also using it. So that's very powerful. And okay. So, I just showed you that we can deploy it to staging. What if I need, by the way, it's, as you can see, successful. So now, as you can see, if I go to cluster, as you can see, new version is gonna be here. Let's just refresh. Oh yeah, here we go. So you can see now it has some intermediate state, so it's not green. So, and actually, how can I revert? What if, something went wrong and I realize that my application is down and must be, rollback, and I get some notification from, from PagerDuty or something, I can click on the old version, right, and click rollback. It actually is, you will have this all revisions and all available server groups here. And you can just add some reason, like failed, and click submit. So that's it. And what if I need to deploy to production, right? Because I have non-prod account and have a pipeline to deploy to staging, but yeah, and he's having one account, and I would like to deploy my application to production. How can I do that? So I can create a new pipeline, deploy to production, and copy it from staging, deploy to staging. Here we go. So I can just edit it. And let me just run it. So I can disable this stuff. And go here and let's hide it. And I click force bake. I don't want to do anything. I just want to reuse previous build. If I click run. And So as you can see, new AMI is not going to be baked. So it's caused by, Spinnaker has this really powerful feature like AMI caching. So it means that you can you can build up your AMI that you would like to deploy to your environment, right? And reuse it across promote it to different environments, to staging, to dev, to production. That's how it works. It's really nice. The same stuff as we do with Docker, right? Because you just would like to one image to run them all. No, let's stop it. I don't want to deploy the new version here. So, and by the way, like, check it out. I think that welcome. Yeah, welcome Devoxx. Here we go. By the way, I think that we should have welcome as well, because currently we have 2 versions attached. Okay, no luck. So anyway, okay, let's get back to slides. And okay, me get it straight. So that's what we have for like VM-based deployment. So we have a pull request. We merge it to GitHub. So then like we have a GitHub webhook configured. Then Jenkins job is triggered. Jenkins actually builds a jar. Then it wraps it like to RPM package, right? That RPM package is gonna be uploaded to YAM repository, which is hosted on S3. And then like Spinnaker bake stage is triggered, and actually Spinnaker leverages Packer, and Packer is used to creating AMIs that is going to be deployed to EC2 machine, and that Packer actually retrieves RPM packages from YAM repository and build an AMI, and that AMI is used to spin up your environment. So, and basically, Spinnaker creates new autoscaling group, and you may have 2 autoscaling groups attached to the same load balance at the same time. So it's based on this like deployment. So I hope that it's clear. But let's check what's going on there. I see you can skip this. I'm not gonna wait. Yeah, currently you see I have like 2 versions. Yeah, this one is because I deployed it to production. I think that's pretty much it for VM-based deployment. Guys, you with me? I hope so. So let's take a look at what is under the hood. So basically, Spinnaker is based on microservices architecture. So you can see there are around 10 microservices, and each service is responsible for different actions. So for instance, we have Orca is the orchestration engine, and we have Roscoe, it's bakery, and we have Kayenta. Kayenta actually provides canary analysis. So, and you can deploy your application, you can spin up a Spinnaker in different ways, using Docker Compose, using Kubernetes, using like Ubuntu. Yeah, I can currently show you what we have right now. Let me SSH to my machine. Yeah. Show you, okay, system, CK. So that's like system that I showed you previously, right? That's how it works. You can check out your services. And what is really great, if I open like, a Roscoe project and show you some stuff, let's check some logs. And we have some logs, let's check it out. Sudo catch logs, log. Here we go, we have some, logs here, and I would like to check out. As you can see, here's how it's, how it calls Packer and some command. Let's take a look at the stuff. Job executor, local service. If I go to Roscoe and try to find it. So as you can see, right, it rings a bell because we guys, really I used to use a Spring Boot application with Java Fox, and it's written in Java and in Groovy, as you can see, like in Groovy. So it means that it really helps us to troubleshoot, because if something goes wrong, sometimes, may happen, you can really easily just check out the project and try to kind of deep dive into the code and realize what went wrong. It's really nice and it's also based on as far as the Spring Boot applications, and all configuration can be done through YAML files. If I go here to my Spring Boot Clinic, yeah, and by the way, so everything, as I said, everything I show you is here in the code, and you can use Terraform to spin up Spinnaker and Jenkins as well. I prepared it for you, just for free, free of charge, so you can spin up Spinnaker and Jenkins in one command. So if I go here to HAL default profiles, you can see that I have all this like files, YAML files. If I go to, let's take a look at Roscoe local, as you can see, it's just a YAML file, right? Because it's Spring Boot application. And let's take a look at, we have iOS, enable it true, we have bakery, some details like base AMI, because we have a base like image, or it's commonly called a golden image pattern. You can install some like basic style like Java to that golden image and reuse it. And for instance, if I go here to, I don't like it. Let's configure, and we have AMI stuff. You can see this base OS, and it's like actually was taken from here, from this file. Yeah, and written in Java. And by the way, if we go into SH to my machine, let's go to cluster. Here details, I think I don't need it. Can destroy. So engineer just would like to SH to my machine. Let's copy it. More. Yes, of course. Why not? And systemctl status pet clinic, right? My server's name is pet clinic. Yeah, as you can see, it's up and running. Yeah, like with the same way. So as I said, we just kind of like follow the practice that's Netflix like invented, right? Not just like invented, they just decided to use this way, and we just reuse the same approach. Okay, and what about configuration? So if you just need to configure a Spinnaker, you can do it either like through YAML file directly, because you can just go here and change something, right, in the YAML file itself, or you can, or you can actually do it via Halyard. Halyard is a service that is like, is created to configure like Spinnaker. So for instance, I have some example how to integrate Slack with Spinnaker. You just need to add some define some environment variables, right? And you can call HAL config notifications like I did, and you need to provide a bot name and token, Slack bot token. And then you just need to call HAL config notifications like enable and HAL deploy apply. And essentially what it does, it's actually like, Halyard just, makes this change to YAML files. So, but sometimes, like in order to enable Slack notification, you need to add some parameters to different YAML files. So that's why, like doing this via Halyard is safer. Okay, so, and 1 second, let me check Bex pipeline, caching, and stuff. Okay, I think we can move on. So let's talk about Kubernetes integration. So basically, Spinnaker actually work with manifest-based deployment, provided v2, and the latest versions of Spinnaker. Yeah, by the way, currently I'm using 1.2.2.2. So, Spinnaker versions all manifest deployment for rollbacks. I previously showed you that it does it for VM-based deployment as well. So it provides some health monitoring of your apps in Kubernetes. You can use deployment rollbacks, and has CI tool integrations. It's really kind of integrates with Docker registry. And Helm, it can be used as well in customized integration. It has UI. So let me show you. The easiest way how you can play with Spinnaker is to kind of spin up it on your machine locally. I have a Minikube. It's not needed anymore. Minikube. Status. Installed on Minikube. Okay, let's go to IntelliJ. And we have namespace. Yeah, like Spinnaker, as you can see, all services here. And we can do the same stuff here. So Kubernetes get Spinnaker. Yeah, here we go. So let's open it. Can get service in Spinnaker. So we just need to go to deck. Okay, Minikube. Okay. And we need to 3.3.3. Yeah, here we go. So as you can see, I installed it locally on my machine, right? And on Minikube. So if I go to applications, I have a Spring Pet Clinic here. It also provides this view to Kubernetes, right? I can see all my pods here, some details, get some details here. For instance, I would like to check out the logs. So here we go. I can get some logs from application. You can also, undo some rollout stuff. If you just decide, okay, there's a bug, you can undo rollout. And we have some, view to replica sets. Applicable bands. As you can see, Spinnaker adds some additional labels here. So, and the way how you have this integrated, let's take a look at pipelines. I think I don't need it. If I go here, we have a deployment pipeline. So, we have a automated trigger Docker registry. I just kind of listen for a Docker image, it's called Spring Pet Clinic Spinnaker. And whenever, I have my application updated, right? Whenever it's something changed, I mean a new image is pushed, this pipeline is triggered. Yeah, it's automatically kicked off. So because I have a trigger enabled. And so, actually Spinnaker just deploys my manifest. If I go here to deploy section, as you can see now I have my account, Kubernetes local. I just need to provide a namespace, and here's my manifest. So ideally, right, it should be stored somewhere and provided as an artifact, but for demo purpose, I can have it here. And as you can see, there is this Spring expression language, spell. So we really know about that, we're familiar with this. So this is a way how you can change and specify the specific tags that you would like to deploy here. It means that, text is gonna be retrieved from configuration, configuration phase. You can just say, okay, I would like to deploy this stuff. And if I go here to 0 and say start manual execution, I can just deploy, and I can specify which version I would like to deploy. So, and yeah, I can add a bake stage. If I go here and add some stage type bake manifest, and here we have all those render engines like Helm 2, Helm 3, and customize. I don't need it. Remove stage. Here we go. I don't think it makes sense to launch it just to save time, right? You can do it by yourself. So, but I highly recommend you to play with it. Just install it locally, and that's it. Not a big deal. Okay, let's move on. Let me check if I didn't miss anything. Destroy. Okay, here we go. So, and guys, one thing that I need to point out, don't think that, you can just take the tool and it will solve all your problems, right? It's just a tool. So, because I just prepared some hints for you from Captain Obvious, because, if you somehow miss it, I don't know, accidentally, read about 12-factor app. It's really important because you should understand how to configure your application, how to develop your application to be deployable, maintainable, and so on and so on. So, and there is a book, really nice. It's called Beyond 12-Factor App. And keep in mind that you should also think about how to write your code and should be backward and forward compatible. I'm talking about APIs, database migrations, and to make it stateless whenever it's possible, and try to follow this practice like immutable infrastructure as a code. So, and this really, really good phrase, treat your servers like cattle, no, not pets. Yeah, that's really true. And there is a Red Hat Principles of Container-Based Application Design white paper, so I highly recommend to read about that. So let's sum it up. I think that Spinnaker has some advantages and disadvantages, right? It's just a tool, so nothing ideal, nothing is perfect. So, and let's talk about advantages. So we just got one tool to deploy to cloud services. So it means that we may have one tool, we just know how to deploy an application to AWS, and you can use the same tool to deploy to different clouds, so like to Google Cloud or to Azure, right? Because as I said, Spinnaker tries to abstract all this stuff. It's kind of on top of infrastructure. It provides this like application-centric view. And you can run multiple cloud providers at the same time. Because like if you just need to have like 8 nines SLA, right? It makes sense to deploy application to different cloud providers. And Spinnaker provides best practice out of the box. That is actually one of the biggest like major features that it has, because you don't need to reinvent the wheel. You just need to use it, follow this best practice, and kind of is like doing everything with minimal effort. And one thing that I need to add is that all these integrations that I show like with AWS, right? The same stuff can do with Kubernetes and Google Cloud. And actually, as I know, Google kind of worked with like Netflix to do the stuff with integration. So it means that you receive this integration from providers. So everything should work like really stable. It has developer-friendly UI, so it's super awesome. I'm really kind of keen on this UI because it's really kind of amazing. And engineers and developers really like it. Yeah, and in my experience. So, and written in Java and Groovy. And as far as we like most here Java developers, right? It's really nice that we can use this tool because it's written in Java and Groovy, and then we can easily troubleshoot. It's because it's not a problem for us to deep dive into the Java code or Groovy code, and it's written in Spring Boot, guys. So it's stable. I can tell you that we have been using it for around like 1 year, like give or take. So and it's really stable. So it's really nice. You just need to spend your time on like to configure it from scratch, and it's working really nice. It's super stable. So let's talk about disadvantages. So actually, like the first constant learning curve, right? That's not really easy. Like, especially like when you just try to install it from scratch, it's really hard, guys. I can tell you that, because you can watch different videos on YouTube, how many guys just using Spinnaker and say, okay, this is really nice, just take it, give me 2, please. Yeah, but anyway, I can tell the installation from scratch is really hard. But you just need to play with it, and and then everything will be easy only after that. Documentation could be also improved. Sometimes it's really hard to find something. I really like Armory documentation. It's even much better to me than like or Spinnaker docs, because you can find almost everything you need. I really like it. It's awesome, and it must be hosted. Because it's no cloud version of Spinnaker. Yeah, I think you can use Armory, yes, but anyway, but I don't think to be honest, it's a disadvantage. Sometimes it's really nice because in our case, because we can't use any cloud services, we can do this because I can actually remove fixed bugs in production. And so it's heavyweight, right? Because it requires at least like 12 gigabytes of RAM. Yeah, but I can tell you that you can launch it with 8 gigabytes. That's what we do. Yeah. So, but anyway, because there are a lot of like microservices, and troubleshooting is hard sometimes. Yeah, because you can receive confusing error message, because sometimes you can say it's error and something went wrong. You can say, oh my God, what should I do with it? And this way is just to check the logs and maybe deep dive to the code base and try to find an error. So, and I think that's pretty much it what I had. Thank you so much, guys. Yeah, and I also prepared some resources for you. This is like Spinnaker website and Armory docs are really awesome. Yeah, I highly recommend you to join Spinnaker Slack channel. You may find a lot of like useful information here, and it'll help me several times. So there is a book about Spinnaker, pretty small, like about 80 pages, something like this. And there are two different YouTube channels with a lot of like video resources about Spinnaker, and you can get some experience from different companies and so on, so on. So that's pretty much it, I believe. That's all I had for today. Thank you guys for joining. I'm really looking forward to receiving your questions.
Yes, thank you, Igor. Thank you so much for your talk and for joining our conference today. Since we have 5 minutes left, I will probably read one question we have in the chat for you. So the question is, why do you prefer to use native OS image for running web application? What is the profit if compared with common approach when jar file running inside Docker container is used?
Yeah. I can tell you. So, basically, you know, as I said, we have monoliths, right? We have a monolith application, and we just decided to try it out. So, like, basically, Netflix suggests you to use it this way. Like deploying the stuff. Yeah, I also think that sometimes it's kind of really like verbose because you need to have a jar, then you need to pack it in an RPM, and then you have an MEI, so kind of really sophisticated because you can also deploy only jar. You don't need to even use like Docker. So, but I think it's worked really nice, and you can achieve all your like goals, like the same way because you know how this stuff is sold, like use like Docker, right? You can just optimize some resources. You can have one image and deploy it to across different ones. I can do the same, guys, because I'm on AWS. I can have one MEI deploy different ones. Yeah, it's not that fast. One of the biggest disadvantages of that it's, it actually let me check the pipeline. So it actually takes around 10 minutes to deploy, right? And we don't deploy really often. So we currently deploy maybe up to 10 times to staging environment per day and once to production. So it works very stable. We just decided to try it out. It's working nice. Why should I change something? Because, so what is the purpose, of that? I don't see any issues right now because it's working stable, and fine. Yeah.
Okay, thank you, Igor. Dear participants, you can join the Q&A Zoom room session with Igor and ask your questions if you have more of them, or to have a discussion with Igor on your issues that you have with continuous delivery and so on. Okay, thank you so much. Thank you for supporting Devoxx Ukraine online this year, and we hope to meet you in person next year at Devoxx Ukraine.
Yeah, not at all, guys. Yeah, thank you so much.
Thank you. Dear participants, and I want to remind you that you can vote for the best speaker and best talk using the mobile application Devoxx. You can install the mobile application using the links at the user page, and the winners, the best speakers, will be announced today at the closing ceremony. And in a minute, we will start our Kahoot game with gold partner of Devoxx Ukraine this year, Playtika company. So join us. Hello. We are glad to welcome the gold partner of Devoxx Ukraine, Playtika company, and its representative Alexei Kisilov. Alexei, hello.
Hi.
Hi, welcome to Devoxx Ukraine Online. And what Kahoot game have you prepared for us today?
Hi everyone. First of all, happy to be at such a great event despite the rough times. I'm manager from Playtika, and in this time slot, I will say first of all a couple of words about Playtika and our R&D department in Kiev. And our Kahoot quiz will mix actually information about Playtika and some tricky Java questions. So pay attention to what I will say and just try your luck. So right now I already generated a Kahoot quiz game and its pin. So if you see my screen, what you should do is to go to kahoot.it website or use the Kahoot mobile app if you have it and enter this PIN code. And while we're starting to get in people, couple of words about Playtika overall. Playtika is a leading gaming company. It was founded in 2010, and now it has a lot of games with almost 30 million monthly active users. It was among the first to offer free-to-play social games and on social networks and after on mobile applications. We have like 3,500 of employees through all over the world. We have headquarters in Herzliya, Israel, but we have offices in Tel Aviv, London, Berlin, Montreal, Chicago, and many other cities, including 3 cities of Ukraine. It's Dnipro, Vinnytsia, and Kyiv. In Ukraine and Kyiv in particular, we have our core R&D department that delivers a platform of more than 100 microservices written in Java. And this platform provides to all our games core functionality and different bundles like contests, clans, missions, and so on. And every Playtika game integrated with this platform can use the power of it. And I'm very proud of it, and I'm very proud of the high loads it can take with all these 30 million active users. And I'm proud also that the pipeline we built allows us, like department of more than 100 people, to make 2,000 deploys on our environments last month. I think the people are coming, so a few words, maybe a few promotions. We also will have a raffle later this day. We will the prize will be rather fruitful. It would be a MacBook. And also I would like to promote the speech of our colleague should be today. He would tell us about some interesting case and interesting research he made here in Playtika. So I think, yeah, one more thing. All 8 questions will have 1 minute for you to answer. But because of the delay, I think it would be less time than 1 minute, so you'll be able to pick an answer like in 30 seconds gap. So keep that in mind also and try your luck. Okay, if number 74 will be here at least for, okay, 77. We're still getting people, so probably 10 to 20 seconds and we will start. 3 persons actually from this Kahoot quiz, rather prizes. Okay, so 5, 4, 3, 2, 1. Okay, let's start. This one should be easy. It was mentioned at least 2 times. The answers are going. It's great. Okay, we have a lot of right answers. Good start. I think after the half I will name the main contestants for the win. This one wasn't named particularly, so a little bit of luck or a little bit of Googling. Yeah, probably I will also name the question. Number of Playtika office locations around the globe is. Okay, 33 right answers. It's great, but it's less than half of all the answers we have. Let's go. Third question, how many microservices there are in Playtika platform? We mean the platform that we built here in Kyiv. It is a core bundles. It has its core functionality like segmentation. It has a lot of features, stuff like missions, contests, and clans. So, how many? Okay. A lot of people, yeah, were thinking that it should be the highest number, but not. in some day we will have 300 microservices, but now it's 125. So I will start. Funny Monkey for now is the leader, with Doctors and Andre is the second and third. Next question, how many people work on Playtika products? With the answers of 3,500, 5,000, 500, and 180 employees. This one was definitely named in the video and in my speech, so hopefully it would be easier than the previous. And yes, it was the easiest one as for now. 3,500 is the right answer. But it also matters the speed of your answers. So as we can see, there is not a big changes here. Now some Java questions. What will be the output when we enter 1 plus 2 plus 3 with some additional thing, plus 4 plus 5? Some of classic tricky questions from all Java quizzes. I hope that this question will be also the easiest, but okay, yes. Yeah, first two integers will be treated as integers, and then it will be the string, and after that everything will be concatenated and Java will handle it as a strings. Good job. Nothing changed, just Funny Monkey is going to the stars with his score. Again, some strings question. What will be the output if we compare these two? Okay, fairly simple as we see. Yeah, it's the same object, the same place in memory, that's why the result will be true of such comparison. We have new third and second place. Andre is second and Rini Vesio is third, with Funny Monkey being our leader. What is the Balmer Peak? It's either a mountain in South America or correlation between imbibing in alcohol and cognitive ability improvement, or it's the name of Steve Ballmer's yacht. It's a mountain in North America. Okay, not so easy as I thought. It's a famous correlation between alcohol and some cognitive skills. If you're not heard of it, please Google it. It's really interesting. And the last question. Yeah, see what's going on here. Funny Monkey, BG, and Ekem Rayev are the top 3. The last one. What is this? And some strange things. There you can see a pattern probably. Is it an assembler? An SMS of after 5 bottles of beer and average code in Playtika, or load? The faster you answer, the more points you get. Yeah, it was code, and almost everyone knew it. So, this is our podium. Cookie, the 3rd place. Funny Monkey, our leader, became 2nd, and who's the winner? It's RBG. Guys, please contact us, and you will have some prizes. That was our Kahoot. Thanks, guys.
Thank you. Thank you, Alexei, for this exciting Kahoot game. The questions were really funny, some of them. So thank you. The winners, I congratulate you, and please join the Playtika chat. You will find the link at our user page, and contact the Playtika company to get your prizes. So thank you once again for supporting Devoxx Ukraine Online, and hope to see you next year with us.
Yeah, I hope too. Thank you, guys.
Thank you. Yeah, dear participants, also I will remind that Playtika has some other prizes raffles, and the main prize is a MacBook, so you can register for this raffle and the winner will be announced at the closing ceremony. And now I'm glad to introduce our next speaker, Ben Evans.
Hello, everyone.
Good afternoon, Ben. How are you today?
Hi. I'm very good, thank you. And thank you so much for inviting me to come and talk today. I'm only a little bit sad that it's virtual and that I can't be with you there in Ukraine today, but hopefully next year.
Of course, we all hope for next year. And thank you very much for supporting us in online format. I know it's a bit challenging, but still we're glad that you joined Devoxx Ukraine Online. So I will not steal more time from your talk, so please, the mic is yours. Just start.
Thank you. Okay, so I'm going to maximize my screen, and hopefully it's going to come up now. Okay, excellent. So the title of my talk today is why you should migrate to Java 11 right now. And that's based on some of the work that I have been doing over the last, I guess, 18 months, almost 2 years, working at New Relic. And by the way, this title slide, which has this kind of nice background on it, it's actually a stylized view of where we go in Oregon, in North America, to have our annual company retreat. And it's got mountains and woodlands, and it's really nice. So I like this title slide because it kind of reminds me and hope for some travel and for getting to see everybody again. Okay, so I do work for New Relic, and because of that, I actually have to show you this slide. And what it basically means, it's a safe harbor slide. If you're a publicly traded company, then if you give a technical talk, you have to show this slide. And basically, it says that you shouldn't make any financial decisions, or invest in any companies based on anything that I'm about to tell you in this presentation. Okay, this is purely technical information, and it's not for financial advice of any kind. Okay, so for people who have not met me before, my name's Ben Evans. I use he/him pronouns. And I am currently the principal engineer and the architect for JVM technologies at New Relic. Before I started at New Relic, I actually founded the performance company JClarity with Martin Verberg, which we sold to Microsoft last year. So that's kind of an interesting startup journey as well. Before JClarity, I spent a lot of time working in banks and in finance. I was the chief architect for listed derivatives at Deutsche Bank, and I was working at Morgan Stanley during Google's IPO, which was quite a few years ago now. So normally, if this was an in-person conference, I would say if you want to hear those stories, then come and find me in the bar. But that's going to be a little bit difficult because I'm at home in Barcelona right now. As well as my career and the sort of corporate side, I've also spent quite a lot of time working with the community. I'm a Java champion. I won the Java Rockstar Speaker Award several times. I should probably update that because for younger people, they probably don't know what Java 1 is. It's been Oracle Code 1 for a number of years now. So maybe I should update the slide. Never mind. Apart from those two awards, I was also part of the Java Community Process Executive Committee. That's the body that creates and ratifies all new Java standards. And I served on that as a community representative for 6 years. And during all of that time, I was living in London and helping to organize the London Java community, where, along with Martin, I was one of the people that helped to found a project called Adopt Open JDK, which I think that quite a few of you will have heard of by now. So that's me. That's a bit of background about who I am and what I've been doing. So let's turn to what we're going to talk about today. Well, today's talk is all about Java 11, and it's really grown out. The material I'm going to present has grown out of the discussions that we've had at New Relic about what we do with our own internal fleet, and also about how we support our customers. So I'm just going to send literally 2 or 3 slides introducing New Relic to you, because I know that not every developer has heard of them or has used our product. So it's important just to explain why we've been on this journey internally, I guess. And then I'm going to talk about Java 11 in context, and of course the real meat of the talk is why 11 is such an important release, and what those reasons, those good reasons and practical things that are good that happen to you when you go to 11. So that will be probably the longest section, and at the end we'll have conclusions, and then I guess we'll go for some Q&A in the chat room. Okay, sound good? So let's start off with just a couple of slides about New Relic. So New Relic is what is sometimes called a performance monitoring company, or these days the term very much is what's called an observability company. And the idea is modern software stacks are really complicated. Even if you're just a Java shop, which maybe has, a React front end to your application, software gets more and more complicated over time, and it gets harder and harder to figure out what's going on. So some companies, they try to build their own tools for trying to understand what's happening in their production systems. But the truth of the matter is that reliably building monitoring software is really hard. And for most companies, it doesn't it's not their core competence. It's not something that, it's a cost center. It's something which is going to tie up their good engineers, and it's not actually producing business value. So companies like New Relic and our competitors exist basically to provide that service for you. So you can just not worry about how to understand what's going on in your production systems, how to instrument them, how to get the data and what the data all means, and that we will collect the data for you and bring it into a form that you can understand. And we handle billions upon billions of events from our customers per day. We're one of the largest observability and monitoring companies in the world. And we have a thing called New Relic One, which we describe as the world's first observability platform. So it's basically a single place to put all of your data about all of your systems in. We are very much an open source company. We recently open sourced pretty much all of our technology. One of the things I've been doing over the last 18 months is pivoting New Relic from being a mostly proprietary company to open sourcing virtually everything that we can. So, and now we just passed the milestone. All of our software agents and every bit of code that we put into a customer system is now completely open source, and we're building towards doing more with open standards as well, which is amazing. And for us, Java is really important. We are especially Kafka. So Java and Kafka is kind of our two biggest things that we use the most of. We actually have one of the largest Kafka installations anywhere in the world, and we have a lot of use of the Kotlin language as well. So this is the kind of the background, and our overall architecture kind of looks a bit like this. So if you imagine that this is the blue box is the New Relic architecture. You put a little blob of New Relic code, the agent, into your Java application or whatever other language you want to use. We don't just do Java. We do Java, but it's not the only thing that we cover. We cover pretty much every modern language and framework. And those agents report data into our pipeline, which is all kind of Java services and microservices all the way through. A lot of Kafka, and eventually there's a dashboard which displays your information back to you. So this is kind of the key part of our pipeline. And pretty much all of this is either Java or Kotlin. So we have thousands of JVMs, actually probably more like tens of thousands running at any one time. So we obviously are very conscious about what's going on. Java is a really important technology to our customers. It's also very, very important to us ourselves. So we were, when I first joined New Relic, we were right at the start of our journey with Java 11. So that was probably 18 months ago. At that time, Java 11 had only been out for about 6 months. And it was really not clear what the road forward was going to be. So having just done a brief introduction of New Relic and our architecture and why we care about it, let's talk about Java 11 in context. Let's talk about some of the things which have gone on in the ecosystem in recent years, which are important. And this is kind of not the sort of thing which developers normally are that interested in, but it is really important. We need to understand a little bit about licensing and about how Oracle's Java has changed in the last year. So it's coming up to 18 months now when Oracle actually changed their support model. And it does have huge impacts on the entire Java world. So if you haven't understood what those changes are, and a lot of people still don't, it's important to take a few minutes just to talk about that. So let's start by just doing a little bit of history, and then we'll talk about the release and support model. I'll talk about the new way that Java releases are developed on what's called a mainline model, and then we'll talk about OpenJDK 8 and 11, and then a little bit about future plans as well. All right. First of all, though, let's get into our time machine and let's go deeply far back in time. Let's go all the way back to 1995, 25 years ago. It's incredible to me that much time has passed now, that we're now talking about entering the second quarter century of Java, if you can believe that. It seems just impossible. I don't know where the time goes. There is actually another point here, which I think is worth taking just a slight detour just to mention, because I don't think people always realize this. When you think about Java, when you look at it, you should always remember that it was a language that was born in the late 90s. It's a very forward-looking, a very opinionated, and a very advanced language which is trying to push the envelope of software engineering. But it was a language which did all that 25 years ago. So when some people criticize Java and say it's very old hat, and it's very mundane, and it's very middle of the road. Well, it is now, but it wasn't back then. 25 years ago, it was out on the edges. It was cutting edge, and if it's mainstream now, that is because it correctly predicted the future. If it's mainstream now, it's because the mainstream has moved to where Java is. There's an old quote in American politics. Ronald Reagan once said, because he was originally part of the Democratic Party, he said, "I did not leave the Democratic Party. The Democratic Party left me." And with Java, it's kind of like that. Java did not become mainstream. The mainstream grew to accommodate where Java already was. So it's a good way to think about that in terms of why Java is the way it is. Anyhow, so 1995, Sun released Java. LiveScript, which was the original name for JavaScript, changes their name from Netscape to cash in just on the popularity and the tech hype that was surrounding Java. If you ever wondered why JavaScript has a similar name to Java, that's it. That's the only reason why. So that's our first milestone. This is a 10,000 foot view, a super high level view of the history of Java. We're going to fast forward 11 years in one go. In 2006, Sun finally finish open sourcing Java. It takes them 11 years. And before that, Java is kind of mostly open sourced. A couple of things aren't, a lot of things are. And that basically led to some problems. And Sun finally got around to finishing the job in 2006, which, by the way, is when the OpenJDK project was born. Just one of the reasons I mentioned this here. Next big thing that happens after a jump of 11 years, a jump of only 4 years. 2010, Sun Microsystems run out of money and are on the verge of going bankrupt when they are acquired by Oracle. And Oracle basically take over Java and all of the other Sun technologies. So this gives you some idea of where we are. So Sun Microsystems ran Java for 15 years. Oracle have now run Java for 10 years. So it's not quite equal, but it's getting there. It's getting there. So Oracle, one of the main things they do is they convert all of their release train and the way that they develop Java so that it is based on the open source code base. And this is really important. Lots of people don't know this, but Java 7 is based on the open source code base. Java 8 is based upon the open source code base. All of the Oracle releases start from open source code as of Java 7. Okay. OpenJDK 6 is a bit weird. It actually doesn't quite correspond to a version of Java 6, but from Java 7 onwards, the Oracle releases are built on top of the open source code. Next up, we're going to jump forward another 6 years, and now that's taken us up to the release of Java 9. Java 9, the release model changes. So we'll talk about the release model in a second, but until Java 9, there has been one release model, which has been about the availability and the completedness of major features. So, for example, Java 8 did not ship until Lambda expressions were finished and they were actually ready, and they had no known high priority bugs. Yeah. Java 9 did not ship until modules were ready. And I want you to understand the difference in release model here between a model which is based upon an important feature and the release ships when the feature is ready, which is the old release model, Java 7, Java 8, Java 9. They're all based on that model that you don't ship until the feature is finished. Whereas from Java 10 onwards, so Java 9 was the last release on the old model. The new model, as we'll see, is purely time-based. And that is a subtle difference, but it's actually quite important in terms of the way that software is built and released. Okay, and then the final point, 2 years ago now, so September 2018, the current long-term support release, Java 11, was released. So that's another important milestone for us. I'm going to talk a lot about that. So just in case I haven't made this point sufficiently clear, let's hammer it home. Java has been open sourced since 2006. And since Java 7, Oracle JDK and OpenJDK are basically the same. If you're running your apps today on Oracle Java 8, it is almost identical to OpenJDK 8. And if you are a server-side developer, as I think most Java people are these days, there is virtually no difference. People sometimes think that there is a different JIT compiler or a different garbage collector in Java, Oracle's Java versus OpenJDK. That is not true. That is not true. So Java 9, OpenJDK is now the official Java. So with the release of Java 9, Oracle Java kind of disappears. Oracle start releasing OpenJDK binaries themselves. So the convergence is complete. For most people, there isn't really such a thing as Oracle JDK anymore. And unless you are paying money to Oracle, you don't really get access to the Oracle Java binaries anymore. Even if you go to the Oracle website and download them, if you're not a supported Oracle customer, you're probably downloading an OpenJDK binary. So OpenJDK is everybody's future. If you're going to carry on using Java, you are sooner or later going to end up running on OpenJDK. So this is it's not like the difference between Microsoft Office and OpenOffice or LibreOffice, where they're completely different products that just happen to support the same file formats. OpenJDK and Oracle JDK are basically identical. Talk a little bit about Java 9. So this is going 1 year back before Java 11, the version we actually care about. But it's just important to mention this. Java 9 was really late, and it has modules in it and the modular JDK, but it doesn't really have anything else. And it's the last release under the old model. And I sometimes, perhaps unfairly, refer to Java 9 as the Windows Vista release of Java. And that's not a bad idea to have in your head. Java 8 is kind of like Windows XP. It's a really solid release. People really like it, and there's absolutely nothing wrong with it. It will just keep on running, and Java 8 is going to be around for a long, long time. Because some people can't upgrade. Commercial companies go out of business and don't support their software on later versions, and so on and so forth. So I think there will be a legacy population of Java 8 for a long, long time. Java 9 is like the Windows Vista release. Java 11 is kind of like the Windows 7 release. So if you were in a corporate or an enterprise, when everyone held on to XP for ages and nobody really bought Windows Vista, but lots and lots of people went directly from XP to Windows 7. And if you think there's a parallel in there between migrating from Java 8 to Java 11, well, that's kind of what I'm getting at. So let's talk about the mainline release. Okay, so this is how it works. There are no big feature releases anymore. So there's no releases which are driven by a single most important feature like lambdas in 8 or modules in 9. That goes away. Instead, what now happens is there is a release of Java every 6 months, like clockwork. We've had Java 10, Java 11, Java 12, Java 13, Java 14, Java 15. We've had 6 releases already on this new model. So every 6 months, a new release is cut. If you are an OpenJDK developer and you are trying to create a new feature in Java, great, fantastic. If it gets close to the cutoff point for the release and you aren't ready, you are not allowed to merge to mainline. You have to carry on working in a branch, and you missed the release. Sorry, you got to wait for the next one. But you only have to wait for 6 months. So features are only allowed to merge to mainline when they are feature complete, and it's believed that they will be got down to 0 serious bugs before the release actually goes out. So that's really important. That changes the way that we develop software. Because now we have a regular schedule for releases, and features are merged when they're ready. But what it also means is that you don't end up with the problem, as happened with modules in Java 9, when there were a load of features that were stacked up behind modules that no one wanted to merge in because of the complexities of merging modules, and they basically didn't know how long they were going to have to wait to get their features in. So a regular release cycle, merging only when ready, promotes easier and less complex merges as well. However, there is a price to be paid for that. A new release of Java comes out every 6 months, but the releases are only supported for 6 months. So Oracle will only support a release for 6 months. So when Java 9 came out, it was only actually existed for 6 months. From 2017 in September to March 2018, when Java 10 came out. And as soon as Java 10 came out, Java 9 was marked as end of life. So if you want to stay at the cutting edge and upgrade your Java every 6 months, you can. And there are free binaries available from Oracle. And as long as you're prepared to keep upping your version number and every 6 months go from, well, currently it's Java 15. So if you're using Java 14, you'd have to upgrade to 15 now. And next March, you'll have to upgrade to Java 16. And then next September, you'll have to upgrade to Java 17. But if you're happy doing that, you can do that. And you can carry on using Oracle code. But there are no bug fixes, including security patches, after that 6 months is up. If you don't want to upgrade every 6 months, you have to do something else. And this is where the long-term support releases come in. So every 3 years, and the current long-term support release is Java 11, one release is designated as a long-term support release. And Oracle will sell you a support contract which allows you to stay on that version and get updates. Currently, that's Java 11, and they basically kind of brought in Java 8 as a long-term support release as well. So Java 8 has also retroactively been classified as a long-term support release. So when I talk about people transitioning from Java 8 to Java 11, that is why. They are the long-term support releases. Now, of course, that's still all about Oracle and Oracle support. Now, what we actually see is that other vendors are also adopting the LTS model. Because, of course, the Oracle code is based on OpenJDK. So the changes that go back into Oracle's LTS versions make their way back into the open source version as well. So you cannot get free support from Oracle after the feature release arrives, and other vendors may or may not offer intended support. However, Java 8 and Java 11 are LTS, long-term support releases, and they are still continuing to receive patches, including security updates. So if you do not want to pay money to Oracle or anyone else, and you want to keep using a free Java, as in a free as in beer, as is sometimes said, that it's zero cost. If you want a zero cost Java, your only choice is to be on Java 8 or Java 11 and to go to another vendor other than Oracle. You cannot get free support on 8 and 11 with up-to-date security patches from Oracle for free. If you want to be supported on 8 and 11 by Oracle, you have to pay for it. But there are places you can get a free zero cost binary for 8 and 11, which continues to be security patched. And that is the important thing that you have to grasp. So I've taken about, I guess, nearly 20 minutes already just to explain the difficulties of that licensing. And that is a problem. It shouldn't be that complex and difficult for teams to navigate. But it basically boils down to that. If you have money and you're prepared to pay Oracle or Azure Systems for binaries, then you can do that. If you do not want to pay money for a Java runtime and you want security patches, you have to go to OpenJDK. There is no other way of doing it. So you decide which you are going to do. Do you want to pay some money and go to Azure or Oracle? Or do you not want to pay money and go to OpenJDK? Okay, so the relevant versions we have the Java 8 LTS, which is 2014, which is 6 years old, right? That's the big thing to take away from this. And yes, it's still being security patched, but it's a 6-year-old runtime. Lots and lots of technical improvements have been made in that time. And right now, Java 8 is about 75% of the market. I know that because I work at New Relic, and our customers can choose to share data with us, and most of them do. And among the customers who've chosen to share data, which we think is about 1% of all of the Java virtual machines worldwide. So it's a pretty big sample. I mean, I see data from tens of millions of Java virtual machines every day. And based on those numbers, I can tell which version of Java people are actually running in production. Not a self-reported survey or anything like that. I see the actual production numbers. And I can tell you that it's about 75%, 70 to 75% of people are running Java 8. And the LTS release, it varies, but it's pretty much the rest. Java 8, let's say 75%. Java 11, between 20 and 25%. And the rest, well, there's 2 or 3% of people running Java 7 and below. And the rest is just noise. So there is nobody really running the strategy of adopting every new release as it comes out, and of upgrading every time a new feature release comes out. So there's not really any Java 9 or Java 10 or 12 or 13 or 14 or 15. It's Java 8 and it's Java 11, and that's it. So I think I've covered this, but Oracle's role is starting to diminish. OpenJDK is gaining more and more prominence, and the non-Oracle Java vendors are starting to get more important. You can still get free support, but only from an OpenJDK vendor, and only for versions 8 and 11. So those are your choices. So who am I talking about? Who are the new players in all of this? Well, there are some names I think that you're probably going to recognize on the next slide. Red Hat, of course, with their ICT product. IBM, who actually have a different virtual machine. The IBM offering is not actually based on Hotspot, which is the VM that most people know, but they have their own virtual machine called OpenJ9. And that's actually part of the Eclipse Foundation now. But they're still a strong player. Now, there's also Amazon, who produce a distribution called Amazon Corretto for AWS. And it's kind of interesting because, as you can see in the picture here, we've got Duke with an ice cream cone. Now, it's Devoxx, we're all adults, so I can probably tell you that a Corretto in Italian is not an ice cream. Instead, a Corretto is a double espresso with a shot of liquor, usually grappa, because it's Italy. And it's not ice cream, and it's not very family friendly. So I don't know what happened here. I think maybe they took the name Corretto because it was cool, and then the marketing department decided that they needed something a bit more family friendly. But never mind. The one that I'm most familiar with, and I'm still involved with in some ways, is Adopt OpenJDK. And this one is actually the largest producer of non-Oracle binaries in the world. Adopt OpenJDK is, after Oracle, the largest supplier of JVMs. So if you don't know what to pick, and you need to get off of Oracle because you don't want to pay money and you need security patches, Adopt OpenJDK is a great choice. If you work purely on AWS, then maybe Amazon Corretto. Sure. I mean, all of these vendors are good choices. There aren't any bad choices here. I tend to use Adopt OpenJDK, but I know a lot of people have a lot of success with Corretto as well. Two other of the smaller players, Azul Systems, they mostly have a paid-for offering, but they do also produce free binaries as well. And if you're planning to maybe buy a support contract, maybe try out the Azul free binaries first. And then, of course, Alibaba, who produced this distribution called Dragonwell, which is I think really designed for their own internal systems, but they also do make it available to people worldwide as well. So those are the new players. And when you start picking a distribution of Java, it's kind of like picking a Linux distribution. Do you like Debian or do you like Red Hat? Some people like one and some people like another. Other people, they might want to go and have Arch Linux, or I don't know, some other distribution which is out there, Gentoo even. But it's still the same Linux kernel, and it's still a lot of the same program code in each case. And that's very much the case for distributions of Java as well. Think of it like a Linux distribution. Okay, so we've talked, I think, about the mainline dev model, and so let's move on. OpenJDK 8 and 11 are now run by Red Hat, so Oracle engineers are no longer leading the OpenJDK projects at all. So let's talk about some of the future plans that are coming up. Well, there's obviously ongoing maintenance, security patches. That's the big thing that is still being put into OpenJDK 8 and 11. There's housekeeping updates. So things like, I don't know if people know this, but the Japanese era changed recently. When a new Japanese emperor arrives, they have to create a new name for the era and a new kanji character to describe it. So that was, and by tradition, that is not announced until the actual the succession of the emperor happens. So that's not known ahead of time. So Java 8 needed an update to change the Japanese era and add the appropriate new characters to the Unicode character set. One other thing which was really difficult on Java 8 is Java 8 was still being built with a really old, nasty version of Xcode. So the build scripts had to be upgraded and changed to run with modern Mac build time zones, build tools. Time zones, of course, are a perennial problem. Again, were we in person, I would say if you want to hear horror stories about time zones, come and buy me beer. And finally, TLS 1.3. As you probably know, TLS 1.1 is now known to no longer be safe. And TLS 1.2, at some point, I guess maybe 8-10 years from now, may also become unsafe as well. So just as a piece of future-proofing, TLS 1.3 support has been backported to Java 8. So OpenJDK 8 has been upgraded with some of these, what I would call housekeeping updates. So there is potential for some new things to be added, but only very small things. So Java 8 and Java 11, the OpenJDK and OpenJDK 11 projects, are all about keeping the lights on. This is a maintenance mode project. We're not going to backport major features from further versions of Java. Okay, so that's the projects. So let's move into the next section, which is to talk about reasons for going to 8 to 11. Now, there are a million talks out there that you could go to about things like local variable type inference, aka the var special restricted keyword. You could talk about modules and Java platform module system and all of that, and I'm sure many of you have been to topics about them. You can talk about the new HTTP client library and HTTP2 and how much better that's going to be for your microservices, and it probably will be. But I don't want to talk about any of those things because I'm just going to assume that you know what those features in Java 11 are. And if you have a need or a desire to use those things, then you don't need me to convince you about why you should upgrade to Java 11 right now. So I'm not going to talk about any of those things. And I know that you'll be able to find content about them on the internet if you are really interested in them. So let us talk to some things which you might not have thought about, which I think are important. And this is informed by my time at New Relic. A decent version of the G1 garbage collector. Did you know that the version of G1 that is in Java 8 is actually very different to the version that's in Java 11? Not many people know that. The version of G1 that is in Java 11 is actually really pretty good. The version in 8 is okay. I do have some services on Java 8 that are running G1, but I have been aggressively encouraging teams that if they want to use G1 as their collector, they should come to Java 11. Related to that is an improvement called compact strings. So you probably know that in Java, a character, a char, is 2 bytes because it's a Unicode character, not an ASCII character. So it's a 16-bit char type. Now, if you have a string, which underneath is really just an array of chars, you know that if your string is written in ASCII or another Western European language, the half of your strings are empty because they're 2-byte chars, and the first byte of each 2-byte char is always 0. So you are wasting a vast amount of space for any string which is Western European by encoding the strings as array of char with 2 bytes per char. Internally, in Java 11, there was an automatic optimization which changes the way that strings work internally, and they actually become arrays of bytes rather than arrays of chars. So straight away, you get back all of those missing 0 bytes. The actual production overhead of that, I have seen heap size reduction of 30 and 40%. And when combined with going from the parallel collector to G1, the garbage collection behavior of an application on 11 can be completely transformed. One caveat, and I will say this several times over the course of the remaining time we have today. When you go to Java 11, especially if you're going to go into containers, you may find that you need to give it more CPU because G1 is a concurrent garbage collector. And because G1 is a concurrent garbage collector, you may need more CPUs available for your application. So you're getting a trade-off of much better GC performance, much smaller heap size, but to do that, you do need slightly bigger containers in terms of needing more CPU, just so that there is an extra core for when the garbage collector wants to run. So that's the first piece. The second piece is the performance improvements. Every time that a Java application is upgraded and goes to a new version, there is the possibility that there are some extra optimizations and improvements within the JVM which are able to speed up programs without recompilation. There are things like new JIT compilation intrinsics. There are changes internally which provide performance improvements. So generally speaking, upgrading will give you better performance. Java 8, especially below version 8 update 192, is not very friendly to containers. Very old versions of Java 8 update 102, for example, actually just ignore the fact that they're running in a container. And that can do very, very bad things to performance. Java 11 out of the box is container friendly. It understands containers and it will play nicely within a container without you having to do anything. So if you are running in containers, the GC and memory improvements that I've talked about, and the fact that the 11 is designed to be safe for containers, that is probably a good enough reason by itself to upgrade. What other things are there? A couple of minor things. If you do cryptography, you will find that Java 11 is much better. If you are running Java-based cryptographic, if you're terminating SSL or doing encryption, the services that do that will see much better performance on Java 11 due to improvements in the VM. And finally, it's future-proof. It's the long-term support release. So you can upgrade from 8, and then I tell my teams you don't have to upgrade again for a long time. So you get a small footprint, you get cloud friendliness, you get container friendliness, you get cool new tech to play with. And on the whole, I start to think that what will happen is I'll have a few teams that have sustaining business as usual applications that stay on Java 8. I'm already in the place where version 11 is what new applications start as now. So when a new application template is run at New Relic, it's stood up automatically as a Java 11 app. And then there's a process that I'm going through of migration and getting people to upgrade and bring their services from 8 to 11. I think I've talked about all of this. So what do we need to know to go along with the Java 11 upgrade? Well, you just upgrade the JDK and it might work. But what you are more likely to find is that some of your library versions also need upgrading. And one of the things that absolutely stands out here is the ASM library, which is a bytecode manipulation library. Now, you may think, what's that? I've never heard of it. I don't depend upon ASM. Well, you may not depend upon it directly. However, I think that if you look carefully, if you expand out all of your transitive dependencies in Gradle or in Maven, you will find that probably all of your applications indirectly depend upon ASM. ASM is used by so many of the other libraries that are in the ecosystem that even if you don't use ASM directly, you probably depend upon something which does. And ASM is very specific about which versions of Java it plays with, because it manipulates the bytecode. It has to be you have to pick a version which knows about the version of Java that you're using. So an older version of ASM, version 5 or version 6, will not play nicely with Java 11. So then you have to work out from your library stack what libraries that you directly depend upon you have to upgrade to, and then take their transitive dependencies as well. So that's one occasional stumbling block. But basically, I just treat this as an excuse to clean house. We're upgrading from Java 8 to Java 11, so it's an opportunity to make sure that all of our library versions are up to date with the recommended level for Java 11. So it's not as simple as just flipping the JDK version, but it's not that bad either. It's just one of those regular exercises of tech debt reduction that people should undergo every once in a while. There are still some very small things that aren't Java 11 compatible. The only two that I know of, and this slide should actually say the Thrift compiler. Thrift itself is absolutely fine on Java 11. But I think there is still one outstanding bug that if you actually wanted to build a version of the Thrift compiler itself, you would have to build the Thrift compiler on Java 8. You could then run the compiler on Java 11, but it won't build under 11. And secondly, Cassandra. And this isn't a Cassandra client, this is a Cassandra node. If you're running an actual Cassandra node, you have to run it on Java 8 still. Cassandra 4.0 does support Java 11, but that has not become generally available yet. So we're still waiting on Java on Cassandra 4.0 before full Java 11 support arrives. So that's it. Obviously, if you're running a Cassandra client, that's fine on Java 11. Okay, so that's sort of a short list of the things that we need to know about. So why do we upgrade to Java 11? The first major reason that we gave is to do with licensing and how licensing has evolved, and the fact that if you don't want to have to pay money for Java support, you have to upgrade to Java 11 or OpenJDK. You could, I suppose, stay on version 8 and just move to OpenJDK and get security updates that way. But the second reason is really about cloud and container behavior and just better performance. It's Java 8 is a 6-year-old runtime now. So you get 6 years of major software engineering improvements from the people that actually make the platform for you. So it's just a good housekeeping exercise. If you're running in something like AWS, the fact that you can get away with much smaller heaps may actually mean that your AWS bill comes down. So there are potentials to actually save quite a bit of money here if you move to a runtime which is more suited to working containers in the cloud. One other major reason, I'm going to spend the last 10 minutes of my talk talking about this. This is really dear to my heart, the next subject. Java Flight Recorder. So I've been interested in performance of applications for many years now. The Google IPO, for which I was the performance engineer, was 2004. And it was, in those days, actually very difficult to get good, accurate performance data about Java applications. Java Flight Recorder is the tool that I wish that I'd always had in many ways. What is it? It's a profiling tool built into the JVM. It allows you to gather profiling data, diagnostics and telemetry data from a Java application while it is running without needing to stop it. And in fact, you can actually dynamically start Java flight recordings from a Java application that is not configured for it. So if you start to notice your application is suffering, you can actually switch on Flight Recorder and say, hey, let's actually start capturing data now. I want to see what's going on. It has a long history. In fact, it originally, the acronym, it's always been JFR, but it didn't originally start being called Java Flight Recorder. Originally, its first name was JRocket Flight Recorder. Yeah, so it actually came from Oracle's acquisition, not of Sun Microsystems, but of BEA. So when they bought BEA Systems and WebLogic and the JRocket VM, Flight Recorder came in at that point. So they integrated it with Hotspot and they turned it into this proprietary tool, which was part of the Oracle JDK, and it's in Java 7, and it's in Oracle Java 8 as well, but it's proprietary, and you have to pay money to Oracle to use it in production. And as part of the reorganization and move to the new release model, Oracle basically decided to open source JFR as part of Java 11. So earlier versions of Java don't have it. The open source version is in Java 11 onwards. And there is actually a backport of Java Flight Recorder to OpenJDK 8. So there's a version of it in very recent versions of JDK 8 as well. But I typically think of it as a Java 11 tool. The most impressive thing about JFR is its low overhead. Now, Oracle have always claimed that the impact is about 1%. Having tested it quite extensively in the New Relic environment, we think it's more like 2 to 3%, which is still incredible compared to many profilers which have an overhead of perhaps 15% or even higher. A 2 or 3% impact is well within the tolerances that virtually all applications can take. So that's a solidly engineered piece of kit which is able to, because it is so deeply enmeshed within the JVM, it's able to produce this very, very low overhead, and it's a spectacular piece of engineering. So most people normally interact with with Flight Recorder by a tool called Mission Control, or Java Mission Control, or JMC, which is a GUI tool. It's a desktop which sits on your Mac or on your Windows machine, and enables you to look through a pre-recorded Flight Recorder file normally. We'll see some screenshots of Mission Control in a sec, but first of all, let's just tell you how you use it from the command line. So you can start it up ahead of time, and you can say, I want to start Flight Recorder. I want to generate a flight recording of 200 seconds at startup, and then stop and dump the file out. Now that's okay. It's a bit simplistic, and it can be very challenging to work within containers, because how do you get the file off of the container? If you're in Kubernetes, how do you manipulate a file that's just been dumped onto the local file system? So fortunately, there is a streaming solution. There is a solution which you can use, but the problem is JFR streaming only exists in Java 14, which is not LTS. And we did initially think about backporting it to Java 11, but that was decided that was too much. That was a bridge too far in terms of what backports were going to be done into LTS versions. So there will be no streaming available in an LTS until Java 17 next year, which makes me kind of sad, because the Java 14 streaming is actually really, really nice. But not to worry, there's still more things we can do with JFR to help us. There is the J command. So if you are able to get onto the local machine and run a command on the same machine as the VM you want to get flight recordings for, you can use J command to do that. You can just say J command on the PID, JFR.start, give it a name, and then set it, and then it will run continuously at that point until you dump the recording, and then you can produce a file, and then you can stop the recording once you're done with it. However you do it, whether you do it this way or you do it with the command line parameter at startup, you'll end up loading.
Yeah, Ben, unfortunately, we lost sound from you just 10 seconds ago. Yeah, nope, still no sound. Yeah. Nope, sorry, still no sound. Yeah, our tech support asks you to refresh the vMix page.
How's that?
Yeah, now we do hear you.
Okay. Sorry about the slight delay, folks. Technology, isn't it wonderful? So this is the one of the screens you'll see in Java Mission Control. And if this looks a bit like an Eclipse IDE set of windows, then you guessed correctly. It's actually built on the Eclipse toolkit. So you can see in here the sort of down the left-hand side, you've got a bunch of different things that you could explore within this recording file. And this is basically showing a kind of a heads-up view where you've got some customizable things of different high-level telemetry that you might look at. You know, you've got your CPU usage, the heap usage, and allocation rate. So this thing is absolutely churning through data. It's actually doing 32 gigabytes in a 15-second window. So it's doing at least 2 gigabytes per second, which is really pretty impressive. And if you're have very sharp eyes, you can look at the stack trace and you can see that what it says is it's actually a benchmarking tool from Amazon Corretto called Hypothesis, which is just one of the tools that I use when I'm doing performance work. So you can use this to explore the recordings, and there are some other nice things. For example, this is the memory histogram, so that you can show what the most commonly allocated types are happening within the recording. So this is all pretty nice stuff. You can step through. You can see detail, and I've zoomed in here quite a lot of the TLabs. So what I'm showing you here actually is the allocation behavior of each individual thread. And so what you can see is that, and this is from a real test application at New Relic, and we do a lot of Kafka work. So of course the Kafka thread is actually the one that's the busiest, and in just a period of, I guess, an hour, it's allocated 10 gig of memory, and you can see all the other individual threads which are there. So it's kind of nice. It can show you what the hot parts of your application are in terms of memory allocation very easily there. There's method profiling, so you can actually do sort of traditional execution profiling and seeing what classes and what methods tend to produce the most activity. So this is like a histogram of execution, I guess. There's other things in there as well. There's things like the JIT compilations, so you can see a compiler duration histogram, how quickly a method's being compiled, and what you can do from here is just to check that all of the methods that you care about are actually being JIT compiled, and so that none of your key methods are actually going to impact. Some very quick best practices. One of the ways that I use it, if I can actually physically access the machine, if I can SSH onto it, is to set JFR up in what's called a ring buffer mode, so that it basically constantly keeps the last window of time, maybe the last 1 hour of time in memory, and then I can use jcommand to dump the file. So if there is a problem, I can quickly jump on the machine, dump the buffer, and then I can go backwards in time to before the problem started on the machine and actually see what went wrong. There is an API for parsing the files, which I'm just going to show very quickly. The key class is recording file, and once you've got a recording file, you can basically just step through it in kind of like an iterator and take events out, and you can actually parse and analyze JFR flight recorder files by just writing a very quick bit of code. To finish off with the last couple of slides, I'm just going to mention that we actually have just released as generally available our support for Java Flight Recorder. It's called Real-Time Profiling for Java. It's open source, and you can install a little daemon on your machine which will listen to Java Flight Recorder. It talks to it over JMX, and it sends the data up into New Relic. So if you install this daemon on all of your machines, you don't have to mess about with Java Flight Recorder files and starting and stopping them and archiving them or anything. You can just have the daemon running alongside your processes and send all the data up to us. And I should mention that it's completely free. So if you can sign up and you can send us up to 100 gigabytes of data, which I think will do you about 20 VMs without ever owing us a penny. So if you want to check it out and see how we're doing with it, I've included a few tiny screenshots of just an explorer view of how your VMs show up over time with just some color to show how hot or not they are running. We have flame graphs and all sorts of other telemetry information which you can just view through our web-based interface. And it's part of the overall change that we see happening, that people are more and more embracing open source solutions and open instrumentation as we move to this world where we want observability to become this really open forum where more systems and more applications, hopefully all applications, will be able to use open source technology to see what's going on inside their applications and produce better software. So we're cleaning house, we're migrating to Java 11. It increases performance, it accesses cool new things like Java Flight Recorder. There are loads and loads of really great reasons to come to Java 11. And thank you very much.
Thank you. Thank you, Ben, once again for joining our online event this year. So again, I hope we will meet in person next year, and we will be glad to welcome you in Ukraine. So, dear participants, please join Q&A Zoom room with Ben and ask your questions. I'm sure the talk was very interesting. I'm already sure that we should migrate to Java 11. So if you are not yet sure, join the Q&A Zoom room and ask your questions and open discussion. Thank you once again. And in a minute, we will start a presentation from our gold partner, Sigma Software.
Привіт! Вітаю в Sigma Software. Мене звати Оксана, і сьогодні я покажу, як нам живеться у львівському офісі. Ходімте! Знайомтеся, а це Зеник – традиційний житель скандинавських країн і символ нашої компанії. Мініатюрна версія Зеника подорожує з нами по всьому світу. Ми беремо його у відпустки, в бізнес-тріпи і на конференції. Sigma Software – це шведська компанія, яка понад 17 років надає послуги з розробки та IT-консалтингу. Nordic Tradition, Ukrainian Spirit, Superior Software – це про нас, адже нам вдається поєднувати шведські традиції та підходи з українською гнучкістю та самовіддачею. У нас горизонтальна структура. Неважливо, який у тебе тайтл та скільки у тебе досвіду. Чи ти пишеш код, чи ти керуєш департаментом. Усі ми разом працюємо, обідаємо, спілкуємось та відпочиваємо. Запозичили шведську традицію фіка – перерва на каву з запашною випічкою. Проходить вона за участі засновників, а також топ-менеджерів. Разом ми обговорюємо новини компанії, ділимося думками, а також знаходимо відповіді на питання, які нас цікавлять. А зараз я вас познайомлю з одним з власників компанії – Вовою Червою. Вова, привіт!
Привіт, Оксана.
Я вже трішки розповіла про наші шведські традиції. Поділися, будь ласка, нашими цінностями.
Ценности наши основные – это уважение к людям и одинаковое отношение к каждому, вне зависимости, это клиент или сотрудник.
А можеш розповісти трішки про наші бізнес-підходи?
Опять же, то, что делает наш бизнес успешным, это то, что мы уважаем наших клиентов и стараемся строить личные отношения с ними.
Чим, на твою думку, відрізняється львівський офіс від решти офісів Sigma Software?
Львивский офис – это относительно небольшой офис по сравнению, например, с харьковским, и это дает возможность знать людей по именам в офисе, более плотно и тесно общаться друг с другом, помнить, у кого когда день рождения.
Добре, я буду бігти. Рада була тебе бачити. Ще почуємось.
Взаимно.
Нам важливо розвивати IT-екосистему України. Нещодавно ми запустили Sigma Software Labs – лабораторію для стартапів і компаній, які щойно розпочали свій шлях. Наші резиденти мають змогу отримати консультації від бізнес-експертів, технічних експертів, а також доступ до світових фондів. Як і більшість шведських офісів, львівський побудований з урахуванням зелених технологій. Ми стежимо, аби він був озеленений і всім вистачало простору. Сам офіс працює за принципом ресурсозбереження, а ми популяризуємо зменшення використання пластику та паперу. Ми дуже гостинні. Окрім фіки, ми залюбки приймаємо гостей, хостимо мітапи, організовуємо внутрішні події та курси від Sigma Software University. Це наша освітня платформа, яка дозволяє здобути знання як зрілим спеціалістам, так і тим, хто тільки починає свій шлях в IT. У нас дуже дружня і затишна компанія. Ми не лише разом працюємо, але й проводимо багато часу теж разом. По п'ятницях взагалі організовуємо спільні сніданки, де можемо поділитися нашими новинами компанії, які відбулися за тиждень. В компанії відбувається стільки цікавого, що важко щось не пропустити. Саме тому виникло дві круті ініціативи. Insiders – подкасти про IT та Sigma On Air – корпоративне радіо, на якому ми з Максом розповідаємо про найгарячіші події компанії. Дякую, що були з нами. Зустрінемось у львівському офісі.
Готова?
Так. Вітаємо на хвилях Sigma On Air.
В студії Оксана Назаркевич
Та Макс Ковтун. Всім привіт!
Hi guys, happy to see you on the second day of Devoxx conference. My name is Kate, I'm PR manager at Sigma Software, and today I'm gonna talk shortly about our company mission, and what are the possibilities for you at Sigma Software. So let's start. Sigma Software is a place where Nordic tradition meets Ukrainian spirit to create superior software. We decided to combine best practices and approaches from Sweden culture and combine it with Ukrainian ones. From Nordic tradition, we take high demand for quality, minimum hierarchy, freedom in decision making, and attention to every detail and each opinion. From Ukrainian culture, we took flexibility and dedication to every team member, every project, and every client. So, Sigma Software in numbers, we are IT consulting company with development offices in United States, in Australia, in Poland, and Sweden, and Ukraine. With the help of our professional team, we deliver smartest IT solution to our customer in areas like development, gaming, government, automotive, aviation, logistics, and many others. Now we are a global player with a team of 1,000 specialists in Ukraine. We turn ideas into technology. Our main mission is to provide our customers with value IT services. And our core values is our team is built on mutual professional respect. We keep our promises. We appreciate professional development and freedom in decision making. And of course, like every Swiss, we follow green principles. So why Sigma Software could be interesting for you? First of all, because we have lots of challenging projects. Here you can find fast-growing professional development and, of course, cool benefits. So let's start from the first one, challenging projects. The company has variety of possibility for everyone. Here you can work with startups, product houses, large enterprise with different technologies and modern directions. We really appreciate professional development of our team. Each teammate could be a part of continuous education program within which you can attend internal and external courses, various of meetups, and be a part of our professional communities. Also, we have an Institute of Membership. If you need a mentor, you can have one, which will support you during your professional path. Also, you can organize your own career path in the way which the most suits you. And maybe lots of us know we have Sigma Software University. It's our educational platform where our employee from junior to senior could get new knowledge and attend our external and also internal courses. So what about the benefits? At Sigma Software, our main focus is our team, and we care about their work-life balance and also mental health. That's why we have really competitive social package. We have legal and health insurance, paid vacation and sick leaves, specialized conference, flexible working hours, part-time for students, and also continuous education program, as I said before. At Sigma Software, we promote sport, one of our main directions, and we support our employees in their activities. We have gyms in our offices. We have our own cycling teams. We support cycling races. We have yogas. Now we have yogas online. And of course, we participate in lots of marathons. Of course, we also love to party, and in the time of COVID-19, all of us faced significant transformation, and Sigma Software is one of them. But we didn't stop. We decided to transform every activities to the online format. Now you could see the photos from our previous corporate parties. Now it happens online. Our employees could attend internal conferences online, participate in online bars, quizzes, team buildings. They can attend events with their children. For this, we have like special kids days, and also we have online Fika. It's the event where our top managers share the recent news of the company with the employee, and each employee could ask anything. So, actually, there are a lot of to do to make behind the work at Sigma Software. And if you are looking for challenging projects, fast professional development, and new opportunities, check our Sigma Software career site. I'm sure you will find something that matches your interest. And I just want to remind you that today we will choose the winners of our giveaways and quizzes. So join us in the evening in the closing session. Thank you for joining the Devoxx conference and organizers for making it happen. See you today and have a great weekend ahead.
Okay, dear friends, we are back and we continue Devoxx Ukraine online. We are a bit behind the schedule, and I'm glad to announce the new speaker, Miro Tsupak. Hello, Miro. How are you?
Hello, I'm good. How are you?
We're good, thank you. Where are you connecting from today?
I'm dialing in from Toronto, Canada. Early morning here.
That's so exciting. Okay, so I will not steal more time from your talk, so please, the mic is yours.
Excellent, thank you.
Hello, everybody. Thank you for tuning into this talk, the topic of which is exploring what's new in Java in 2020. My name is Miro Tsupak, and I'm with a Toronto-based company called DNA Stack. Our mission at DNA Stack is to improve lives of people affected by genetic disease, and we do it by making standards and technologies for discovery, sharing, and analysis of biomedical data. If health tech is something you're interested in or curious about, feel free to reach out to me. I'm very passionate about this topic and always happy to connect and talk about it. If you want to reach out, here's my Twitter handle in the corner here. In this session, however, we're not focusing on healthcare. We're focusing on the underlying technology stack, which in our case is, of course, Java. This year, as is typical with the release cycle Java has been on for the last few years, we've seen 2 releases of the JDK, 14 back in March and 15 recently in September. The goal of this talk is to really provide a pragmatic introduction to what I consider the most impactful new features in these 2 releases, with maybe a tiny teaser for the upcoming Java 16 as well. Interestingly enough, a big focus of Java this year have been new language features, particularly developer productivity language features coming out of Project Ember, as opposed to library APIs or tools, which, as users and consumers of the JDK, is where we typically get the most visible updates. And that's interesting, because even though these kinds of changes in themselves are often relatively small, since they're at the language level, they affect every single developer, and in that sense can have very high impact. So we're going to take a look at these 5 language features: switch expressions, pattern matching for instance of, text blocks, records, and sealed classes, as well as 2 new APIs, specifically Flight Recorder and Foreign Memory Access. Now, before we go any further, there's one thing you should know about me. I'm bad at making slides. So I've prepared exactly 3 slides for you today, and you've now seen 2 of them, and the rest of this talk is going to be pretty much like coding. I like learning through examples, so I'm going to write a lot of them, and I'm going to write them in JShell because I find it's nicer for demonstrating sort of isolated things when you abstract away from all the magic that IDEs do for us. So let me switch to my terminal here, and let's take a look at the first feature. What you're seeing here is JShell. I'm actually running an early access build of JDK 16 because what could possibly go wrong? So let's dive right in and start with the first productivity language feature from Project Ember, the goal of which is to really reduce boilerplate and make Java a bit more developer friendly. And this feature is switch expressions. Switch expressions were a preview feature in Java 12 and 13 and are a full permanent feature since March this year and its Java 14 release. Preview features, if you don't know, are features that are implemented as part of the JDK but may not be permanent. So the goal is basically to give developers access to these features to test them in practice before committing to maintaining backward compatibility. In other words, preview features are to the language and the VM what incubator modules are to APIs. Don't worry, they're not available by default. You have to pass a special flag to the compiler and the launcher to be able to use them. In fact, we can actually see it here. If I take a look at my environment, you can see that I'm giving JShell this enable preview flag, which gives me access to preview features. Now, to be fair, I don't need this for switch expressions in particular. They are a permanent feature enabled by default now. But I wanted to introduce the concept because some of the features we're covering today are still in the preview state. So if you want to try them out, this is the flag you will need. Switch expressions is essentially an extension of the switch statement, so it also works as an expression. This also addresses 2 slightly annoying aspects of traditional switch: the default scoping of switch blocks, the block is treated as a single scope, and the default control flow behavior, the sort of fall through of switch blocks and having to use breaks everywhere. This is basically done by introducing switch labels that kind of resemble lambdas. So let me just start by declaring a variable, let's call it x here, and this is going to be the variable that I'm going to switch on. And then we can make a simple switch expression. Let's just say, okay, I'm going to be switching on x, and let's say if this is 0, return 0, otherwise return 1. So kind of a simple Boolean simulation, if you will. And you can see a few interesting things here. First of all, this returns 0. So the result of the first part without using any breaks. Secondly, we're using expressions inside rather than statements. And in fact, this whole thing is an expression because it has a return value. There's also a convenience aspect to this. The syntax is obviously very concise, and we can even aggregate multiple cases. So if I wanted to say, okay, if this is 0 or 1, give me 0, otherwise return 1, I can just do this very easily. Now I mentioned that this new syntax works for both expressions and statements. So if I wanted to make a statement, and let's just simplify this a little bit so that I don't have to type that much, I'm just going to keep a single branch for demonstration purposes. And I'm going to replace this expression with a statement, maybe just a simple print line, hello, Devoxx, and this should be just fine. Now, of course, this is just a statement. We can see what it printed, but there's no return value. We can, of course, execute statements and still have an expression with a return value by using blocks, kind of a similar approach to lambdas. So if I wanted to take advantage of that, I can just add a block here, and let's close this at the end. And then if I wanted to actually return a value, I can use the new keyword here, which is called yield hello Devoxx. Now, I say yield is a keyword, but strictly speaking, it's not a keyword. It's actually something called reserved type name. And what that means essentially is that it doesn't conflict with things that keywords normally conflict with, such as variable names. So I can do something like this. If I wanted to introduce a variable here, let's call it yield again, and I'm going to assign some value to this variable, maybe just my string here, and then I can yield this yield variable, and this is going to work just fine. So I'm creating a variable named yield here, and then yielding it. It's certainly not a practice to recommend from the perspective of writing clean code, but it does work. A note here, switch expressions must be exhaustive. In other words, for all the possible values, there must be a matching switch label. That's not the case for switch statements, of course. In practice, this means that you need to specify the default clause, like we've done here. There is an exception to this rule. If you're switching on an enum and cover all the values, the compiler will insert the default clause for you, which is convenient. And now a final note on this topic related to types. Switch expressions are powerful, flexible, and dynamic. They're what's known as poly expressions in Java. And that's not a new concept, that's something that we're all familiar with. For example, lambdas are also poly expressions. What this means is that switch expressions have different types in different contexts. For example, let's go to our previous switch expression and assign it to a variable. Let's pick this one maybe. And I'll let Java infer the type of the variable through local variable type inference, which of course is a well-known Java 10 feature. And let's just call it y so as not to conflict with x. Now this of course works, and you can see if we take a look at the type here that this is actually correctly inferred as an integer. So the type is of course static, but the compiler was able to infer it by looking at what these branches return. But let's pause here for a second and think about it. This is interesting, isn't it? This isn't like a method where we tell it what the return type is. We've never actually committed to returning integer in each of these branches. In fact, I can change it to return different types, let's say integer in one branch, and for example a string in another branch, and you'll see that this still works, because it's a poly expression. But what is the type of this result? What is the type of y? Well, let's think about this. We basically have three options, right? Option number one, it's an integer. In other words, the compiler did some analysis, it determined we're going to end up in the first branch, and it inferred integer. Option number two, it can be an object, right? So the compiler couldn't analyze it that way, but it found a common supertype of all the return types, and it used that. So for string and integer, that would be object. And option number three, it inferred something completely different. And if we take a look here, we can see that this is actually a pretty long type here and not exactly readable, but it's definitely option 3. It's not an integer and it's not an object. So what happened here? Well, option number 1, inferring integer, that was actually never really on the table. Our x here can potentially be passed at runtime, so there's no way to infer compile time what branch we'll get into. The compiler did actually go the route of inferring the closest common supertype of string and integer, like we described in option 2, but it didn't get all the way up to object, it found something more specific. Which brings us to option 3. What we see here is what's called an intersection type. Now, it's a bit hard to read because of generics, but this is actually an intersection of 4 types, which correspond to the 4 interfaces that integer and string have in common. These 4 interfaces are serializable, comparable, constable, and constant desc. And if you're thinking, well, the first 2 kind of make sense, but I've never heard of the last 2 before, that's okay. These are actually from the JVM Constants API, which is a new API in Java 12, so pretty recent feature, but it's out of scope for this talk because we're talking Java 14. But that's just how local variable type inference works. It always infers the most specific type. Intersection types like these belong to a group of types called non-denotable types, which essentially means that you can't name them, for example, when you're declaring a variable. But these are the types that are supported by the compiler internally, and a cool thing about local variable type inference is that it exposes them to us. And this is something you run into relatively often, particularly when dealing with poly expressions like switch expressions. The way they work is essentially if the target type is known, this type is pushed down into each arm, and the type of a switch expression is its target type. If the target type is not known, which is what we have here, a standalone type is computed by combining the types of each branch. So it's just something to keep in mind when you're dealing with switch expressions. This brings us to the second productivity feature, again out of Project Amber, which is pattern matching for instance of. Pattern matching for instance of is a new preview feature in Java 14 and 15 and will be permanent as of Java 16. The goal of this feature is to simplify one very common situation that we have in our code. We often have some sort of a logic that combines testing if an expression has a certain type, and then conditionally extracting components of its state for further processing. What I'm sure each one of us has written many times before, and probably auto-generated many times as well in the form of equals and hashcode, is the instance of and cast idiom. For example, let's start by constructing an object. I'm just going to name it O, and let's just assign a subtype to it, let's say a string. Now, in order to process this object, what we would normally do is first test if this object is a string, and then cast it to a string, and then do something with it. So I would probably do something like, okay, if this is instance of string, then first let's do a cast string O, and let's call this S, and then we can do something with this. Maybe let's just test if this is empty, just like this. The problem that we have here is boilerplate. This is tedious to write. Most of the time, after you test for a type, you follow up with a cast so that you can do something with your object. It's also verbose. The type, string in our case, is your 3 times, which obfuscates information and actually creates an opportunity for error. So the proposal here is for Java to introduce pattern matching, similarly to other languages like Scala or C#. Pattern, in this case, is a combination of a predicate that can be applied to a target and a set of binding variables that are extracted from the target only if the predicate is satisfied. In the case of the instance of operator, this means extending the operator to not only take type, but also a type test pattern. In other words, a predicate that specifies a type and a single binding variable. For example, I can rewrite my previous example just like this. I can completely remove this line here, performing a runtime cast, and I can just add a binding variable here, and this will work just fine. So in this case, the instance of operator matches the target O to the type test pattern like this. If O is an instance of string, then it is cast to string and assigned to the binding variable S, which is just a little bit shorter, a little bit nicer, and a little bit less error prone. Of course, this is not super significant, but since we type and read such code all the time, it could actually have noticeable compound benefit over time. But what's cool is that we can now simplify this code even more and take advantage of the lazy nature of the AND operator, for example, and I can just do something like this. Remove boilerplate here, and just add the double AND here, and of course get rid of the if2, and this works just fine. This time without any casts here, so not risking any runtime errors. One thing to note here is the scope of the binding variable, as in our case. If we go back to our example here, obviously, you can only cast this O to string to use here if the test passes, right? If instance of evaluates to true. So if I add an else, I'm creating a very interesting situation, right? So let's actually try this out. I'm going to add an S branch here, and let's maybe, test for the same thing. And now, if I try this, you can see that this doesn't actually work. And it won't just fail, this will not compile. S simply doesn't exist in this scope. So this will be checked compile time, and that's pretty nice. While this is kind of intuitive and allows us to safely reuse pattern variables, for example across multiple checks, this flow scoping does come at a cost. And the cost in this case is rather unfortunate interaction of this flow scoping with shadowing of fields. In other words, if your variables have conflicting names, it's pretty easy to introduce a bug. For example, if I already had a variable as defined, let's say, string s like this, and I executed the code that previously did not compile, it would, in fact, work now. Because s in this branch, in the first branch of our if statement, is a pattern variable, as you would expect. But s in the second branch is now our original variable from before, not the pattern variable. So take advantage of this feature, but be careful when it comes to shadowing. Now, another feature that came out of Project Amber here are text blocks. Text blocks are still a preview feature in Java 14, but permanent as of Java 15. They are basically multi-line string literals where you don't need to escape most things, and they automatically format strings in a predictable way with you having control over the formatting. In other words, this is perfect for cases where you need to include source code in your program in a string literal, like an SQL statement, or JSON would probably be pretty frequently used with various frameworks, maybe even HTML or documentation for your endpoints for your auto-generated OpenAPI spec. That used to be pretty painful, right? Usually when you want to copy, let's say, an SQL or JSON to a Java string, there's a significant editing step involved, escaping it correctly, particular quotation marks and things like that. And then it's not readable, and as such, it's hard to change and maintain. And that's what text blocks address. It's a new kind of literal in Java, enclosed in triple quotes, so as not to conflict with, any other things that we normally use. For example, I can create maybe just a JSON here. Let's just open a bracket, do something like foo bar, and let's close the bracket and close the text block here as well. Now, notice a few things here. The text block is equivalent to the string printed here. Notice that the white space is preserved, including new lines. You can specify them explicitly, but you don't need to. And you don't need to escape things either, particularly the quotes. But notice what's actually the content of this text block when we compare it to the string here. The content starts on line 2 here, right? After the first 3 quotes. And it ends just before the final 3 quotes. So actually here, which is typically what you want with source code. But if you don't want a new line, this is how you would need to put it. You would need to put it like this, and then you no longer have the new line at the end. Similarly, this is not an empty string, right? This doesn't compile. But this is an empty string. Of course, not very practical. Don't make an empty string this way, but that's how it works. Now, I mentioned the text blocks preserve formatting, but that's not entirely true. They do a couple of tricks convenient for storing code. For example, they remove trailing white space, because that you typically don't want in a program. So if I go back here and just add, maybe let's go to the previous one, if I just add some white space at the end, you can see that this white space is actually entirely stripped out. Now, if you're not happy with this behavior, you can use one of the special escape sequences here. You can, for example, escape the last white space here, maybe just something like this, and now the white space is of course preserved. Or you can, for example, suppress the new line so that your spaces are effectively in the middle of the line, which I can do like this. And now, of course, there's no new line here. Text blocks also remove common white space prefix at the beginning of each line to be sort of indentation and IDE friendly, which is just incredibly useful. So for example, if I go back here and indent everything by 2 more spaces, you can see that this is stored just as before. Of course, this indentation needs to include the triple quotes at the end, otherwise it will just be preserved. So these are text blocks. Now, the next productivity language feature on our list are records. Records, again, are a preview feature in Java 14 and Java 15, and permanent as of Java 16. There were some changes between the releases too. It's a nice feature in that it can really change the way we code. Records provide compact syntax for declaring classes for holding immutable data. And the goal is really to make Java a little less verbose, which is nice. One big source of boilerplate are data classes. If you just want to write a simple POJO or DTO or a Java bean, you have to write a lot of stuff, right? A lot of boilerplate. Things like constructors, accessors, equals, hashcode, toString. And as developers, we don't like doing that, hence the success of libraries like Lombok. And sure, IDEs can help us generate all of this, which helps us write code, but it doesn't really help us read code, which is even more important. Records are a new kind of type declaration in Java. Similarly to enums, they're essentially restricted classes. A record has a name, it has a state description declaring its components, and optionally a body. So I can create a new record here. Let's just call it a tuple. I'm going to use records to model tuples in Java. Let's give it a couple of components and just an empty body for now. And this is our record here. And even though this is very compact, records actually get a lot of additional functionality automatically. If I wanted to instantiate this, I can just give it a couple of values here, and let's call this t, and this of course is going to work just fine. So we have a constructor here with the signature, as you would expect, matching the state description, and this constructor initializes the fields from the corresponding arguments, just sort of out of the box. If we take a look at the API here, you can see that we have a few methods here. We have a private final field for each component of the state description, and a public accessor method for each of them with the same name and type. So for example, if I wanted to access the first component, I can just call TA, and of course, this is 1. Of course, we only have reads, no writes, because records are immutable. Notice the accessors are named like the components. That means it's even more important now to pick good names because they directly become your API, right? We also have a few other methods like equals, hashcode, toString that behave pretty much as you would expect. I can just try one of them here, and this is a pretty reasonable representation of this record. By the way this is implemented is for an abstract class called record, which declares abstract equals, hashcode, and toString methods. So this class is kind of an implicit superclass of all the records, similarly to how object is an implicit superclass of all the objects. In order to make this work, there are restrictions on records. And essentially, all these restrictions have something to do with two things: keeping records immutable and not creating additional instant state, because they're just data. The state is given fully by the state description. So what does that mean in practice? Well, for example, records cannot extend a class. If I try to do that, and if I go back to my record here, and if I say, okay, this extends, let's say, a number, this, of course, will not work. Because classes create instant state, right? And we don't want that. You can implement an interface, though, because that doesn't create instant state. So if I actually modify this and said, okay, this just implements, let's say, serializable, this, of course, will work just fine. You cannot declare instance fields other than the components. If I try to do that, I'm going to go to my original representation here. If I try to add a component here, this will not work. Because that's instant state, right? It just makes complete sense. You can declare, of course, static fields, as it tells you here. That's not instant state, so if I just modify this to be static, this, of course, will work just fine. We saw that records cannot extend classes, but they also cannot be extended themselves, because you don't want to change the state of a record by another class later. In other words, they're implicitly final and cannot be abstract. If I try to make an abstract record here, you can see that I do, in fact, get an error, modifier abstract, not allowed here. The components are also implicitly final to achieve immutability. We saw that we had only read accessors there, of course, but even if we tried to change it internally, it would not work. So if I go back to my record here, like a working version of it, and maybe add the method, let's just give it some nicer formatting. Let's create a new method, maybe update. And in this method, I'm just going to say, okay, change this component here, but this, of course, is not going to work. By the way, this is just shallow immutability. What records do in the background is really just create final fields. So if your components had internal state, for example, they're a date or a collection, you wouldn't be able to change the reference, but you would be able to modify their state, for example, add elements to the collection. In other words, this is just plain final here, no fancy immutability or anything like that. And otherwise, records behave pretty much like normal classes. We saw that you can add methods. You can, of course, add static initializers or constructors too. One interesting case here is the canonical constructor, of course, the one that records get automatically, where the arguments match the state description. You can declare it explicitly, of course, but you can avoid a lot of boilerplate there. If I go back to my previous example and I try to create a new constructor, I can just do it like this, and I'm just going to maybe print out something. Let's say, I'm just performing or simulating that I'm performing some validation, validating just like this, and this will work. So notice that I didn't have to specify the brackets and the parameters here. This was all implicit. It's just assumed that it matches the state description. And also, you don't have to initialize the components, right? In the constructor, I'm just validating. This all gets done automatically. Not only you don't have to initialize the components, you actually can't. It was possible in Java 14, but as of Java 15, it's actually a compile time error. By the way, another new constraint as of Java 15 is the visibility of the canonical constructor. In Java 14, the constructor had to be public, which of course can sometimes be impractical. But as of Java 15, the implicit constructor gets the same access modifier as the record class. So if you declare it explicitly, it needs a modifier that gives it as much access as the class or more. Now, we can test this new constructor. I'm going to initialize this tuple again, and let's just call this t, and you can see that this works just fine, and it is indeed using my constructor because I can see the validation message, yet it initialized everything correctly without me doing anything explicitly. So what this allows us to do is maybe just have a quick and simple constructor that just does validation of components, and if no exception is thrown, it will auto-initialize correctly, which is pretty cool. Similarly to nested and local classes, we can also have nested and even local records too, so small records inside methods. If I go back to my constructor here, I can maybe change this, and I can, or actually we can keep this, doesn't really matter. I can just create a new record here. Let's call it helper maybe, and let's give it some state components, and this, of course, will work just fine. Now, since the whole purpose of records is to immutably hold data, this makes them an ideal construct for storing intermediate values, and this is just a perfect example of that. There's a small but important difference between local records and normal classes though. Normal local classes can access variables of the enclosing method, right? However, local records are implicitly static, which means that their own methods cannot access any variables from the enclosing method. And the reason for that is that this enclosing instance would add state to our records. And like we said several times before, we don't want some sneaky state leaking into our records. So this is a small but important difference to keep in mind here. We can also apply annotations on records as well as their components, like you would with normal classes. If I go back to my example here, I can just say, okay, this is deprecated maybe, and this of course is going to work just fine. And like other classes, records can be generic. If I go maybe to a better example, just let's take something simpler, maybe this one here, I can just say, okay, let's make this tuple a bit more generic, parameterized by t, and then maybe, one of my components uses this type, and this of course will work just fine. By the way, at this point, you're probably noticing that even though I'm modeling a tuple using a record here, records are actually a lot more than basic tuples, right? Their attributes have names, you have constructors that can validate the state and enforce invariants, so this concept is more than what we would just need to have tuples in Java. They're also not the same as value types. Both value types and records are essentially immutable data classes with restrictions on how they can be extended, but value types are about enabling flat and dense layout of objects in memory in exchange for giving up object identity. Whereas records, on the other hand, are more about concise syntax, and they still have identity. One final thing to note here, because we now have this new form of a class essentially, the reflection API was also enhanced to accommodate this. For example, we can now test whether a class is a record. If I take a look at my tuple here and get the class, I can see if this is a record, and of course it is. So it's kind of similar to the isEnum method that we had there. We can also do other things, like extract the components. I can go here and maybe call get record components, and you can see that this gives you an array of record components in the order of their declaration. And then you can extract more information from them. For example, I can take a look at maybe the first component here, which is of course index 0, and I can take a look at the name, or maybe I'm going to take a look at the type, or I can maybe just take a look at the accessor here. Pretty standard reflection stuff. And other things like annotations, pretty much everything that you would expect from reflection work as well. Now, this concludes records and brings us to the final productivity language feature in Java, again out of Project Ember, and that feature are sealed classes and interfaces. Sealed classes and interfaces are classes and interfaces that restrict which other classes or interfaces may extend or implement them. So the goal is really to give the author of the class or interface control over which code extends or implements it. By the way, this is not a Java 14 feature, not even in preview. This is a brand new preview as of Java 15, so likely something that won't be finalized before Java 17. So why do we need something like this? Well, restricting a set of subclasses is a design goal that we encounter in APIs relatively frequently, but our current tools are pretty limited. We can either make a class final, in which case it can have no subclasses, or we can make it package private, in which case it can have subclasses, but only in the same package. And this might be enough for many cases, especially if we're just using inheritance as a means of reusing code. But it's often not enough when we're using inheritance for domain modeling different options in a certain domain. For example, let's say we're developing a library for processing text in different formats. So we might start by making a class called format, and maybe that class is abstract. I can just create a class here. Let's call it format, just like this. Now, let's say our library handles different formats differently. So we make more classes. Maybe I make another, let's say, final class. Let's call it YAML, which of course is an example of format. And maybe I'm going to make another class. Let's call it XML, which is also a format. Now, these are the only two formats that we want to handle in our library, right? We're not interested in handling or defending against some other unknown subclasses, some custom formats someone develops. It's too complex to be flexible enough to accommodate all the possible formats. If we could restrict this, that would make maintenance easier too. For example, when we change things later, we wouldn't need to worry about maintaining all the possible invariants in any random implementation somebody might have developed against our API. But in Java, it's currently an all or nothing kind of approach. If format can be extended at all, it can be extended by any number of classes. And if we want format to be widely accessible, because it's an important abstraction for users of our library, it has to be widely extensible as well, even by subclasses not known by the author. So it would be helpful if, as the authors of the library, we could say both to the reader and to the compiler, hey, this class is co-developed with these other subclasses, and we declare a class hierarchy that is not open for extension by arbitrary classes, only within the defined tree. And that's exactly what sealed classes are about. To seal a class, we need to do two things. We need to add a sealed modifier and add a permits clause to specify the classes allowed to extend this class. So if I go back to my format here, I can say, okay, this class is now sealed, and we're only permitting two extension points here. It's going to permit YAML, and it's going to permit our XML. And now, if someone tries to create another unauthorized format, they won't be able to. If I create a new format, what's a good example? Maybe just plain text, you can see that this now is not allowed, and it's actually a compile time error. Now, there are a few rules to obey here, and the first rule has to do with location. Permitted classes must be located near the superclass. That means in the same module or package if the module is unnamed. And if they are in different packages, you can qualify their names in the declaration of the superclass. A special case of this is having subclasses in the same source file as the sealed class, which is actually a pretty useful pattern when you have sort of a small number of small one-off classes. In that case, you don't have to specify the permits clause. The compiler will infer it automatically by scanning the file and seeing what classes extend your sealed class. This single file scenario is the only case when you can use the sealed modifier without the permits clause. Otherwise, you need to specify both. Which brings us to the second rule. When you use the permits clause, you need to make sure that every subclass directly extends the superclass. You can't list it, but then have it not extend the superclass. And rule number 3, every permitted subclass must be declared with a modifier that determines how it continues with the sealing that its parent started. So you saw that when I declared this YAML and XML classes, I used the final modifier. That wasn't by chance, it actually would not compile without the modifier. In our case, I was saying that sealing ends with YAML and XML, nothing can extend them further. But it's not the only option. Alternatively, I could have used the sealed modifier again and then extend the hierarchy further by declaring further subclasses of YAML and XML that are also allowed. I can actually demonstrate this here. If I go back to my YAML, I can say, okay, instead of final, this is now going to be sealed, and this now permits another format, maybe, let's say, JSON. And this, of course, will work. So the compiler can deal with this kind of transitive dependencies. And I said that it wouldn't work without any modifier, but that doesn't mean that there isn't a way to keep it open. It just means that you as the author need to be explicit about which of your subclasses you want to designate as an extension point, and you can then say that they allow for extension by sort of arbitrary unknown subclasses. And the way to do this is by using the non-sealed keyword. So if I go back here, back to my format, and instead of sealed, I'm going to use non-sealed, this is now sort of an open extension point. So open extension is possible, it just doesn't happen by default. You have to be explicit about it. And by the way, these modifiers are actually mutually exclusive, so you can't make something final and sealed, or final and non-sealed, or sealed and non-sealed. Final basically means strictly sealed with no permitted subclasses. So this is one thing that's potentially confusing. Sealing without the permits clause is for multiple subclasses in the same file, not for not allowing extensions. That's what final is for. Abstract modifier works with sealing as you would expect. Sealed classes can be abstract, of course, that's actually a very common scenario. We saw that with format. Non-sealed classes can be abstract as well. Why not? If I go back to my YAML, I can just say, okay, this is now abstract as well, and of course, no problems here. Final classes cannot be abstract for obvious reasons, right? What would that even mean? So if I try to actually make this final, this would be a no-go. And finally, I just want to mention that although I've been using classes in my examples, sealing actually behaves the same way for interfaces. As in, interfaces can also be sealed, and you can permit implementations and sub-interfaces. Sealed classes, as a feature, tie nicely or will tie nicely into several other features that we've gone over today, such as pattern matching, switch expressions, and records. Pattern matching and switch expressions haven't been fully integrated yet, but the plan is to do so in a future Java release. The boilerplate issue this will solve is the fact that when we use inheritance for domain modeling and we want to handle different subclasses differently, like YAML and XML in our format example, that handling often translates to methods that have a bunch of if statements with instance of checks and catch-all. We can imagine, for example, a process text method, which would say something like, okay, if format is an instance of YAML, process it like this. If format is an instance of XML, process it like this. Otherwise, do this. And if we have a lot of subclasses, this not only gets unwieldy, but it's actually prone to errors too. Because if we add a new subclass, it's not like the compiler can alert us to the methods where we need to add the logic, because the superclass is universally extensible, right? So we always have this catch-all, which would simply kick in. However, with sealed classes, we don't need this catch-all because we enumerate the extension points, so the compiler can now alert us when we add a new one. And that's very, very useful. On top of that, we already have some pattern matching on instance of. If we extend it to switch, we'll be able to have very concise methods for handling different formats. For example, we can just switch on formats and then list subclasses as cases in our switch with pattern matching out of the box. This is not available right now, but maybe one day in a future Java release. Sealing also works very well with records. In fact, because records are implicitly final, it's actually very concise. If we create an interface to permit a record tuple that we used before, let's bring back the tuple. Actually, this one will do. So I can create a new interface, a sealed one, and what's a reasonable abstraction for tuple? Let's say data, and we can say, okay, permits tuple, just like this. And of course, it's complaining now. I need to add the implementation here, implements data, and now we're good to go. Just fix the references here, and we're good. So this is nice and clear. You can see that no modifiers are necessary here. But the reason I wanted to mention this integration of sealed classes with records explicitly is because together they provide what's sometimes called algebraic data types. Algebraic data types are a kind of composite types, in other words, types formed by combining other types. And the two main forms of algebraic types are product types and sum types. Product types combine multiple values of different types into one, so effectively they're records. Sum types have values from either one type or the other type, so effectively they're sealed classes. So there's just a nice alternative way of viewing records and sealed classes as complementary constructs. Records can be viewed as AND between the types, and sealed classes can be viewed as OR between the types. Now, a final note here to wrap up. Similarly to how the reflection API was modified for records, it was also modified for sealed classes. And we can test if a class is sealed, for example, by obtaining a class here and let's just call it sealed, and of course this one is. We can also, for example, extract permitted subclasses, just like this. This doesn't actually show us a lot. Let's access the first one of these and maybe take a look at display name, and of course it's our class tuple. This concludes the main part of the talk, focused on productivity language features. In the last few minutes, we'll take a look at a couple of new APIs in Java 14 and 15, starting with the Flight Recorder API. Flight Recorder is probably something that you're familiar with because it was actually pretty successfully marketed, and its functionality was delivered over several releases of Java. Java 7 sort of provided the basis for this. It introduces infrastructure for tracing across all subcomponents of the JVM and printing this information to standard output. This was done in the form of timestamped events like garbage collection, method compilation, things like this. Java 11 then took it further, and it introduced the Flight Recorder as basically a monitoring tool for Java. So it's a framework for recording events from applications, the JVM, and the operating system. You can even use it to monitor other processes, for example. New events were added as well. These would be things like memory, CPU load, process information from the operating system, or garbage collection configuration, compiler configuration, memory leaks from the JVM, I/O exceptions, you name it. Events get recorded to a file, which you can save and attach to a bug report, or use to analyze a failure that occurred in production post-mortem. These files where you store the events usually have the extension JFR, and they're binary. Their format might change, but that doesn't matter because we have stable APIs to interact with them. What Java 14 did is it extended this even further, and it added event streaming for continuous monitoring of your application. So you no longer need to manually start a recording, stop it, save it to a recording file, and then parse it. You can just subscribe to events asynchronously and stream the data directly without storing it in a recording file. We can demonstrate it with a simple example here. Let me just start by creating a new recording stream, and let's just call it RS. And I'm going to take a look at some event. Let's say maybe I'll monitor my CPU load, and let's call this event. And then finally, I should be able to take my recording stream and enable this event on it. Of course, this is a continuous metric, so I'll have to sample it with a certain period. Let's say maybe every second. So now every second I should be getting a reading of my CPU. Now I should be able to specify the handler for my event. So on event, my event here, I'm just going to print it out, the whole event, just so that we can see. And finally, I should be able to start the recording stream. And now every second we get CPU load statistics, and that's just very nice. There are, of course, many other events here. We can take a look here. If I obtain an instance of my Flight Recorder, I can take a look at event types, which actually doesn't give me a lot of useful information. So let's do some further extraction here. I'll just convert it to a stream and just use a map here. And let's maybe format this a little bit better. I'm just going to say, okay, this goes on the new line, then maybe this goes on the new line, and this goes on the new line. And inside this map, I'm going to say, okay, for each event, give me the name of this event. And then, of course, I probably want to print out everything. So for each, let's just do a quick method reference, system out, print line, just like this. And of course, you can create your own events for your application, but you can see there are quite a few available just out of the box. So a nice little convenient API for tracing here. Now, finally, let's briefly touch on the topic of foreign memory access. Foreign memory access API is again a feature in incubation in both Java 14 and 15, and it's actually still in incubation in Java 16 with quite a few revisions between the different releases. It's a feature that comes out of Project Panama, which focuses on making the JVM and non-Java APIs more interoperable. As the name suggests, this is an API for accessing memory outside of the Java heap. And the main reason why we would want to do such a thing is performance, particularly avoiding garbage collection. This might sound pretty niche, but it's actually quite common. There are quite a few pieces of software that already take advantage of such functionality. In fact, many of us, if not most of us, probably use such software regularly. There are existing constructs in the JDK that allow us to do this, but they're not very good. We have the byte buffer API, which is an old API from Java 4, which allows us to create direct byte buffers allocated off heap directly from Java. This doesn't work very well and has size limitations as well as garbage collection issues. Then we have JNI, of course, Java Native Interface, which allows us to call native applications and as such also access memory. But it requires us to write C code and is very slow because we're constantly translating between Java and native. And finally, we have sun-misc unsafe, which is what most tools are using nowadays because it's very fast. But this is an unsupported API, and as the name suggests, it is unsafe. You can access any memory location, so you can potentially break your own JVM if you're not careful. So we need something better, and Foreign Memory Access API is an attempt in this direction. The API introduces three abstractions. There's a memory segment, which models a continuous region of memory. There's a memory address, which is a location within a given memory segment. And there's memory layout, which is a way to define the layout of a memory segment. And here's how it works. I can allocate a memory segment, let's say something like this, memory segment, allocate native, how about 1000 bytes, and let's call this segment. Now, I should be able to obtain a memory address within this segment, and the easiest way to do this is to access the base address, and let's call this address. And now, to access the underlying data, we need to use a memory access var handle. Var handles in Java are basically just a typed reference to a variable, or in our case, a reference to a component of an off-heap data structure. I can obtain such a var handle from memory handles. So if I go to memory handles here, I can get a var handle, and this needs a class, a carrier, and a byte order. So I can tell it, okay, give me a handle to, let's say, an integer, and the byte order, I don't really care, so I can just keep it on the default one, just native order here, and let's call this handle. Now, I can use this handle to write something in my memory. So I can say handle set on my address, write some integer, let's say 42. And now finally, I should be able to read from this address. And this, of course, gives me 42. Now this is not a very practical way of accessing memory. It's basically purely by offsetting a memory segment. Most often, you would want to organize the data in some layout, which is what the memory layout and memory layouts classes are for. Memory layouts with an S is basically a bag of convenience predefined layouts, sort of a building blocks that Java comes with out of the box. If we take a look here, you can see that there's a few of them, and these are mostly sort of simple value layout models for basic data types like integer or double. So each of these has a predefined size, which is the same as the corresponding type, and the byte order. Memory layout, on the other hand, without the S, is an interface which allows us to construct more complex layouts from the building blocks. So for example, I can create a sequence layout, which is basically a repetition of a given layout. For example, I can say, okay, let's make, let's say, 100 elements, 100 repetitions of some building block. So let's go back to memory layouts and maybe just use Java double as an example here. And of course, you can combine layouts in many different ways, and you can even make your own, but that's beyond the scope of this talk. And that's it from me. I hope you found this talk useful. If you have any questions, we should have a Zoom room available for up to 15 minutes for Q&A right now. You're welcome to join, and I promise I will try my best to answer your questions. And if you like this live coding style and are interested in concurrency in Java, I have another talk in 15 minutes about the past, present, and future of concurrency. The talk provides sort of a pragmatic guide to existing concurrency constructs in Java, and then dives deep into the upcoming project loom. If you want to discover other enhancements to Java made in the last few years, Mohammed Taman gave a good overview talk at Devoxx yesterday, going as far back as Java 9, and I'm sure the recording will be made available. If you want to get in touch with me later, here's my Twitter handle in the corner here. And otherwise, thank you, and enjoy the rest of the conference.
Thank you, Miro. Thank you so much for your talk and for supporting Devoxx Ukraine online. Dear participants, Miro will have a second talk, so you can join the Q&A Zoom room with him after the second talk and ask your questions there. Also, I remind you that you can vote for the best speaker and the best talk using the mobile application. You have a links to download the mobile application in your user page, so just do it and vote for the best speakers, best talks, and we will announce the winners at the closing ceremony later today. Thank you. Yeah, and in a minute we will start the presentation from our gold partner, Svitla Systems. Okay, welcome back, and I'm glad again to introduce our gold partner, Svitla Systems company, and the representative, Natalia, who will give the short presentation about the Svitla Systems.
Hi everybody, my name is Natalia and I'm talent hunter at Svitla Systems. Let me tell you more about us. Svitla Systems is a multinational software company. Our head office is located in California and business and development offices around the US, Mexico and Europe, Poland and Ukraine. We have 600 plus developers and provide a wide range of development services for such well-known companies as Ingenico, Ancestry, Thermo Fisher, AstraZeneca and others. What I love most about Svitla is the freedom to choose your work location. And thanks to schedule flexibility, you get more time for your hobbies, family, and less time commuting. And what is also very important, no micromanagement. Moreover, there is no bureaucracy. Any question is solved quickly and easily. We care about your comfort. We do everything we can to help you focus on your work and your personal life. We truly appreciate our developers' work-life balance. We enjoy some vacation days, national holidays, days off, sports activities, family days, and splendid birthday presents. We care about your education. Svetla constantly organizes in-house and public tech webinars named Svetla Smart Talk. You can visit our Facebook page to see the schedule. Also, Svetla covers tickets for others' IT events and courses. Svetla is well known not only for its family-like attitude, but also for a big number of most innovative projects. I'm going to show you several projects we are especially proud of. For some of them, we are hiring now. The first one is a leading traveling platform. Each month it helps over 400 million developers to make their trips across the globe. The app is available in 30 languages and works across 50 countries. Yes, leading team collaboration platform like Skype and Zoom, it helps enterprise users stay connected. It is used by thousands of companies and sends over 500 million messages daily. Multinational US technology company focuses on e-commerce, cloud computing, digital streaming, and artificial intelligence. Next one, a biotechnology leader, American provisioner of scientific software and services to healthcare, life science, and biotechnology. Safety observations solution, trained to recognize construction risks in photos and other projects' data. It creates an automated risk assessment. Global leader in robotics, enables self-driving robots development, deployment, and operations. Works in 40-plus countries, serving the mining, military, aerospace markets, and agriculture. Of course, we have more projects to tell you about, and we will be happy to do it personally. You're welcome to learn more about us on our career page on svetla.com. And now for more exciting part, our prizes raffle. Take a chance to win our awesome backpacks, AirPods, thermocups, and t-shirts, and more. Go to the Devoxx website to see Svetla Systems page. You will find two options. First, simple fill-in form, and second, advanced Java quest. If you wanna challenge yourself and solve our tricky tasks. Again, links to raffles at Svetla Systems page at Devoxx website. Thanks for your attention. I hope to see you at Svetla. Take care. Bye.
Thank you. Thank you, Natalia. Very exciting projects you're working with. Yes. And yeah, guys, very exciting prizes, new AirPods. So just solve the Java quest from Svetla Systems and take your chance to win. Thank you.
Thank you.
In Itera, we are specialists in creating digital business. We have a proven track record of developing innovative solutions that bring great user experiences and high business value. Our method is to work in cross-functional teams, combining our skills of business development, service design, user experience, development, testing, security, DevOps, and cloud platforms. We are always excited about collaborating with new, innovative customers and have high ambitions for common achievements in areas such as designing excellent user experiences, scalability and cost benefits improvements through our hybrid delivery model, providing more for less, increased operational effectiveness through smart use of technology. And this is just the beginning.
Okay, dear participants, welcome back. We continue Devoxx Ukraine Online. And I want to invite on our virtual stage once again Miro Tsupak with his second talk, who will connect from Toronto, Canada. So Mira, welcome.
Hello everybody, and thank you for tuning in to this talk. My name is Miro Tsupak, and I'm with a Toronto-based company called DNA Stack. Our mission at DNA Stack is to improve lives of people affected by genetic disease, and we do it by making standards and technologies for discovery, sharing, and analysis of biomedical data. If health tech is something you're interested in or curious about, feel free to reach out to me. I'm very passionate about this topic and always happy to connect and talk about it. If you want to reach out, here's my Twitter handle in the corner here. In this session, we're not focusing on the healthcare domain. We're focusing on the underlying technology stack, which in our case is, of course, Java. In particular, we're talking about what APIs and constructs Java provides for concurrency, how the concurrency model has evolved over time, and what the next step in this evolution is. One thing I find about concurrency is that whenever it's talked about, the concept and the theory behind it is really the topic of the conversation. Critical sections, thread safety, Java memory model, concurrency versus parallelism, that sort of thing. But as a developer, I just want to dive in. I want to know what the APIs are and how do I actually use the constructs in my code. So today, we're going to take a very pragmatic approach to concurrency. In fact, to the level that I've actually only prepared 2 slides for you, and you're looking at one of them. I like learning through examples, so the rest of this talk is going to be all live coding. I'm going to write my examples in JShell, because I find it's nicer for demonstrating sort of isolated things when you abstract away from all the magic ideas do for us. So let me switch to my terminal here, and let's get started. The basic unit of concurrency in Java is a thread, represented by the thread class. Interestingly enough, this is something that has been available since the very first version of Java. Even in Java 1, 25 years ago, we had the runnable interface and its implementation thread. So we could easily do something like this. I'm just going to start by declaring my task as runnable. Let's just do a quick lambda here. Of course, lambdas weren't available at the time, but we can take advantage of them now. And I'll just do a simple printout here. Let's say hello Devoxx, and that should be it. And now I can create a thread, and this, of course, takes a runnable. So I'll just give it my runnable from before, and let's call this T. And finally, I should be able to start the thread, and we can see the right output. And that's very nice. This was a big deal at the time, because now we had this abstraction in the JDK, so we no longer had to write native code to handle threads. And JDK 1 was tiny. We're really talking 200 classes or so. And a big chunk of that was actually AWT and its UI components. Java Lang was only about 20 classes at the time, plus some errors and exceptions. So the fact that the thread was present in the very first edition of Java really shows you how core the concept is to the Java platform. And a lot of our stuff really is tied to threads. At the VM level, we have exceptions, where the context is given through the thread's stack trace. Debugging is also done through thread, and profilers group data by threads. So what could we do with this construct in the early days of Java? Well, not much, actually. If we take a look at the API here, we can see that there are a few methods here, and most of these have been here since the early days. But it's quite a strange API, because different parts of it withstood the test of time to varying degrees. Some parts are not deprecated, and others are confusing. So what do we actually have here? Well, we saw the start method in action, which is sort of the main method you would want to call here. Another really commonly used method is the method currentThread, which, as the name suggests, gives you the reference to the thread that you're currently in. So I can, for example, do something like this, thread currentThread, and let's call this T. And now I can use any range of methods that allow me to extract some information about the thread. And of course, the most well-known one, and the one we've all used before, is getStackTrace. So this, of course, returns an array of stack trace elements representing the stack of this thread at this time. And like we said, exceptions and debugging context is all tied to a thread. There's also a method called getID, which, as you would expect, returns the identifier of the thread. Threads in our application are actually numbered sequentially by the JVM. That's why the ID on the main thread is 1. We also have a method called getName, which actually returns the name of the thread. In this case, we're just in the main thread. But this implies that we can actually name our threads, which can be handy if we have many of them. And this is quite an underrated feature, which I wish people used more often. It's very useful for logging and debugging purposes. Actually, not only we can name threads, but every thread has a name. If we don't specify one, it will be generated for us. And the easiest way to specify one is through the constructor. If I try to create a new thread here, let's make a new runnable now, and I'm going to print out the name of the thread. So thread, current thread, get name, and let's close everything, and let's call this T. Now let me add the name for my thread here. Let's call this worker, and now if I start the thread, you can see that we see the name, and the name indeed is a worker. So we saw that you can start a thread using the method start, right? But confusingly enough, there's actually another method here which looks like it might start the thread, but it does something completely different. And that method is run. And you can see that if we try to call it, it actually gives us a different result. Because you see, this is the run method from the runnable interface, and if we call it, it doesn't actually start a new thread to execute this runnable. This is just a normal method call now. So the thread executing this is, as we can see, our main thread. So if you call run by mistake, it can be quite tricky to hunt down the bug. Start is the method you're most likely looking for here. There's actually a similarly confusing situation when it comes to stopping a thread as well. You might be tempted to just call thread stop, but this method is actually deprecated and just inherently unsafe. The closest thing that we have to stopping the thread is the method interrupt, which is not completely the same thing. Interrupt is sort of a polite version of stopping the thread. Essentially, you're asking a thread to stop, but it's up to that thread to decide what it really wants to do. But this is what we have in the JDK right now. A similar situation is in place for pausing as well. I'm sure we're all familiar with thread sleep as kind of the main pause method. Let's say I just put this thread to sleep for 2 seconds. This, of course, works just fine. But for example, the method suspend or its counterpart, method resume, they're both deprecated and should not be used. There is actually one more thing. We've covered what you can do with individual threads, but if you have many of them, you might benefit from a construct simplifying thread management, like a thread group. Thread groups, as the name suggests, provide a simple way of grouping threads. So you can create a new group and you can name it. Let's just create a new group called group, and let's call this TG. And that's pretty much it. That's more or less all you can do with it. The API is actually very simple and not a lot of things going on here. One thing to note here maybe is that we don't actually have methods on the group for adding or removing members. To add a thread to the group, you need to specify the group when you create a thread. So if I go back to my constructor maybe from before, which was this one, I can now add the notion of the group here. And now if I take a look at the group, you can see that it indeed is the group that I just created. There's a reason why we add threads to groups this way. Group assignment is permanent. You can't just move threads between groups. And actually, every thread needs to be assigned to a group. If you don't name one, you get assigned to a default one. So there's a group called system for the JVM threads, like system threads, and it has a child group called main for our application, which starts with a single thread running our main method. We can actually even see it in JShell here. If I obtain the reference to my thread and take a look at the thread group, you can see that it indeed is the group main. And this is actually a hierarchy. Thread groups are also assigned to other thread groups, so you sort of end up with this tree of threads. And this is a useful, basic thread management construct. Now, I want to mention one more thing here, which was actually added in Java 2, but then really became useful in Java 5 with the addition of generics. And I want to mention this because it's one of the most widely used concepts related to threads today. And that concept is, of course, thread local. As we started relying on threads more heavily, it became pretty clear that we needed a way to store data in the scope of a single thread, which is a use case not really captured by other Java primitives. And thread local is the construct that allows us to scope variables that way. So unlike regular variables, thread locals allow us to give each thread its own independently initialized copy of a variable. So it's a perfect feature for storing thread state. It's actually really simple to use. We have a class called thread local, which only has a handful of methods. So we can, for example, create a new thread local, let's say thread local of type string, and then let's call this TL. I can set its value, importantly, for the current thread. So I can use my favorite string here, hello Devoxx, and then of course we have a get method to extract the value. And that's pretty much it. It's actually pretty much all there is to know about threads in general, as we've had them in Java for about 25 years. As far as concurrency constructs go, threads are actually very easy to understand. We've spent about, a few minutes going over them. And we saw the usage was pretty straightforward. When we use threads this way, we do synchronous programming, right? every task executes start to finish on a single thread. And we saw that from code perspective, this was easy to read, fits well with the design of the language as well as the tooling. OpenJDK currently provides a single implementation of threads, which is a relatively thin wrapper around operating system threads. So when you create a thread in Java, a new operating system thread is created to back it. And this gave us simplicity, but as you can imagine, it results in certain inefficiencies. The operating system, for example, doesn't know what kind of workload the thread is executing, or what language it's written in, and how the language manages the stack. So the operating system must go for a very conservative and robust approach that gives us good compromise across all the possible implementations, which in turn makes Java threads pretty heavyweight. Scheduling is also a compromise across all the use cases, so you're not getting optimal cache locality, and context switching needs to go through the kernel, which is also relatively slow. And because any thread wraps an operating system thread, and that thread is costly, we can't have many Java threads at the same time. And because every task consumes a thread, the number of tasks that we can handle is bound by the number of threads that we can handle, which on a regular machine, even nowadays, will be somewhere in the thousands. So threads themselves became the bottleneck. And there's certain irony in that, right? The reason threads were introduced in the first place was because hardware was the scarce resource, and threads were the lightweight mechanism at the time allowing us to share this scarce resource. Yet over time, threads themselves have become the scarce resource, and soon we needed another abstraction. So what did we do? Well, the same thing we always do when we have an expensive resource. We try to share it. And how do we share threads? Thread pools, which brings us to Java 5. The idea with thread pools is that instead of spawning a new thread for every incoming request, we have a pool of threads. We typically create such pool at the start of the application. When a request arrives, we borrow a thread from the pool, we run the task on it, and then return the thread back to the pool when we're done, which gives us some level of sharing. Java 5 introduced 3 useful interfaces in this aspect. It introduced Thread Factory, Executor, and Executor Service. Thread Factory is probably pretty much what you would expect. It's an implementation of a very common design pattern in Java. It's a low-level thread management construct. It's basically an object that allows us to create many threads of certain configuration on demand. As a simple example, I'll just use the default thread factory here. I'm going to reach into executors, obtain the default thread factory, and let's call this TF. And now I can use this factory to create a new thread, which unsurprisingly needs a runnable, so I can just reuse the one that I had from before. And I can also immediately start it, and you can see that this gives the right result. So that's Thread Factory. Executor is an object that executes tasks, so runnables. It's a way of decoupling task submission from thread use and how each task will be run, so scheduling. It's a higher level construct than a thread factory. It's something that will actually typically use a thread factory to deal with threads. And this is what you would normally use instead of thread factory directly. We also have executor services. Executor service actually extends executor, so it's essentially a more extensive framework for execution of tasks, or runnables. All the implementations of the executor interface in the JDK actually also implement executor service. So executor service is the more useful construct here. And in practice, this is what we really mean when we're talking thread pools. So how do you use this? Well, I can create a new executor service, let's say by reaching into executors, and let's just create a fixed thread pool, let's say consisting of 3 threads, and let's call this E. Now, I can call the method execute here, which is actually a method from the executor interface inherited in executor service. And in fact, it's the only method in the executor interface. And I can give it my runnable from before, and you can see that this works just fine. And this gives us a lot, right? We've pushed scalability further. We can now relatively easily reuse threads. But this isn't really how threads were meant to be used. This is basically a workaround for improving concurrency. So what are the problems that we might encounter as a result of this? Well, we saw that thread locals are an important construct with threads. And with thread pools, our thread locals might leak. So let's say one of our tasks takes a thread, it creates a thread local, and then forgets to reset it. Then a different task gets the same thread and can now read those unrelated thread locals, which can cause surprising consequences in highly concurrent applications. So it's a good practice to reset thread locals yourself before and after execution. We also saw the methods for interrupting a thread, and we can now encounter synchronization issues with interrupts. Let's say we have a task that's been running for too long for whatever reason, and we want to cancel it. To do that, we need to interrupt the thread it's been running on. But because threads can now be shared, maybe you trigger the interrupt, but by the time it's in effect, the task has already finished and the thread is now running a different task, and you interrupt that one. And that's something you, as an application developer, need to think about. There are complexities with interrupts that are not covered by abstractions in the JDK. And finally, thread pools are still not efficient enough. Even though we use a pool, we run tasks start to finish on a single thread. So the number of tasks we can run in parallel is still bounded by the number of threads we can handle, which, as we've already established, is not high enough. So how do we push scalability even further? Well, we notice that while a task is being processed, it's only actually performing computation on a CPU for a relatively small amount of time. A lot of its time is actually spent waiting for I/O. So what if, while we wait, we return the thread to the pool, and a different task can reuse it before our task is actually terminated? And that allows us to have more active tasks than threads, which brings us to asynchronous programming. Java 5 took the first step towards asynchronous programming. Together with executors and executor services, which we've seen already, it introduced two other very useful interfaces, a callable and a future. Callable is kind of like a runnable, which we've seen already, in that it's a representation of a task, but it's a task that returns a result and may throw an exception. And while runnables can be run with threads directly, callables can only be run with executor services. And future is simply future result of an asynchronous computation. And this is how they work together with executor service. I'm going to reuse the executor service I had from before to submit a task, which is a callable. So let's just call submit, and I'm going to do a quick lambda here for a quick callable, maybe just something like this. And this, as we can see, returns a future. Let's call it f. And you can see that the method returns immediately, and the future is not completed because it's asynchronous. Of course, it completes very quickly. It's a very simple lambda. So if we take a look now, you can see that this feature is now completed. And if we try to extract the value, you can see that it is actually the value that we would expect. And this seems simple, but it actually gives us a pretty sophisticated asynchronous system, and it allows us to push concurrency in Java a bit further. But as you can imagine, as time went on, this still wasn't efficient enough. Pretty soon we needed more. And the help came with Java 7, which introduced the fork join framework, and most importantly, fork join pool. Fork join pool implements executor service, so it's a thread pool. And it's an ideal candidate for writing asynchronous systems, because it understands that some tasks need to wait for others. It avoids changing threads, if possible, until workload is significant, so it can help prevent cache corruption. And it basically provides better utilization of resources and generally better performance for asynchronous processing. So how does it do it? Well, the key assumption behind it is that newly created tasks are more likely to have their data in a closer cache than older tasks. So maybe we should run those on our CPU and schedule the old ones for other CPUs. So this is how it works. When I create a task, it goes in the queue. Every thread has a queue it needs to do. When the thread is ready, it says, hey, I'm ready, do we have any tasks in the queue? And it takes the task and executes it. When a task needs to do more work, it adds more tasks to the local thread queue. So the thread keeps pulling tasks from its local queue, which means ideally we're not corrupting our cache. So how do we scale this across threads? Well, if another thread is out of tasks, it does what's called work stealing, where it grabs a task from the bottom of someone else's queue. So the expectation is that the bottom of the queue is far enough from the cache that moving it to a different CPU will have the least performance impact. And it turns out that this works really well for synchronous computations. We get good single-threaded performance, and as we're adding tasks, we get pretty good sharing across CPUs. In fact, fork join pool works so well that it is what pretty much all higher-level components relevant for concurrency in the JDK use under the hood nowadays. If we wanted to use it directly, a very simple way of doing that would be just by modifying the example that we had from before, where I was creating an executor service, and now I can create one like this. I'll just reach into the fork join pool, and let's just use the common pool here. And now I can repeat the steps from before. I can use this executor service to submit a task, and of course, I can use the get method to extract the result. And you can see that this works just fine. This is, of course, a very primitive way of using the fork join pool. I'm not really benefiting from it here, but it's just for demonstration purposes. So with futures, we're asynchronous. With the fork join pool, we can do synchronous very effectively. But as you can imagine, time went by, and we needed to scale more and more, and at some point, this again wasn't enough anymore. So we took a look at this framework and thought, okay, what are the issues here? Where could we possibly optimize even more? And the problems that we have right now are that futures are hard to compose. What you see in practice when people are using futures, when they try to coordinate multiple tasks, they often do it by essentially performing busy waiting. So you're kind of iterating over your tasks, checking if they're done, and then when the tasks are finally done, you schedule the next task that depends on them, which obviously wastes resources and it makes you block on your main thread. The get method that we have to call to get the value from the future is actually also a blocking call. So I can run things asynchronously, but to get the result, I need to block. To improve, we want to avoid blocking threads, we want to optimize our use of CPU, and we want to avoid changing threads, because context switching is expensive, and the thread we switch to generally uses different data from the previous thread, so the CPU needs to pull in the data, and we want to optimize our use of cache. But as it turns out, Java 8 helps us with this quite a lot by introducing completable future. Completable future is basically a framework for primarily non-blocking, asynchronous programming in Java. It's built around a class called completable future, which, as the name suggests, is a future that may be explicitly completed, so it can set its value and status. And when I say it's a future, I mean the class literally implements the future interface we've just seen. But it actually extends its functionality significantly by implementing another interface called completion stage, which was also introduced in Java 8. Completion stage is a representation of a stage in a larger computation. So basically, we use completable futures to model tasks in a bigger, primarily asynchronous workflow, and we have APIs to create dependencies between the tasks and chaining them. In other words, completable future addresses several problems that we have with futures. It makes tasks easy to compose, and it allows us to do so in a non-blocking way. And it automatically uses the fork join pull behind the scenes, so it actually performs very well. So this is a very mature framework for synchronous programming, but this comes at a cost of complexity. And this cost is substantial. If we wanted to show all the functionality this framework offers and common usage patterns, this talk would be several hours long. In fact, just taking a look at the API, you can probably tell this is noticeably more complex than anything we've seen today during the talk. If I just create a new completable future here and take a look at the methods, you can see that there is a bunch of them. Completable future is a big class, almost 3,000 lines of code, and quite a few methods, and if I remember correctly, there are over 80 public methods on this class alone, with inheritance and overloading. A few of them come from the future interface, as we've seen, but the main API comes from the completion stage interface, which has over 40 methods. So yeah, probably not the best API design, but there is a system to these. The reason we have so many methods is because there are 3 categories of what we want to express in the API, and we need to express all the possible combinations, which gives us 36 methods. The 3 categories are what kind of a task it is, how do I process it, what kind of an operation it supports, and where, what thread can it execute on. As for the task, there are 3 types. It can be a runnable, it can be a consumer, or it can be a function. As for the operation, we can chain them, so execute one after another. We can compose them, as in function composition, or we can combine 2 of them using AND or. And as for the thread it can run on, it can run in the same executor as the caller, it can run in the new executor passed as a parameter, and it can run in the common fork join pull. So let's take an example. And the simplest usage pattern that I can think of is asynchronous sequencing, which is about creating that basic dependency, ensuring that one task runs after another. So I'm going to create a small asynchronous pipeline here. I'm going to start by creating a completable future in a different way, asynchronously. And I'm going to use supply async here, which takes a supplier. So let's just say, okay, quick lambda here. Let's say hello. And then I'm going to call another method, then apply async. So you're probably noticing the naming patterns here, and the name really tells me, all the 3 things that are being combined in this particular instance. So supply async tells me that I'm going to need a supplier to generate my task, and I'm going to do it asynchronously, so not in the caller's thread, but either in an executor given as a parameter, or I will let the fork join pull decide. Then apply async tells me that the operation is basic chaining. Apply tells me that the task is a function, and async we've already discussed. I'll just use the fork join pull. So this needs a function here, so let's just create a quick one with a lambda. Let's just take the output of the previous completable future and combine it with another string. Let's say hello Devoxx, and then finally I'm going to call then accept async which again, the name gives me all the information that I need. It basically says, okay, the method is again chaining because then it expects a consumer as the type of my task because accept, and again, I'm running it asynchronously because async. So I'll just give it a quick consumer here, maybe just a quick method reference, and just like this, and we can see that we do get the right result. So you understand now what the system is and why we have so many methods and how the naming works. It also shows a key property of the completable future API. Almost anything that you do to a completable future produces another completable future, which gives us this sort of fluent functional API to model our workflows. Completable futures get us very far, and they address a bunch of issues that we have with futures. We can compose them easily, and we don't have to log on the main thread to coordinate. We can just tell it to run a dependent task when our task is done. This is a very important construct in the JDK that everybody should know about. This is the way to do asynchronous in Java. But like I said, it comes at a cost, and the cost is not low. You can see that even with such a simple example, the API is quite complex. The code is relatively hard to read, write, and maintain. Ordinary threading and APIs we were used to no longer work here, right? We need to use these new APIs. There's also loss of context. We're obviously using threads in the background, but they're hidden from us. We no longer have associations between tasks and threads. To get the efficiency, we split our tasks into smaller stages, and there are no guarantees that different stages of our task continue on the same thread, which of course increases complexity. And this lost context is a real issue, because as we said at the beginning, Java depends on this context, right? When we get an exception, we're given context through stack trace tied to a thread. So now we're only seeing stuff relevant to our stage rather than the whole task. Similarly, debugging is tied to a thread. When we go to the next step, it's the next step for the thread, which might now be a different task. Profiling is hard because it can tell us about the thread pool and that sort of thing, but we have limited information about the running tasks if they're waiting. And if some interesting event happened, we might not know what task it was coming from. So it's tricky. As developers, we're faced with a choice. We can either go for synchronous, which is easy for us, but inefficient for the hardware, or we can go for asynchronous, which allows us to utilize the hardware better, but at the cost of complexity in our application. So how do we solve this? Well, if you think about it, threads is what we like, right? The rest, like thread pools and asynchronous, are basically workarounds to extract more performance from threads. What if we could code in a synchronous way though, but get the scalability of asynchronous? In other words, what if we could lower the cost of threads to a point that we could have so many of them that they're no longer a scarce resource, and we don't need these workarounds anymore? And that's exactly what Project Loom brings to the table. Project Loom is experimental, but a very, very high impact effort, which will quite substantially change how we do concurrency in Java. It's a Java effort, but it's not in the JDK yet. It isn't even planned for any soonish release as far as I know, but it is under heavy development, and it has been under development since 2017. And really things are being changed all the time. The information that's out there often gets out of date pretty quickly, but here's what we know right now. Project Loom really took a step back and said, okay, concurrency has gotten pretty hard, as we've seen today. Let's get back to the roots. Let's take a look at threads and create a much more efficient version of them so that we don't need these complex workarounds like thread pools and futures. Project Loom does this by introducing the concept of virtual threads, formerly known as pipers. Virtual threads are lightweight threads which are inexpensive to create and block. They are managed by the Java runtime and implemented in user space, unlike regular threads which wrap operating system threads. So what you're getting by having Java manage them is a lot of efficiency thanks to the additional knowledge that Java has. For the operating system, as we said before, a thread is more of a black box. The OS doesn't know what kind of workload the thread is executing, what language it's written in, and how that language manages the stack. So the operating system must go for a very conservative and robust approach that gives us a good compromise across all the possible implementations. But if Java manages its own threads, it knows a lot more about what they do, so it can represent them in a much more compact way and adjust the scheduling accordingly. So virtual threads are not wrappers around operating system threads. They're just Java entities. So how do we use these virtual threads? Well, pretty much like regular threads. Compatibility was a big design goal with Project Loom, so tools and libraries that can use threads will be able to use virtual threads as well. There aren't many new concepts, it's more about having new conventions for using concepts that we're already familiar with. So let's take a look at that. Let's review what we've covered today, but do the examples with virtual threads instead of regular ones now. Virtual threads are threads, so to create one, I'll start with a thread class. Unlike regular threads, there is no public or protected constructor for virtual threads. by design so as not to have to deal with subclasses. Subclasses of thread cannot be virtual. So instead, I'm going to call a method here, and that method is called start virtual thread, which, as you would expect, requires a runnable, so I can just give it the one that I had from before. And you can see that this created and executed a virtual thread, and we got the right output here. We don't have to start threads directly, like we did just now. If we want more flexibility, there's actually a builder. So I can call the builder here. I can tell it to build virtual threads. I can give it a task, such as my runnable from before, and then I can call build, and let's call this T. And now we can check if this indeed is a virtual thread, and of course it is, and we can start it explicitly, and this works just fine. This builder is actually a really nice addition to the Thread API. It's not specific to virtual threads, of course. I can use it with regular threads as well. It's just kind of an overall convenience feature that just happened to be added as part of Project Loom. The things I had to do with threads through constructors and setters before, I can now do with the builder. For example, I can just go back here and maybe I can decide to name a thread, let's say worker, which works just fine with virtual threads as well, and could be very useful actually since we now have so many of them. But there are many limitations as well. For example, priorities are ignored. If I wanted to specify a priority here, I can just go here, priority, and let's say maybe thread minimum priority. By the way this works is the default priority is normal, which is actually just 5. Usually assign priority on a scale 1 to 10 here. And in this case, I've assigned 1, the minimum priority. But if we do a test, if we take a look at the priority of this thread and see if this is equal to the normal priority, not the minimum one that I assigned, you can see that this test passed. In other words, the priority of virtual thread is always normal priority. Thread groups are not supported either. If I go back to my example here, and maybe let's just change this line to specify a group, I can reuse the group from before, you can see this will not, in fact, work. To be exact, when I say thread groups are not supported, what I mean is that I cannot specify a custom group. But to be consistent with regular threads, where each of them needs to be assigned to a group, they do actually have an implicit group. And if I take a look here, you can see that there is a group called virtual threads. It's pretty limited. The expectation is that we'll have millions of virtual threads. So we can't, for example, even enumerate threads in a group, but it does exist. Many methods that we've seen in the Thread API are also missing support, especially the ones that we've described as confusing. For example, the method run here actually doesn't do anything, just to avoid confusion. The deprecated methods like stop, suspend, resume also don't work, and they actually simply throw an unsupported operation exception. But the main methods that we saw, like get stack trace, sleep, current thread, and things like that, they of course work just fine. We can maybe demonstrate just one of them here. I'm going to change the task here, do a quick lambda, and maybe let's just print out the name of the current thread. So I'll use the current thread here and then get name. And of course I have to remove this group here, but we can see that this works just fine. Importantly, thread locals are supported as well. These are obviously used very frequently, so if they weren't supported, it would be a substantial barrier in adoption. And we can demonstrate this just by going back to the builder, and I can change my task again, and maybe I'll just modify this to be a block. Let's just do a quick lambda, and inside this block, I'm just going to create a new thread local, let's say of type string. Let's call it TL, and new thread local just with a quick diamond here, and then let's assign the value here, maybe hello Devoxx, of course, our favorite string. Let's close everything and see if this works. So now if I start a thread, this actually works just fine. The good thing about this is that in some way, thread locals actually work better with virtual threads than they do with regular threads. Because remember, one issue that we had with thread pools was basically the potential for thread locals to leak because we were sharing threads, which is no longer an issue here because virtual threads are so cheap, we don't actually need to share them. There are complications here as well, though. The reason Loom works is because virtual threads are so lightweight, right? To a point that having thread locals could actually substantially increase their footprint. And because we have so many of them, reduce the scalability as a result. So if you actually wanted to keep them really light, you can disallow thread locals through the builder here. If I go back here, I can add another method here, just disallow thread locals. And now if I go back and start a thread, I am actually getting an exception here. It should also be noted that inheritance is tricky as well with thread locals. Thread locals can be inherited between the parent and the child threads. And with Loom, we're actually encouraging creating new child threads frequently for various stages of our computation because they're so cheap. Like we could, for example, create a new thread for each HTTP request to different microservices that participate in answering kind of, one external request coming in. So we might actually rely on inheritance even more now. But thread locals are immutable, as we've seen. And as such, they're not safe to share between threads. So they must be copied when you're creating a new thread, which creates performance overhead. Again, multiplied by the very large number of threads that we have now. So alternatives to thread locals are actually being explored as part of Project Loom. And one of these alternatives are scope variables. Scope variables are immutable, and they have a smaller scope, just a code block instead of the whole thread. These scope variables have been prototyped in Project Loom, but it's a very early prototype. There's just one class with absolutely no Javadoc. So it's likely to change, possibly even disappear, or the implementation might even be deferred to a future Loom release, not the initial one. But a simple example would be something like this. I can create a new scope variable here, let's say, for type, maybe let's just use string here, and let's call this s. Now I can bind a value to this variable. Let's of course use our favorite string here. And now this value is in effect for the duration of the scope. So this is still immutable. I can't mutate this scope variable, but I can bind a different value to it in a different scope. And once you leave the different scope, you have the old value again. So I could, for example, have a block in a thread, defining the scope, then create a new thread in that block, share the value in the scope with that thread. It supports nesting that way. And then bind it to something else in the child thread, and then when I return to the parent, it will have the original value. There are some language changes necessary to demonstrate this behavior in a meaningful way, so I'm not going to show it. But for now, I can just simply extract the value so that we can just see the API. What's also important is that not just the bare thread, but Java 5 features that we saw are supported as well, to an extent. So, for example, thread factories work just fine. In fact, they're not only supported, but it's actually much easier to create them now with the new builder. So if I go back to my builder here, I can just tell it, to build virtual threads, and then I can tell it to create a factory, and let's call this TF, and this, of course, works just fine. The importance of this being supported is that this is sort of an integration point with other APIs we're now used to using, such as executor services. If you take a look at the factory methods for executors here, pretty much all of them actually accept a thread factory as an optional argument. So we can give them a factory to create their threads, and because we now have a factory for virtual threads, they all automatically work with virtual threads. So we can migrate from regular to virtual relatively easily. I can reproduce our executor service example from before, in fact, now with virtual threads. If I just go to my executor service, and let's see if we can find it, I'm just going to use new thread executor. Let's just use the basic one. And let's say I'm going to pass it my thread factory to make it work with virtual threads. Then I can submit the task, of course, a callable here. So just the quick lambda, hello Devoxx. And this, of course, returns a future. And now finally, I should be able to extract the value from my future. Notice that this really is the same as the example from before, right? The only difference is the thread factory here. So very easy, drop and replace. For convenience, we actually also have a new executor directly contributed by Project Loom. If I go back to this line here, I can, instead of the new thread executor, just use the new virtual thread executor, and then everything is going to work as before. This virtual thread executor is actually very simple. Since with virtual threads, we don't typically need any sophisticated constructs like thread pools because they're so cheap, it actually just creates a new virtual thread for each task. Loom actually provided another enhancement to executor services that's very cool. Executor service now extends auto-closable. Pretty much all the constructs that represent external resources do that in the JDK now, so this just makes complete sense. The advantage in practice is that we can now use executor services in try with resources statements. So relying on our example from before, I can do something like this. I'm going to start new try with resources. I'm going to create a new executor service. Maybe let's just use the default one with our custom virtual thread factory. And then I'm going to start the body and just submit a couple of tasks. Maybe let's just submit our runnable from before. Let's do a couple of these, just like this. And this, of course, works just fine. So what this does, it creates a new executor using our thread factory. This executor creates a new virtual thread for each task we give it, no pooling or anything because we're talking virtual threads. And then we give it 2 tasks to execute, and when they're done, we clean up. The interesting thing about this is that the current thread will block waiting for all the tasks and their threads to finish. In other words, when we exit the try with resources, all the tasks and their threads are guaranteed to have completed. And this is a very interesting and a very powerful invariant. This concept is known as structured concurrency. And there's literature available about this. I'm not going to go into too much detail. But basically, structured concurrency means that the runtime behavior mirrors the structure of the code, which makes it easier for us to reason about the code. Our code is arranged in blocks, and based on these code blocks, we can see where each thread starts and finishes. So implicitly, every thread has a parent that blocks until the children terminate. There are actually more similarities between virtual threads and asynchronous programming with completable futures, including scheduling. With virtual threads, we're not scheduling on the CPU directly, but we schedule virtual threads onto regular platform threads, which we call carrier threads. So like with asynchronous programming, we do end up scheduling kernel threads ultimately, but we abstract that through familiar threads rather than some new constructs. From application perspective, carriers are isolated, we can't access them. For example, the current thread method will refer to our virtual thread, not the carrier. Only the scheduler interacts with the carriers and mounts virtual threads onto them. Similarly to completable futures, the default scheduler that we use here is the fork join pool, like we've seen before. By default, the number of carriers is equal to the number of cores on the machine, but it is configurable at the JVM level through a flag, similarly to how you would configure parallelization for, let's say, parallel streams. If you wanted to specify a custom scheduler, you can specify it when you create a thread in the builder. So if I go back to my builder here, let's just find one, maybe this one, I can go to virtual and try to autocomplete, and you can see that this does actually optionally take an executor. So for example, if you're not happy with the global number of carriers, you could implement custom schedulers that delegate to different numbers of carriers based on the tasks. As we've seen, executor is a very simple interface. It only prescribes one method, execute, which takes a runnable. There's even an interface extending runnable to represent a task for a virtual thread, and that's called virtual thread task here. This allows us to distinguish between virtual and regular tasks so that we can deal with blocking and resuming on carriers. By the way, the assignment of scheduler to a thread is permanent, so you can't change schedulers for existing threads. One final thing before we wrap up here, Loom also introduces the concept of continuations. Strictly speaking, this is a low-level construct that we as application developers don't even need to be aware of, but it is currently a part of the public API, so I wanted to mention it at least briefly for completeness. The idea is that running virtual threads requires 2 things, a scheduler and continuations. The scheduler decides when and where we run, which carrier thread we mount onto, and the continuation decides what we run. It's a representation of computation that can be paused and resumed. So it's basically a wrapper of a runnable that can pause and continue from where it was paused. With Loom, we're mapping a large number of virtual threads onto a small number of carrier threads. So it works well when threads are waiting most of the time for I/O, which is a common workload in most applications, fortunately. So we need the thread to tell us when it's about to block so that we can offload it and then resume. And with millions of threads, we basically shuffle the virtual threads across the carriers frequently. And that's what the continuation provides, is this ability to pause and resume. So our execution is this constant handoff between the scheduler and continuations, right? And it's important to keep these concepts separate because this allows us to reuse ordinary Java schedulers for virtual threads, as we've seen. Continuation needs 2 things. It needs a scope and it needs something to run in the form of a runnable, of course. It provides 2 important methods. There's a method called run and a method called yield. When you call run, a continuation starts running the runnable until it calls yield. When the continuation calls yield, the run method returns to the caller. And the next time you call the run method, it will continue from the last point the continuation yielded. For example, let's start by creating a scope. I'm just going to create a new continuation scope. Let's just call it scope, and let's call this whole thing CS. And now I can create a new continuation. You can see here that this needs a scope and it needs a runnable. So I give it the scope that I just created, and let's create a new runnable here. Let's create a more complex one. It's going to be a multi-line lambda here. And first, I'm going to just print out something. System out print line, let's say hello. Then I'm going to call yield, continuation yield, to my original scope. By the way, you can yield from any depth here. And then I'm going to continue executing something. So maybe just another printout, let's just say Devoxx here. And now I should be able to run this. So let's actually give this a name. Let's call this C so that I can call run here. And you can see that it did execute the first printout, but then it stopped, right? It yielded and it returned to the caller. We can check if this continuation is done, and you can see that it's not done, still more work left to do. So we can try running it again, and you can see that it now did not execute the first printout. It just continued from where we left off and executed the second printout. So we can check if this is done now, and of course this is now done, so if I try to run it again, it will not work anymore. But a very cool and very essential concept here. So to sum up, virtual threads allow us to achieve pretty impressive efficiency. Creating virtual threads is cheap. You can have millions of them without the need for thread pools in most cases. Blocking is also cheap. You don't need more complicated asynchronous programming in many cases, you can just be synchronous. And if you want the flexibility of synchronous programming, you can make it work with virtual threads through pluggable schedulers too. It should also be noted that migration to virtual threads is likely not going to be as scary as it might seem. We've seen some of the constructs in Loom that allow us to connect virtual threads to other existing constructs, but there's a lot more functionality in the JDK that has been adapted or will be adapted to work with this new model. This includes networking primitives like NIO channels, sockets, HTTP URL connection, console I/O, but DNS lookups, process pipes, and file I/O are also being explored. This means that many constructs that use these primitives, like JDBC drivers, HTTP clients, and servers, will get support for virtual threads automatically. And even frameworks and libraries external to the JDK, like Spring or Hibernate, ultimately delegate to the JDK when running blocking operations, so they will also get a lot of stuff for free. The expectation is certainly that the vast majority of libraries will not require any special treatment. And other JDK tools like debuggers and profilers like the flight recorder are also being adapted, and a lot of progress has already been made there. And that's it from me. I hope you found this talk useful. If you want to learn more about the topic, I'm sure you'll have no troubles finding materials on concurrency in general, but I thought it'd be useful to point out some resources about the emerging Project Loom, because these are actually not completely easy to find. The first link on this slide is sort of the main Project Loom resource. It's just a couple of pages on the OpenJDK wiki with links to downloads and such. But unfortunately, the documentation is very sparse. The closest thing we have to documentation is actually this article by Ron Pressler from the Java Platform Group on the state of Loom from earlier this year. This really helped me learn more about the project, and many of the examples I've shown today were inspired by these talks. If you have any questions, I believe we have a Zoom room arranged for the next 15 minutes. You're welcome to join, and I'll do my best to answer these questions. Or feel free to reach out to me later. My Twitter handle is in the corner here. And otherwise, thank you. Have a great weekend, wherever in the world you are, and enjoy the final keynotes here at Devoxx.
Thank you, Miro, for these two exciting talks. I hope that our participants enjoyed them. And we welcome to ask the questions by joining the Q&A Zoom room. And dear participants there, you can unmute, put your audio, video on, and have a discussion with Miro. Miro, and thank you once again for supporting Devoxx Ukraine online. We hope that this lockdown will be over next year and we can meet in person and we can welcome you in Ukraine.
Likewise, thanks for having me and looking forward to next year already.
Yeah, thank you. Thank you so much. Okay, dear participants, we are moving forward and please welcome the video presentation from our silver partner, DN Simple Company.
Your domain is the backbone of your business. You need a stable, secure, and reliable DNS provider to protect your investment and ensure your customers can always stay connected to you. But being stuck in a room with a hungry mosquito is way more appealing than navigating the world of DNS management. Until now. DN Simple has solved the problem of needlessly overcomplicated DNS management with automated tools that most people have never even dreamed of using. Want to register a new domain? Enter your information once and you're done. How about selling domains from your app? Integrate your sites with our API to instantly provide more value for your customers. Set up the DNS records needed to connect to services like Heroku, Shopify, and G Suite with one click. And use our automated SSL certificate generation to easily secure all of your websites. It's so user-friendly, everyone from grandma to this super genius can connect their domains to the services they use without ever thinking about DNS. Simple, secure domain management is right here at DN Simple. Try us free for 30 days.
Thank you, DN Simple Company, for supporting Devoxx Ukraine this year. And we want to invite to the presentation our next gold partner, Luxoft Company.
The future of business depends on the transformation of yesterday's legacies. Luxoft meets the challenges of today by developing the solutions of tomorrow. Because innovation lies in our core, it allows us to reinvent and not just respond. Domain integrity, coupled with ability to scale, is how we define our purpose. Think about tomorrow's autonomous driving landscape. Digital companions that always steer you in the right direction. We will empower the mobility revolution to put stunning user experiences on the road. Imagine the patients of the future connected to 24/7 health monitoring systems and treated by algorithms that can predict and even prevent diseases. We can help our clients to improve patients' experiences and drive them into the digital era. Our perception of money might not change in the future, but everything else will. Luxoft helps integrate businesses with advanced technologies that deliver an unparalleled experience. Using our blockchain expertise, we help to remove data silos and improve trust. We are taking full advantage of the growing symbiosis between human and AI talents. With self-learning machines and robots on our side, we will be able to shape the world of tomorrow. With our client-centric approach, Luxoft quickly connects the dots to identify a perfect solution, from development to delivery. We offer technology hope. We embrace customer fear, and we drive the experience of tomorrow. And because we live and breathe technology, we see what others have missed.
Hello, Devoxx community. Even though I cannot see you, I can feel you, that you are there behind the screen, and it's a great pleasure to know that you're today gathered at this conference. My name is Lesia Manzevich. I'm an employer branding manager at Luxoft Ukraine, and it's a great pleasure for us to support Devoxx throughout the years, especially this year. It makes us even more proud that this year, in times when we are all threatened and many events are cancelled, Devoxx managed to turn from the biggest Java-related Ukrainian event into truly global happening. Way to go, guys. This is beyond amazing. Java is actually one of the most popular technologies in the world, and hundreds of thousands of solutions are being built daily utilizing this technology. At Luxoft, we honor it and use it in many projects as well. If you enter our website and go through it, you will see many vacancies and events dedicated to Java. Please feel free to study more and join us at any event or join our team at any time. When we participate in conferences, we at Luxoft always strive to make new friends and to get to know people. This year, for obvious reasons, we are forced to do it digitally, but nonetheless, we really want to establish that contact with you. So please feel free to join our Telegram channel and to take part in our friendly giveaway, to test your knowledge in Java, and not only in Java, through our Galactic IT quiz. You can find the links in the partnership section of your screen, of your today's screen. We have a lot of presents for you at Devoxx. These are gift certificates, chargers, backpacks, and even a bike. So as the Devoxx is a 2-day conference, we will announce our winners tomorrow. That means you have still plenty of time to join and to become a winner at our giveaways and Galactic IT quiz. That's probably, I will wrap up my presentation, but the last but not the least, I would like to mention that Luxsoft unites over 3,500 people in Ukraine and over 12,000 people globally. We strive to make difference and to bring excellence to our customers. And we think that it's a great cause. That's why we always encourage people to join our team and actually to make a world a better place somehow. So please, don't hesitate, join, participate, take part in the quiz. And at Devoxx, learn, become smarter, and have fun. Enjoy. It was a pleasure meeting you.
Okay, dear participants, we continue Devoxx Ukraine. We have just 2 talks left. And now I would like to invite to our virtual stage Bruno Souza, Java evangelist, founder of the largest Java community in Brazil, SuJava. So he will connect from South America today. Bruno, welcome. Hello, Bruno.
Hey! Hello, everyone.
Hello.
Can you guys hear me well?
Yeah, we do. We hear you well, see you well. So how are you today?
So good to see you. Oh, we're doing fine, doing fine. Great day today. Awesome to be here on Devoxx Ukraine. You know, thanks everyone for organizing this awesome event. You know, I've been to Ukraine. I think when I went there was it still called the Java Day in Ukraine? I think it was, right? But you know, I'd love to be here with you. I wish I could be there, right, in Ukraine.
We wish there too.
Such an awesome experience to be there with you. So thank you everyone for inviting me again to be here.
Yeah, thank you so much for supporting our event and giving a talk and participating in the round table. So I will not steal more time from your presentation. So the mic is yours. Please start.
Okay. All right. Awesome. So let's get going with this. So let me just kind of adjust this thing here. All right. So basically, you know, we're talking here about learning faster, right? So let me show this here for you, right? So that's the idea. A lot of people want to learn faster, right? So that's what we want. We want to learn faster, right? To be better, right? To be a better developer, right? So that's kind of the idea. We want to learn faster to be a better developer. But the reason why we want to do this is because we're going to get more results, right? And I think that it's really, really important that we have to think about what results all about, right? And the one thing I want to show you guys here is that really for you to learn faster, for you to be a better developer, better professional, and for you to get more results, it's all about the skills, right? So that is the topic that we're going to talk about today. So we're going to talk about those 4 things here. And one thing that I want you to think about is that we, right, developers, technical people, we tend to be, Java developers in particular, right, to be aficionados, right? Maybe about learning, right? You know, we want to learn everything. We're going to learn new technologies. We're going to learn new frameworks. We're going to learn new languages. We're going to learn, all the new version of Java, right? We're going to learn. So that's why when we talk about, learn faster, right? So we're going to talk about learning faster. Oh man, so I can learn faster. And then if I can learn faster, that's awesome because I can learn more things, right? But at the same time, we do understand that learning is not the objective, right? Think about it. How many times have you bought, a book, right? Or how many times have you bought a training online, right? And you never even opened the book, you never even read it, or you never accessed the training that you bought, right? We fictional about learning, but we understand that just learning is not enough, right? Another thing, how many of you put, all the books you read on your resume, right? That's not what you put in your resume. You don't put what you read. You don't put your training, maybe one or another, but usually you don't put all your trainings that you took. You don't put all the videos that you watched on your curriculum, right? What is it you do? You usually put your experience, right? It's not about learning. It's about your experience, right? And so the one thing that I want to discuss here is, right, is actually, experience doing things, right, is the only way for us to get skills. And I think this is really, really important because we tend to forget that, right? We know that the most important thing is not learning, is experience. But we kind of mix things up by thinking that, the more I learn, the more experience I have. And that is not true, right? It's not about learning. It's about creating the right skills, right? And so because skills is so important, we understand how do we acquire skills, right? What is the real way to acquire skills? And so let me just kind of see here, because one thing that I really would love to do is, if you're watching here, really would love to do to see, if you have any questions, right? So I want to make this very, very interactive. So, I'm just going to go to the chat here. So if you're watching me here, I can see the chat at the I think we are on track 1, right? So I'm at the chat on track 1. So if you can go and ask questions there, so we can make this very, very interactive. It's not about what I have to say, it's about what is your challenge that you're facing right now that I can help you out, right? And I see there's a couple of questions here from Luca, for example, and JCADs, right? Okay, so we're gonna go over this question in a minute. That's awesome. I'm loving this. All right, so basically, and feel free, to ask as many questions as you want there. Okay, so basically, it's all about experience, right? So, and that's one very important thing. It's not about learning; it's about experience. So, it's skills. You only acquire skills by doing. So we have to understand what are skills and how do they work, because a lot of times we kind of confuse what skills are. So let's think about skills for a minute, right? I want to say one thing that lots of people don't think. When we think about skills, we understand, like, for example, if I want to be a soccer player, for example, or I want to be a basketball player, or if I want to be a skateboarder, right? There's a lot of physical skills. We understand that, right? Now I have to have my muscles. I have to, prepare my body so I can actually go and do those things. So there are physical skills, and we think, okay, so those are physical skills, but programming, software development is an intellectual skill. So it's not physical, it's intellectual. But we forget that even the intellectual skills, they are biological. Okay, they are physical in a way because they're biological. The connections in our brains, they're physical connections, right? The cells in our brains, they're physical. I mean, they're like muscles. They're different types of cells, but they go by the same rules of biology. So that's very important for us to understand, because we have to understand that learning is not the objective. The objective is doing. So let's think about how biology works and how biology has to do with skills, right? So, you have in your brain lots of neuron cells, right? You guys know this very well, right? So those are cells like this. You've seen this in your biology studies when you were in high school, for example, right? And if you remember, right, so the neurons, the connections between the neurons are the things that actually makes you a developer, right? It's very cool, right? So how do we actually create those connections? The same way that you have to practice to get muscles, you have to practice to have neurons, right? Software development neurons, Java neurons, right? So how do we create our Java neurons? One thing I want you to understand is that, in this cell here, there's this little thing here that you might have, that you might recall from the drawings when you're a kid, right? Or maybe you've seen this lately or something, right? So this here is called the myelin shaft, right? So this is myelin. Myelin. Come on, what does this have to do with Java? You're gonna see in a minute. I understand. So let's just see in a minute. Myelin is this little it's an insulation barrier, right? So the more myelin you have in your neuron, the faster the electricity travels on the neuron, right? So the more myelin you have in your neuron, the faster energy travels in the neuron. What this has to do with skill? Because the faster electricity passes through your neuron, the faster you think, right? So I just want you to understand, and basically the way it works, right? If you cut this thing here and you see from, you get this thing and look from like this, what you're going to see is that you have the neuron here, the axion, this thing here, right here in the middle, and then you have, the myelin covers around it, right? So basically, when you become good at something, your body puts myelin around the neurons so your neurons can run faster, right? And so, and what does faster means, right? That's very, very important. What does faster means? Well, let me tell you what faster means. A neuron with lots of myelin around it can be 100 times faster than a neuron without myelin. 100 times faster. And not only that, it can activate. The time for it to activate is 30 times smaller. So it's 100 times faster, and it can activate again in 30 times, in 1/30th of the time. So you know what this means? Do you understand what 100 times faster? Think about the Java VM. If the Java VM is 100 times faster, right? What does this mean? 100 times faster means magic, right? It's magic. Remember how we call that amazing basketball player? We call him Magic Johnson. Why we call him a Magic Johnson? Because 100 times faster in the brain makes you way better than other people. So much better that other people look at you and say, "That's magic. How can this person do this?" Right? How can he be so fast? How he can do things like this? So that's what you need. So Christina is asking, project counts as experience. I'm going to talk about side projects in a minute, Christine. But but the thing is, if you can if side projects, Christina, can help your neurons be faster, then yes, they're going to help your skills. So let's think if they can, right? So what we want is that we want to make our neurons faster, right? I know this is a biology class, but let's think about it. I want you to understand, skills are myelin. Skills are not crazy things. They're like ethereal things, like things that you don't understand. Intellectual skills are myelin in your brain. The more myelin you have, the better skill you have. That's simple like this, even for physical skills, right? Because for you to be able to, throw the ball in the right place in basketball or kick the ball in the right place in soccer, your brain has to be working. There's no such thing as muscle memory. The only memory you have is in your brain. So the neurons that goes from your brain to the tip of your foot, they have to have myelin in it for you to be able to do things in a physical thing. So skills are myelin, right? And why this is important? Because myelin is a biology thing, right? So let's think about it. If everything is biology, right? Let's think about how to do skills. Let me show you the rules of skill achievement. There are 4 rules. There are 4 rules of skill achievement, and they're all grounded in biology. Rule number 1, you have to activate. You have to activate. What does that mean? I can't get stronger. Let's say my muscle, right? I can't, do push-ups with this arm here and my other arm will going to be magically strong. That's not going to happen. The only muscles in my body that will get stronger are the ones that I activate. So if I want a muscle to get stronger, I have to activate the muscle. That's biology. You can't force in your brain like, muscle, get stronger. You can't do that. You have to activate the muscle for it to get stronger. It's the same thing with your brain. You can't get a neuron to be faster. You can't put myelin in a neuron. You can't inject myelin in your blood, your blood current, and then you magically get better. No. You have to activate the right neurons for you to get better. So if you don't activate a neuron, you don't get better. So that's why, Christina, we have to do things, right? If we do things, then we activate the right neurons. So that's the biggest misconception we have. If we learn, if we read something in the book, let's say I get a book to read something, just to learn. If I read something in the book, am I activating the neurons? Let's say I read something about Java in a book, right? So I'm reading, Java bytecode, right, in a book. So which neurons are being activated? The neurons of doing, of working with Java bytecodes, or the neurons of learning about Java bytecodes? So it's just the neurons of learning, right? So it's not the neurons of, it's just the neurons of reading. They're being activated because those are the ones I'm exercising, right? So if I really want to get a skill, I need to activate the doing neurons, let's say, right? So that's why, of course, some learning is important, right? But for us to get skills, we have to activate the right neurons. So we have to do things, right? And so if you don't activate the neurons, there's no myelin, you don't get better. Okay, so that's the first rule. The second rule of skill achievement, right? You have to force it. Okay, what do I mean by force? Let's think about muscles again, right? Let's say I have this 1 kilo heavy thing here, right? And I want to get muscles in my arm. So I'm going to do like 10 push-ups with this, right? So if I do 10 push-ups with this, and that's good, right? My muscle going to get better, right? So tomorrow I do 10 push-ups again with 1 kilo. And then after tomorrow, I do 10 push-ups again with 1 kilo. A month from now, 10 push-ups again with 1 kilo. A year from now, 10 push-ups again with 1 kilo. Is my muscle getting better? Is my muscle getting stronger? No, it is not. Why? Because after a week, I'm strong enough to do 10 push-ups with 1 kilo. And then my body doesn't need to improve my muscles anymore. That's the same thing for your neurons. If you don't force your neurons, your brain's not going to put more myelin in it. Your brain only puts myelin on the neurons that are being forced. No force in the neurons, no myelin. So how do you know how to force a neuron? Well, how do you know how to force a brain? You do it more than you are able to do. You do until it hurts, right? But more than that. Very important. You do until it hurts, but not more than that, because you don't want to destroy your muscle, right? So you do it a little bit more. Same thing with the neurons. You have to force it, but how much you have to force it? Look, lots of people say, oh, you have to work outside of your comfort zone. Very problematic this, right? Why? Here's your comfort zone, right? Working outside of your comfort zone, it's outside, right? And then, when you work outside of your comfort zone, you make a lot of mistakes, right? So if you make too many mistakes, like it's destroying your brain, if you make too many mistakes, that's forcing too much, right? So for us, we want to work on the edge of our comfort zone, right? This is the comfort zone, right? We want to work on the edge of our comfort zone. How do we know we're working on the edge of our comfort zone? We are making mistakes. Mistakes, right? If we're making mistakes, we are working on the edge of our comfort zone. Now, if we have no idea what we're doing, if we're getting everything wrong, we are complete outside of the comfort zone, and that's actually prejudicial, right? It's like pushing your muscle too far. But if you want to improve, you have to work a little on the edge of your comfort zone. You have to make mistakes. If everything you're doing is always right, you never make mistakes, then you're in a comfort zone, right? So you have to make mistakes, a little bit of mistakes, but not completely wrong, okay? So that's the idea. So basically, that's forcing. It's working on the edge of our comfort zone. Make sense? So if you don't force, your body is not going to put myelin around your neurons, and then you're not going to get better. So you have to activate the neurons, but activate them stronger than the easy part. You have to have difficulty of doing it. If you don't have difficulty of doing, then you're not improving. All right. Now the third lesson about the third lesson, or the third the third rule, right? Those are rules. The third rule about skill acquisition, right? It has to be frequent. Okay? Right? You have to do it continuously. Right? So actually continuous could be a better word. We have to do continuously. Continuously. Right? You have to do continuously. What do I mean by doing continuously? Look, let's go back to our muscle again, right? We go to our muscles and we say, okay, I don't have time to do 1 hour of exercise every day. So what I'm going to do is I'm going to wait to the end of the month, and once a month I'm going to go to the gym and I'm going to do 30 hours of exercise at once a month. Will that work? No, it will not work. It will destroy your body, right? And you're not going to have time to increase muscles, right? You're going to have your body completely destroyed, and you're not going to have time to increase your muscles at all. So it doesn't help to just kind of bundle together and do a lot and stop doing, right? You got to keep doing every day, a little bit every day. 5 minutes a day, 15 minutes a day is better than several hours on the weekend, right? 5 minutes a day, 15 minutes a day is better than several hours on the weekend. That's very, very important. So you have to do continuously every single day, right? Every single day. So is this a coding equivalent of do something every day that scares you? Yes, Alan, that's right. Exactly. So activate, right? Something every day, frequently, right? That scares you. That's a little bit stronger. Right. You're totally right. I love this phrase, Alan. Okay. So the fourth rule of, you got to do it frequently, right? So you got to activate the right neurons stronger every day for you to get the skills. Now, the fourth rule, I just want to tell you this. The fourth rule is a sub item of rule number 3, right? So let me just do this. It's not four rules. It's actually 3 rules, but a 3.1 here, right? A 3.1 rule is if you stop, you lose it. All right? You know this very well. If you do exercise and you stop exercising your muscles, and you spend like a month not doing any exercise, or 2 months not doing any exercise, your muscles all go away, right? All the effort disappears. Same thing for your brain, right? If you stop activating your neurons, things go away. Really, there's a famous musician that would just say, if I stop practicing 1 day, I notice. If I stop practicing for 2 days, my wife noticed. If I stop practicing for 3 days, the world notice, right? So if you stop, you lose it. So those are the 4 rules of skill acquisition. Any skill, right? You have to apply this. So let's answer some questions here, right? So Christina says mind blowing. So thanks a lot, Christina. Awesome. So think about those 4 rules to acquire skills. It's not about learning. It's about skills. So now let's answer some questions here. So Christina asked, do side projects count as experience, right? Do they help us get skills? So if you do a side project, does it activate your neurons of doing? Yes, it does. Does it forces you? It depends on the project. If you're doing a very easy project, then it doesn't help. Okay, but it's doing a project that's hard, right? Yes, it does forces you. Do you run your side projects for 15 minutes, for 1 hour, for 5 minutes every single day? Christina, if you do this every single day, yes, it helps you, right? So yes, and of course, if you're doing a project, you're not stopping training, right? So basically, yeah, so the 3 rules, remember, those are the 3 rules of skill acquisition, right? So if your project helps you to do that, Christina, yes, it solves you, right? Let me see here. What else? What other question I can answer right now? You know, mean by learning back end, by trying, you know, practice things that you learn it might help you get the direction skills, isn't it? Yes, exactly. Right. If you apply, you know, if you try to look, let me tell you one thing. Let me tell you a story here. Right. My friend Oleg, that's here, organized this event. Right. Oleg gave me a gift. Right. For me, I'm part of the event, so he sent me a gift. He sent me a new video game. Right. For me to play on the PlayStation or Nintendo. I don't even know which one I'm going to play on. But he sent me a new game. So right after this talk here, I'm going to go, you know, I'm very excited about this new game. It looks like an awesome game. I'm very, very excited. So what I'm going to do, right after I finish this talk here, I'm going to go and I'm going to read the manual. Right? Is that what I'm going to do? I'm going to read the manual? No way, right? No one's going to read the manual. What I'm going to do, I'm going to go play the game. Look, that's the same thing if you want to do back end, or you want to do anything about Java, or you want to do anything, you know, cloud computing, or anything you want to do. It's not about reading the manual. It's about going and doing, experimenting. So that's what I'm going to do. I'm going to play the game, right? So that's what you should do. Of course, if I go play the game and I have no idea how to play the game, I have to learn a little bit. Well, what are the commands, right? And then I can start. Same thing for everything else, right? You know, you have to learn a little bit, enough for you to get started. Once you get started, then you can learn more, because now you're doing something, and now you're activating your neurons. Now you're forcing yourself to try to solve the problems. You're making mistakes, right? Because you're trying to learn. So that's what Teresa asked here. I agree with the continuous improvement. However, it takes some time to get into a topic. How can you focus on some problem for just 5 minutes? Do you have, okay, all right, so Teresa, so let's talk about the 5 minutes in a minute. But very important, right? Of course, it takes some time for you to get into a topic, right? It takes some time for you to learn something enough, but it's just a little bit of time, right? A lot of people, they want to read the whole book, right? Or they want to learn everything about Java, or they want to learn everything about containers to start doing anything. No. You start doing first. And then you figure out what is the next step. You do enough to figure out the next step. All right? We do enough to figure out the next step. Teresa, I'm going to leave the 5 minutes here for a minute, all right? Because I want to talk about other things first before I come back to the 5 minutes part. All right. So let me go answer some more questions here. That's all I want, right? I want to answer as many questions as I want. As you want to ask me. So people who start coding late in their age, over 40, right? They're late for programming. No, Luca, that's a good question. No, why? Because even after you're over 40, you can still grow neurons. That's an awesome thing. Your brain is very plastic, right? And so you can grow myelin. Myelin grows in your brain until you die. Right? Until you die, you're still growing myelin in your brain. So you can put myelin in the right neurons. Doesn't matter what age you are. So yes, Luca, it's totally okay to start after 40, right? That's not a problem. Jakey says, I started programming when I was 31, right? So that's awesome. Fully qualified lawyer and did this. So that's awesome. Congratulations, Jackie. So yes, I totally agree with this. I started at 44. Your brain's hungry for new experience. Go for it. Exactly. Because your myelin, look, we learn it in school, right? That the neurons don't grow. You know, if you lose a neuron, there's not going to be a new neuron in place. And that is true. After a certain age, your brain doesn't create new neurons, but your brain creates new connections and myelin, right? So you can use the neurons that you have. They're already there, right, to create more myelin and create new connections to start programming. So that's totally fine. You can do it after 40, no problem at all. Let me see here. Can we consider learning to be a stage to get skills? Let's say read some Java books and start to do things until you forget it. Okay, so no. Very careful, Vitality. So yes, learning is a stage to get skills. Yes, you're right. But then you go in your question and you say, let's read some Java books. No. Read one paragraph of one book and you start doing. right? You start doing as soon as you can. Do not read some Java books. It's not going to help you. Do not even read a full Java book, right? Read the first example and try. You start with the minimum thing you have. You start doing as soon as you can, Vitality. That's what's going to make a big difference, right? Find a mentor is the best way to improve your skills, in my opinion, right? Okay, so I'm gonna talk mentor later. Okay, mentor is a great way here too. I'm gonna save it here for later. Okay, so Vitality says, yeah, then you never stop the learning phase, right? So yeah, so don't do this. Don't ever. You gotta. The learning has to be mixed with the practice. You learn, mix it with the practice. Okay. Okay, so yes, so yeah, you okay, so don't we can talk more about how you can read websites a little faster if you want that, right? Okay, cool. So lots of smiles. So why do textbooks exist? All right, Alan, that's such an awesome question, Alan. Man, look, this is like a really awesome questions, Alan. So let me tell you, there is a curse of teaching, a curse of training that's very complicated, Alan. Look, think about it. For you to get skills, you have to activate the neurons, right? And you have to force it, right? But to force it, you have to make mistakes. And when you make mistakes, how does that work? It's frustrating, right? When you make mistakes, man, this is frustrating. And so if it is frustrating, you don't want to do it, right? You have to force yourself. Now, let's say you buy a book, Alan, and that book is, it's a frustrating book. You're reading the book and you try the examples and you make mistakes. It's frustrating. Or you go to a training at a school, for example, and you try things and you make mistakes. It's frustrating. So what happens? You complain about the book. You complain about the training. You say, that's a terrible training, right? It's frustrating to go through it. So what do trainings and books do? They do it in a way that's not frustrating, right? They do it in a way that you don't make mistakes. And if you don't make mistakes, you don't force your brain, right? And so you like the book, say, oh, that's an awesome book. Oh, that's an awesome training because I was able to do everything. And then you go home and you have no skills. And then you have to go somewhere, right, to get these skills. You have to do a real project in your life, right, to get the real skills. Make sense? Right? So that gets completely crazy. So that's a paradox of teaching. You have to make it interesting enough for people, and by making it interesting and easy for them to learn, you're not forcing them, so you're not helping them get the skills. Isn't it crazy? Right? So that's completely crazy. And so it's good for you to know that. Once you understand that, what happens then it's better for you, because now you can choose how you learn, how you acquire your skills. Make sense? So most tech books come with company code to follow by doing. So the problem is most people just read. They don't actually do things, right? Most people just read, they don't actually do things. All right, so that is complicated. Okay? So that's very important that you go and do things. All right? So let me ask one thing. For me, it looks like there's a delay on the stream. Can you guys still hear me well and see me well? No problem. I'm just gonna continue here because for me it looks like the whole video is kind of slow motion here for me. All right. So bottom says how you don't forget what you learn it, right? If you're not working with it, so that's the biggest problem. Bodan, you gotta keep doing. You gotta keep insisting, right? You gotta keep working on it. If you stop working on it, you're going to lose it. Rule 3.1. You stop, you lose it. So you can't stop. You have, okay, all cool. All right, thanks, Luca. Thanks, Christina. All right, so if you stop, you lose it, right? So don't stop, right? You got to be refreshing everything. All right, okay, awesome. So how do we refresh things, right? Okay, we're here loud and clear. Okay, I talk very loud, right? So maybe you have to turn down the volume a little. So basically, the way to do this is refresh your skills. So let me give a very simple example here. Very, very simple example. Most musicians, when they start practicing, right, what is that they do? The first thing they do in the practice, when they're going to play the piano, when they play guitar or play the piano, the first thing they do, they play a song that they're familiar with. A lot of them, they love this one they love, so they play that. When you play something that you're familiar with, what do? You activate the right neurons, right? You activate the neurons. You poof, your brain kind of flashes on the right neurons. And when your brain flashes on the right neurons, you activate them, right? And you activate them, you refresh the pathways. You refresh everything. So that's a good thing, right? So that's why we do code katas, for example. When you're going to start practicing, a easy way for you to do a little code kata. Refresh your brain. Refresh the fundamentals, right? That's why it's important for us to do code katas, right? Because then we refresh, refresh the for loops and refresh the language features, and we refresh, the collections, right? Because then it flashes our brain. We activate the right neurons. Don't forget, right? So that's an awesome way to do that, right? So do you know learn in public? What do you think? Mainly is explain what you're learning to others while you're studying, even if you're a complete beginner. That's awesome, David. That's very, very good. Why? Why this is very good, David? Because when you explain look, when you're reading something, when you're just learning and reading something or watching a video or watching a class, right? You are activating the neurons of watching. You're activating the neurons of reading. You're activating the neurons, a little bit of the neurons of the learning too, right? Of the doing, a little bit, but not much. Now, when you teach one something, the only way for you to teach something is that if you know how to do it, right? So when you're teaching something to someone, you are actually doing, so you are indeed activating the neurons of doing. So yes, David, it's very important. So there's a phrase I love to say, you think that you think when you think, but the truth is you only think when you speak. You only think when you share. You only think when you only think when you try to explain to someone else what you're doing, because then it helps you activate the right neurons. So that's an awesome way, David, to do that. Yes, I totally agree. Even if you're a complete beginner, right? You can teach others, complete beginners, to do that thing, right? Okay, so last question I can see here. I'm going to talk about mentoring in a minute, Hugo. I just want to mention two more things before I talk about mention. And I'm also going to talk about motivation. All right, so Nadia and Hugo, let me just kind of quickly go here. One more thing. So I don't have a lot of time. I have about 10 more minutes. So one thing that I would love to do is I'd love to give everyone a book. Before I go, I want to give everyone a book. Why I want to give everyone a book? So so if people can put my book there on the screen, that would be awesome. Why do I want to give you a book? Because there's two things that are going to happen, right? If you download my book, you're going to get my contacts, right? So you can talk to me. If there's any question that I didn't answer here, you can send them to me and later on, and I can answer over email. But the other thing is that I'm giving you a book that has the 4 steps for you to take action. So people that are asking about motivation, for example, this book is really going to help you with motivation, because it's going to show you the 4 steps that you need to take action, right? 4 steps for you to do things. Okay, so that's an awesome book. And actually, I'm going to also put here on the chat, right? Why they put this on the screen. I'm also going to put here on the chat the link for it. And all right, so if you can go here on the chat, or you can see on the screen as soon as they put there in the screen, and then we're going to see then you're going to be able to see the book. Maybe they're not going to be able to put it on the screen because I forgot to send the images for them earlier on, so I'm not sure if they're going to be able to do that. But if not, it's on the chat, right? You're going to have my book right there for you guys to download, right? Let me know if the links works, right? So, okay, so now let me talk a little briefly about a few things here, right? So we're talking about, we're talking about learning, right? And skills. So now you understand how to get the right skills. You understand how to learn the right way, right? Now, think about being better. How can you be better? For you to be better, right? What you have to do is you have to apply your efforts on the right skills, on the most important skills. If you apply apply your efforts, if you activate the neurons for the most important skills, that's how you get better, right? Should we read the whole book? Just the path. That's awesome, Sergey. That's why my book has just one paragraph. Really, right? My book is not about reading. It's about asking questions. I ask a lot of, so my book is all about doing, right? My book is going to ask you lots of questions for you, right? For you to improve your career, right? So that's my book has very, very little. It's a very short book. It's going to take you less than 10 minutes to read it. It's a very short book, but if you start answering the questions, right, you can use that book for months to get everything going for you in your life, right? So it's a very, very short book, and you're totally right, Sergey. The whole idea is not to read the book; it's actually do the things the book tells you to do, right? So that's the idea right there. Awesome question. All right. So for you to be better, you got to go after the right skills, right? The most important skills. So how do you know which one are the most important skills? Well, the most important skills are the ones that give you the results you want. Very, very important. You can't really acquire skills if you don't have a clear focus. What is that you want for your life? What is that you want for your career? What is it you want for your family? What is it you want in terms of money? If you don't know exactly what results you want to achieve, that's very, very hard for you to decide which are the most important skills for you to achieve those. Make sense? It's not about doing everything, guys. It's not about doing, learning everything. It's about deciding what are the most important results that you want. Once you know exactly what results you want, so I want a better job. I want I want some better thing. So hey, Chris is already here. So hi, Chris. Awesome that you're here. So you're talking next. So you guys got to stay here because Chris Richardson is going to give the next talk, and his talk is totally amazing. So that's awesome. All right. So it's really, really important that you know exactly. And there's one thing. A lot of people are afraid of focus, right? A lot of people are afraid of focus. Why they are afraid of focus? For one thing, it's very scary, right? It's what we call FOMO. FOMO. FOMO is the fear of missing out. The fear of missing out. So that fear, oh man, but if I focus in one thing, I'm going to miss out so many other things, right? So that's the fear of missing out. So instead of the fear of missing out, that's not what we're wanting. We want to have focus, right? Now, the most important thing, why people are afraid of having focus. They're afraid of having focus because they think that having focus is, oh, but Bruno, if I focus on Java, then I'm never going to learn Kotlin. And that's not focus. Java is a tool. right? So having focus in Java is like, you're asking someone to come fix your roof, and the guy says, oh yes, I'm gonna fix your roof because I'm an expert in hammers. You don't want to hire an expert in hammers to fix your roof. You want to hire an expert in roofs to fix your roof, right? So it's not about the tools, it's about the problem that you solve. So it's not about the tools, it's about the results you want. So you got to think about the results. All right? Okay, with that, I think that we never get I don't think we ever got the image for the book here on the stream, but at least you guys get it in the chat, right? I can actually put the link here on the board here while I'm answering the last two questions, right? How about this? I'm just gonna put the link here. So it's jav.mn, JavaMan, right? That's me. jav.mn / all in small letters, right? All small letters / best year. Okay? Right. So if you come here, jav.mn, JavaMan, that's me, right? / best year, that's where you're going to get the book. So I'm going to leave the link here while I answer the last two questions here so we can get all the questions answered. I really need to fix my roof. Okay, awesome. All right. So let me ask questions here. Someone at 5 minutes a day, right? 5 minutes a day. It's an awesome way for you to, 5 minutes a day is an awesome way for you to start doing anything, right? But Bruno, 5 minutes a day is not enough for me to do things. Yes, it is. 5 minutes a day, it's awesome for you to create a habit, right? The most important thing is you create a habit. Once you have the habit of doing your side project every day, once you have your habit of, of doing a code kata every day, once you have a habit of doing things every day, you're already, halfway there, right? Because the most hard thing is motivation, right? Motivation, that's what someone asked there. How can I have motivation? Motivation is not going to take you very far. Motivation is very, very energy consuming, right? So it's not about motivation. It's about doing every day. So doing 5 minutes a day helps you create the habit. Once you have a habit of doing something, then that's going to change your life by itself. All right? A great thing. Where can you find a coach? If you want to, you go send me a message and then we can talk about it, or come to the question and answer that we're going to have in 2 minutes, and then we can talk about where you can find a good mentor and coach. But let me tell you one thing, Hugo, in terms of mentor. Mentors are the best way for things. Why? Because mentor is going to force you. Mentor is going to challenge you. Mentor is going to help you barriers more, then you can faster achieve what you want. So that's an awesome way. And you can have mentors by reading a book. Let's say you're gonna, Chris Richards is gonna come here, right? You can say, okay, let me read Chris' books, and I'm gonna follow what Chris is saying. I'm gonna do what Chris is saying. So that's a way for you to have a mentor. Come here, ask questions on events, talk to people online. That's awesome, great ways to get mentors. A lot of interviews ask theoretical questions, also ask topics which do not exist and will exist in their projects. I'm interviewed too. Should I learn such topics just for an interview, or should just skip such companies? So Dimitri, let me tell you, you have to know enough about what's going on to understand the process, right? So that's important. It's important that you have a general understanding what's going on. But you, Dimitri, have to have a focus. So go after the companies that focus on the problems that you want to focus. So remember, focus is about the problem that you solve. Once you know what problem you solve, then you can go after companies that want that problem solving. That's how you go after the best companies. All right. So Yuri said, amazing speak. Thanks a lot, Yuri. The best speak for a long time. So if you like this speech, if you like the talk, go vote for it, right? So they invite me again so we can have more time together. So that's awesome. Okay, so go vote for it. A lot of positive energy, was awesome. Thanks a lot. Thanks, everyone. All right, so don't forget to vote on talk. That's all I'm talking about. Focus on something takes me 30 minutes to get concentrated. So let's talk more about this in the question and answer. I think that's going to be better. Download my Best Year, because that book is going to help you focus even faster than 30 minutes. All right, so that's by 40. That's the end of my talk. So thanks everyone. Thanks Oleg for the invitation. Thanks everyone for being here. And I'm going to go to the question and answers right after this. Thank you.
Thank you, Bruno. Thank you so much for this energetic talk. We are very excited here after your talk. And dear participants, the link to the book is published in the chat, and we will publish it once again now. So yeah, go download it and follow the Bruno's advices. Yeah, thank you so much, and please join the Q&A Zoom room and have more discussions and more questions to Bruno. Thank you.
Thanks,
Thank
everyone.
You so much.
It was awesome. Thanks for the opportunity, and thanks for running this awesome event that you guys are doing. Keep doing it. Thanks a lot.
Thank you. Thank you. See you next year. Yeah, dear participants, and in a minute we will have a presentation from our platinum partner, EPAM company. Yeah, hello. Hello, Yulia.
You grow. You grow when you have a desire to become better, to learn new things. When you listen to a webinar, a conference, a talk, go to courses, dozens of courses, then you are the one who speaks. You grow. You grow when you get up to speed, when you focus on your work, on your customer, on your team. Then you become a part of something big. When you raise the bar and take responsibility for your work, whether good or bad, when they ask you for advice, when you create a small revolution or speed up an evolution, then you grow. You are growing because growing matters to you. You keep at it until it's just right, to be honest with yourself and others, to further educate yourself, to become an expert. And if it matters to you, it matters to us. APAM, focus on your growth.
Yeah. I'm glad to welcome the representative from EPAM, Yulia Trisko, Associate Learning and Development Specialist at EPAM. Yulia, what presentation do you have for us today?
Hello everyone, my name is Julia and I'm the project coordinator of Master's Degree Program in Software Engineering at EPAM, and today I'm excited to present the educational opportunities we offer on the Master's Degree Program. So this is a unique educational product for experienced IT professionals who would like to succeed in their careers. And the presentation will cover the key points about Master's Degree Program in Software Engineering, its advantages and the reason why we are the best in what we are doing, the skills and qualification you must have to start on the program, and the ways to apply to the program. So our Master's Degree Program in Software Engineering is designed for senior level engineers and includes 2 years of training. Our students have 2 options of participation in the program. You can study on the program independently or in a partnership with 2 major Ukrainian universities, Kyiv-Mogilyansk Academy and State University of Telecommunications. After completing the program, you will get a master's degree diploma of higher education. Master's degree program offers 120 learning credits, more than 400 face-to-face workshops, 80 hours of online webinars, 5 compulsory and 1 elective modules, more than 100 experts, mentors, speakers, coaches, among the most experienced IT professionals from all over the world. More than 15 years of EPAM's experience in education and 27 years in software development. The program includes the following modules: Engineering Excellence, Solution Architect, Core and Advanced, Delivery Management, Big Data, DevOps and Cloud. And now, I would like to move on to the advantages of the program. I would like to highlight the curriculum driven by business needs, combined online-offline activities, blended format which includes self-study and working shoulder to shoulder with the mentors and your colleagues on webinars and workshops. Integration with the best educational practices in the world, best lecturers from business and science. And for 2 years, our program has been providing trainings for IT specialists forming IT professional community which connects best engineers from all over the world. You have the opportunity to develop your professional network, which also affects your professional career. Your mentors are the practitioners who can advise you on your career and will share their expertise. The participants of the first year have already stepped up their professional careers and received offers from the world's leading companies. At the moment, our program has 2 streams of students, and now we are recruiting the 3rd class stream. Today, there are no similar programs to build a career in solution architecture and delivery management. And the most important skills you need to succeed are 3 years plus of experience in IT development, working with one of the programming languages, Java, JavaScript, .NET, and others, basic business toolkit, English level B2 plus, soft skills like leadership, efficient business, customer-focused communication. And now let's watch a short introduction video about our program.
We training tens of thousands of people per year, and this year we also decided to bring some of the program externally. We're running graduated master program for software engineering.
It is a great honor and big responsibility to be the first, and we are working 24/7 for the result.
The next start date of Master's Degree Program in Software Engineering is September 1st, 2021. Please send your applications now and you will be contacted right away by our representative. You'll be advised the next steps and get the answers to all your questions. The estimated deadline is May 1st, 2021. Here you see the QR code to the program page. Please scan the QR code and register. Also, you can find the link to the MSDP page on your participant account of the conference. Throughout the program, we have received thousands of applications, but only the best candidates who have been qualified according to their professional level got the opportunity to study. Don't miss your chance to change your future, get new opportunities, and improve your career. Get unique knowledge from top managers and experienced leaders. Hurry up and register and get your seat on the program. The link to our program is also in chat. So learn, grow, be excellent with Master's Degree Program in Software Engineering at EPAM. So thank you for your attention.
Thank you, Yulia, for this presentation. Thank you for this exciting master degree program. It's really cool and interesting for growing their future architectures and engineering elite, as your video says. So thank you once again to EPAM for such a program. And dear participants, just will remind you that you can find the link to application form to this master degree program at the personal page under the EPAM section. Yeah, and just in a few minutes, we will start our last keynote of the Devoxx Ukraine from Chris Richardson. So stay with us and enjoy the last talk at Devoxx Ukraine. Okay, dear participants, welcome back, and I'm glad to invite to our virtual stage the last keynote speaker, Java champion, Java 1 rock star, Chris Richardson, connecting from sunny California.
And yeah, so it's a beautiful sunny day, and they just announced the results of the election, so I'm super happy. So yeah,
Good
great
morning.
to be here.
Good
Hi.
morning, Chris. Yeah, sorry for interrupting. You can start your talk now, so please, the mic is yours.
Okay, great. Yeah, so yeah, welcome to my talk on architecting for rapid, frequent, reliable, and sustainable software delivery. So in the talk, I'm going to explain why that's important. I'm going to explain what it means. I'm also going to explain what it means for us as software architects. Do we architect differently? Then I'm going to talk about the role that microservices, or specifically the microservice architecture, plays, and why it makes sense to use it sometimes. So before I talk about that, a little bit about me. I've been developing software for a long time. First job was like back in the mid 80s, building Lisp systems. Then over the years, ended up in Java, wrote the book Pojos in Action, created the original Cloud Foundry, which then got acquired by SpringSource. That's where the name of the current Cloud Foundry comes from. And then for the past 7 years, I've been pretty much focused on the microservice architecture, working with organizations around the world through consulting and training, to help them adopt microservices. I wrote the book Microservices Patterns. I have a startup called Eventuate, and also doing training and so on online in the age of COVID. And yeah, if you want to get discounts to either my book or my online training classes, please use these coupons, and you can go to adoptmicroservices.io. So, that's me. I basically spend my time doing microservices. So talk agenda is as follows. I'm going to begin by dissecting the phrase architecting for rapid, frequent, reliable, and sustainable delivery of software. Going to break that down, explain what it means, explain why it's important, and explain its impact on architecture. Then I'm going to look at two different architectural styles, namely the monolithic architecture, and why that is a perfectly good choice for many applications. Then I'm going to talk about the microservice architecture and explain why that's a good choice for some applications, not a good choice for others. And then I'm going to finish up by talking about a key microservice architecture topic, loose coupling. And as you're going to see, the concept of loose coupling is kind of plays a major role throughout this talk. So let's get going. So I'm going to first talk about this word architecting. So obviously that's about software architecture. And then, well, what is that? Well, this is kind of my favorite classic definition of architecture. It's a set of structures that you need to reason about a system. And it consists of software elements, right? The relationships between those software elements, and then the properties of those elements and the properties of those relations or relationships, which is a pretty abstract kind of description, right? And you could sort of boil it down into architecture as really three things, right? Elements, relations between them, and properties, which, ultimately is a bunch of boxes and lines, but there's sort of key concepts there. And one really important idea about architecture is that it's multidimensional. So if you think about a building, right, it could be, say, a house or a high-rise building, there's actually many different facets to the architecture. So there's the structural aspects. If it's a high-rise, that's the concrete and steel. So there's a whole group of engineers who look at it from that perspective. But then there's the electrical architecture, the plumbing, the mechanical, so on and so forth. So there's actually all these different perspectives that you can have on architecture. And each one of those perspectives is kind of a view, which itself is really a collection of elements, relations, and properties. And what those specific elements are and the specific relations depends very much on your perspective. So let's make this concrete. So, let's say we're all Java developers, right? So what does that mean? So it means that what we do is create Java classes, organize them into packages. And so from an architectural point of view, what matters there are the elements are the classes, the packages, the relationships are the arrangement of classes into those packages, and then also the dependencies between those packages. So that's sort of what I'm going to call the logical view of architecture. So that's good, and we can focus on that, and it's quite important. But then there's the deployment view of architecture, which actually is all concerned with taking our classes and packages and turning them into code, into something that is running in production. And there's a couple of concepts there. You have modules, which in Java would be jar files. And then there are components, which are a collection of modules that are executable, deployable units. And so there's this issue, it's like, what is the nature of that architecture, the deployment architecture, which actually includes the deployment pipeline, the automated process that takes our code, builds it, tests it, and then finally deploys it into production. And when we talk about monolithic architectures and microservice architectures, we're really looking at mostly the deployment side of it, which actually leaks back into how we do development. But that's sort of kind of a quick introduction to the sort of concepts of software architecture and how there are multiple perspectives or views on the architecture of the system. So why does this architecture thing matters? Well, if you break down the requirements for an application, it's basically two categories. There are the functional requirements, the stories, the use cases, which, that's all sorts of business logic, right? And then there are the non-functional requirements or ilities or quality attributes, which are things like scalability, security, reliability. And then, some of those are sort of kind of runtime things, but then there's kind of development time things like maintainability, testability, and deployability. Now, it turns out that you can basically implement a given set of functional requirements with almost any architecture. I mean, that's not entirely true, but it's like to just implement some business logic. Doesn't matter what architecture you have, but architecture the architecture of the system determines how well it actually meets its quality attributes. It determines how scalable it is, how reliable it is, and so on. So, so architecture is how we achieve the necessary quality attributes. So that comes back to the word architecting, right? Which is the process of defining the application's architecture in order to satisfy those desired quality attributes. And that's obviously something we do at the beginning of an application's lifetime. But it turns out that, over time, the ilities of the application, those non-functional requirements change, right? You might go from just having a few users to, say, in the case of Facebook, having 1 billion users. The application and the team that's developing it typically grows over time. So all of sort of the non-functional attributes of the application evolve, change, and you actually have to occasionally re-architect. You can actually outgrow your existing architecture, and you have to adapt a new one. So, who is doing this? Well, that's the job of the architect, right? Which is like a coveted job description. And so if you're an architect, your job is to define an architecture that meets the required quality attributes. But what I find with a lot of organizations is that the business only cares about the user visible feature or the user visible aspects of the software, features, and then some user visible quality attributes like scalability, performance, and reliability. There's a whole set of quality attributes that are often ignored, particularly ones that impact development, which is really the context of this talk. And architects often don't actually spend too much time doing architecture. They're typically designing big new features. And so what that means is that the quality attributes that aren't visible to the customer are usually neglected. And that's where organizations get into trouble. And let's kind of look at some of those sort of more development time quality attributes. So the next thing I want to talk about is what is really meant by rapid, frequent, and reliable software delivery. Why is this relevant? And what does that actually mean for the quality attributes of the application? So back in 2011, Mark Andreessen coined the phrase "software is eating the world." What that actually means, what he meant by that is increasingly products and services are powered by software. So it doesn't matter what business you're in, software is playing an increasingly important role. Whether that's, and it doesn't, obviously banking, which is a very sort of, that's very tech oriented to begin with. But even in businesses that are very much in the physical world, like let's just say an airline, right, or a mining company, software is increasingly important to the business. So that's one key thing. It's a key trend is software is becoming really important. And also, the world in which we operate, we live, and more specifically, the marketplaces within which businesses operate are just sort of increasingly unpredictable. There's this phrase, volatile, uncertain, complex, and ambiguous. And, and a sort of more, common example of that is competitors coming out of nowhere. Deregulation of banking allows for, banks that results in banks that are hundreds of years old facing tech startups that are 2 years old, and that they risk losing market share, for example. And then COVID, who would have known, thought if you go back a year, who would have thought that we would have spent a big chunk of 2020 sheltered away and afraid for our lives most of the time, right? That's almost been the ultimate disruptor. If you look at, say, online grocery deliveries in the US, they've jumped forward 5 years as a result of COVID. So, it's just, who knows what's going to happen, which is kind of exciting and scary all at the same time. But, what does that mean? Well, it means that businesses must be nimble, agile, and be able to innovate faster, right? You can imagine COVID comes along, online grocery delivery, and suddenly the demand jumps forward 5 years in a matter of weeks, and businesses have to be able to quickly respond to those kinds of changes. And that's actually happened, I think, across multiple industries. Sort of online has suddenly taken a much more important role. And guess what? Well, that means for us in IT, we need to be able to deliver software much more rapidly, frequently, and reliably, so that we can, so that our businesses can compete much more effectively. So a good definition, a good sort of quantification of rapid, frequent, and reliable software delivery is captured by these 4 metrics, which come from this most excellent must-read book called Accelerate. And there's 2 metrics that are concerned with velocity. Those are lead time. That's the time from a developer committing a change, doing a git commit and a git push, to that change being deployed into production. You want that's a key development metric, and you want that to be as short as possible. There's also the deployment frequency. How many deploys into production are you doing per day? So those are measuring your velocity. Then there's also some reliability metrics as well. So first one is change failure rate. What percentage of deployments cause an outage? Obviously, that needs to be really low. And then if there is some kind of outage, how quickly can you recover from it? And once again, that you should be able to recover extremely quickly. So, the Accelerate authors do this DevOps survey, and they find that high-performing organizations, developing software at a much faster rate, but at the same time doing it much more reliably. So they're pushing changes into production many times a day, and then the lead time is under an hour. And there's a crazy statistic about Amazon.com, who I think are doing at one point were doing 130,000 deploys per day, which was like one deploy every 0.6 seconds. So you have massive organization, but a good goal would be each developer commits every day, and that change gets pushed into production. And then these organizations are doing it in a much more reliable way as well. So it's sort of counterintuitive. You think, oh my God, this must be reliable, so we must do it really carefully and slowly and infrequently. And it turns out that it's backwards. If you want to deliver software reliably, then you should be just delivering a constant stream of small incremental updates to your production environment. And of course, it's flowing through an automated deployment pipeline that thoroughly tests it. But that's how you achieve success. And there's a strong correlation between how well you can deliver software and the performance of your business, which is another key finding by the authors of Accelerate. So how do we do this? Well, you have to use what I call the success triangle. In other words, it's a combination of three things. You need to have the right process, which is really DevOps, which embraces continuous delivery and development. And that's really defined by the DevOps handbook. Right? It's a set of principles and practices for delivering software rapidly, frequently, and reliably. You also need to have the right organizational structure, which is a network of small, as in let's just say 5 to 9 people, cross-functional, loosely coupled teams that are empowered to basically take requirements, possibly seek out requirements, and turn them into deployed code, or code that is running in production. So you need the right process, the right organization, and then you need the architecture that supports both of those things, that enables DevOps and enables the teams to be loosely coupled. So the Accelerate book had some super interesting findings about what it's sort of like to work in a high-performing organization. So, one point is that team members can complete their work without having to constantly meet with people from other teams. Interestingly, I've been to so many companies around the world, and one constant is there is never enough meeting rooms. And I would argue that that's probably because the way they're organized is that they're constantly having to coordinate and with one another, and it's very inefficient. But in high-performing organizations, it's almost like your daily stand-up and just informal conversations with your team members is sort of the primary communication mechanism. Another key finding is they can make large-scale changes to the design of the system without making other teams do a bunch of work for them, or without forcing other teams to do a bunch of work. Then the third point is they can do testing locally. So you sit on your laptop and you make changes and you test it, and at that point you can be confident that it's ready to go. Obviously, it goes through a deployment pipeline, but you can test effectively locally. And then finally, they find that you can deploy the application. A team can deploy their service without having to coordinate that deployment with other teams. So very different from sort of standard organizations. But this actually has implications for architecture. It actually means that you have to have a loosely coupled architecture. If you want to have a loosely coupled organization, you have to have a according to Conway's law, you need a loosely coupled architecture. The fact that you can make changes without impacting other people, that actually implies that you have a modular architecture. The fact that you can test locally implies that you have a testable architecture. And then the fact that you can deploy independently implies that you've got this architecture that are called deployable. So, once again, here's some key requirements that the architecture needs to satisfy. So that's for rapid, frequent, reliable delivery. Now let's look at what I mean by sustainable delivery, why that's important and what that implies for the architecture as well. So, if you're successful, applications and a successful application will live for decades, 10, 20 years even. But at the same time, the technology that you use to develop software changes, right? Technologies come and go, or even versions of technologies come and go, right? At any point in time, you look in the marketplace, there's a set of technologies that are important, and that slowly changes over time. Now, Java, 25 years old, right? So it's still important. That's a good thing. But which version of Java is important has changed throughout those years, right? And from a technology management point of view, you want to ensure that the importance of a technology inside your organization, the level of reliance that you have on it, is aligned with the importance of the technology in the marketplace, right? In other words, if you're relying on a technology that is no longer important, out of date, obsolete, you have a problem that represents some kind of technical debt. And so what that means is for these long-lived applications, we need to be able to incrementally upgrade the technology stack. Obviously, you can always do a complete rewrite, but those are actually incredibly expensive and risky. So you want to be able to incrementally switch out the technology that you're using in your application in order for it to have a long, healthy, sustainable life. And this is actually another form of modularity, right? Where, in a sense, normally we think about modularity as where the API encapsulates various design decisions. Well, here I'm sort of expanding that definition of modularity to include the API in encapsulating the technology choices that you've made in your application. And you could imagine that there's very few ways to achieve that. One obvious way, of course, is you hide something behind a REST API, right? And then doesn't matter what's behind it. And that kind of, to me, is like, this is hinting at the importance of the microservice architecture. But I'll get to that in a minute. So put all of this together, right? You need an architecture that's loosely coupled and modular, both in the regular way and also sort of in this way that encapsulates technology. And you could also call that evolvability or evolvable as well. Plus there's a requirement around testability and deployability as well. So that's the architecture that we need for rapid, frequent, reliable delivery of software. So let's look at a couple of choices, right? If you were to go on Twitter today and say, ask a question, what architecture should I have for my application? You'd get answers like the monolith, microservices are a total mistake. And then there are other people that are going, well, microservices are the way to go. It's the future, right? And so, there's been some great tweets about very polarized discussions and some great tweets either way about that. But as you could imagine, I mean, from my perspective, the answer is very much, it depends. Depends very much, what on sort of fundamentally the size of your application. So let's look at the monolithic architecture, right? So that's an architectural style that structures an application as a single executable or deployable component, which in other words, what's getting deployed into production is either in a Java sense, a WAR file, or it's an executable jar, right? I mean, those are the common ones. And you can imagine at the start of the application, you just, make a directory, CD into it, and then you start typing away, right? And literally, I mean, I've worked at startups where pretty much that's how development began, right? So, an example application would sort of look like this, right? Bunch of very sort of modular packages and that get turned into modules, modular layered architecture. That all gets packaged up into a WAR file or an executable jar or something, and then it's talking to the database. So, and then there's a browser. The application's either generating HTML or it has a REST API or something like that, right? So anyway, that's sort of a typical monolithic architecture. And this is a perfectly good choice for a lot of applications, right? Because if you have, especially when they are small, because a small application is highly testable. You can test it locally on your laptop. The amount of time it takes to test is relatively short, right? Deploying means just pushing it into production. That's pretty straightforward. It tends to be easy to maintain, right? The code base is kind of small. And then if you design your package structure correctly, it's modular. And it's kind of sort of evolvable in the sense that, well, yeah, you can swap out the technology stack by doing a complete rewrite, but if the application is small, that's not impossible. But the problem that you have is, that's tiny application that maybe it had started off in life as a single, one directory. You just started with make dir, and you've got half a dozen developers. If you're successful, you're likely to end up over time with a large application, right? Many millions of lines of code. I've worked with clients that have had applications where the WAR file itself is measured in gigabytes, right? And then the number of developers you have working on it is measured in the hundreds or thousands. That's the sign of success. But once you get into, once your application reaches that scale, you have a whole bunch of issues, right? Even just committing changes into a single source code repository when you have a lot of developers is problematic, right? There's a contention for actually doing commits. Obviously you can no longer do teams can't deploy their work independently. Because everything is packaged together with every other team's module, and they all have to deploy together. If you've got a very large application, in order to reduce the execution time of the deployment pipeline, it needs to be parallelized. It needs to be running on a cluster of machines. So you've got this complex infrastructure for doing builds. And then ultimately, you run the risk that the actual act of updating production, which ends up, I feel like, can't really be parallelized, ends up being a bottleneck. So the rate of change, I think, ultimately will kind of just bottleneck at some point. Now, you could have a more complex architecture where you split it up into, each team has their own repository, and that actually parallelizes the build, and each build pipeline spits out a compiled module that then feeds into the application level deployment pipeline. but you still risk having a bottleneck there. So there's sort of some inherent issues around scalability at this point, sort of from a development perspective at this point. So you sort of end up with this graph where over time the size and the complexity of your application grows, but then sort of the kind of the desirable development time at soft quality attributes gets worse and worse over time, right? Testing is likely to take longer, deployment takes longer, so the sort of the rate of change kind of just plateaus. And this is a problem for the business, right? Because you really need to be going faster and faster, and there's a real risk of disruption as well. So you can kind of mitigate some of the problems of having a large monolith by throwing a bunch of technology off at it, but ultimately I think it's quite difficult to do at large scale. Plus, there's this huge problem where many of the technology choices in your application are global, right? It's basically, ultimately, you've got, say, a giant executable jar file. Well, you have committed to using the same version of Java. Well, first off, you're committed to using Java. You're committed to using the same version of Java. And unless you start getting into the complexities of the Java module system, for the most part, you can only use a single version of any given library, third-party library. And so that actually makes it extremely difficult to make changes, to sort of to change your technology stack. And you basically end up being locked into the original technology choices that you made. And I think there's a lot of organizations who are sort of stuck in this situation. So, you end up in what I call monolithic hell. I mean, it's not inevitable, but there's a very high risk of that. So what can you do about it? Well, of course, obviously the alternative architecture is the microservice architecture. So that's an architectural style that basically structures an application as a collection of services or components, right? So instead of effectively a single executable, a single deployable, you have many of them or multiple executables and deployables. And each one of them is highly maintainable, testable, has a minimal lead time. Each one is independently deployable by definition. And they're obviously loose, they need to be loosely coupled. And then the last point is super important. Each service is owned by a small team. So if we were to look at the food to go application, it would consist of multiple services. Each one of them has its own database. They're communicating via a message broker. You can sort of functionally break up the web application into multiple web apps as well, each one implementing a particular part of the UI. You'd have an API gateway in front of it, exposing APIs to the outside world, right? So, instead of one thing, this architecture is broken down into a bunch of services, which actually hints at the complexity, right? Like there's a bunch, in the deployment perspective, there's many more moving parts, many more boxes and lines. So, what is a service? The whole point of a service is to expose an API. In a sense, the whole purpose of a team is basically to expose an API. The API implements operations, right? Things that clients can invoke. There's two types of operations: commands that mutate data, create order, cancel order. There's queries that retrieve data, like find order history. And these operations can be invoked either synchronously, which is sort of how we normally expect it, but importantly, they can be invoked asynchronously as well. Services also expose events, typically like order created, order canceled. So when key changes occur in the service, it's common for it to publish events. And then services can invoke operations implemented by other services and consume events emitted by other services. And the service also has its own database as well. And I'll talk about that in a little while. But the idea, though, is that the service database is an implementation detail of the service. Services typically implement business concepts. So a service implements a subdomain, or if you're familiar with DDD, or it would implement a business capability, which is a term from business architecture. So there would be order management, delivery management, accounting, so on and so forth. And another key issue is sort of like what's the granularity of services? And what's the size of a service as well? So given that the primary goal is to enable a team to be autonomous, so needs to be a loosely coupled architecture to support loosely coupled teams. Ideally, you just want to have one service per team, as few as possible. And also, given that the team is should be small, 5 to 9 people is a good size. That actually imposes an upper bound on the size of the size and complexity of the service as well. So that's sort of a rough sense. And interestingly, a bunch of organizations I visited, they actually tend to have like a service per developer, which arguably is far too fine-grained. It's just too much complexity for insufficient benefit. Having said that, it can be useful, it can be useful to split a service if it solves a tangible problem, right? So imagine, over time the service grows and the team grows. Well, that would be a reason to split the service and split the team to keep the team the right size. If the deployment pipeline takes too long, well, you could split the service into 2 that can be developed and tested independently. Obviously, there's very little not so much benefit in splitting a service into 2, which then constantly are having to change in lockstep, right? That's a sign of tight coupling between those services. You might need to split to support polyglot development. So imagine your data analytics team has produced a fraud detection algorithm in Python and machine learning model, right? But the rest of you're using Java. That would be a reason to have a Python service. You might want to split for fault tolerance, like high parts of the application that need to be highly available, like the critical path for processing credit card authorizations might be separated from merchant account management, for example. So if I'm working on merchant account management, well, I don't want to impact the credit card authorization logic. You might also want to split for regulatory requirements as well, where if you have part of your application is subject to strict regulatory requirements like PCI or some sort of health care related requirements, well, you could split those off so that the development of the rest of the application is not impacted by those fairly burdensome regulations. So a whole bunch of kind of issues that can drive introducing more services, but you should only have services should exist for a good reason, not just because. So a bunch of benefits to this, right? It improves maintainability. I think each service is small and fits in the head of the developers who are working on it, unlike a massive monolith, right? Each service is small and easier to test and faster to test, so it improves testability. You can change each service's technology stack independently, and I'll talk about that in a minute. Each service, by definition, can be deployed independently, which means the teams don't have to coordinate. It can improve scaling as well, and it can improve availability and fault tolerance as well. If there's a failure in one service, it doesn't necessarily impact other services. But by far the biggest benefit of the microservice architecture is that it enables DevOps, it provides the testability and deployability that DevOps needs, and it provides the loose coupling that's vital to enable the teams to be loosely coupled as well. So you end up with a situation like this where each team is committing changes to their services code repository. There's an automated deployment type pipeline that's building and testing the service, and they're all working independently most of the time, unless they have to coordinate their work to agree on API definitions. But most of the time, these teams are working independently. And then I think a huge benefit, which is important for these long-lived applications, is that you can experiment safely with new technologies and incrementally evolve the technology stack, right? So imagine that you get all excited about Golang, right? You could go implement a service in Golang, even though the rest of your services are implemented in Java. You can safely experiment with that. But then, and if you like it, that's great, that experiment has succeeded and you've now figured out that there's a new technology that you wish to incorporate into your architecture. But on the other hand, you want to use, say, a more 21st century language. You might decide, well, yeah, we want to use Kotlin instead of Golang, right? And that's okay. You haven't invested much time in experimenting with Golang. And at some point, you could, when you're going to make major changes to that service, you could rewrite it completely in Kotlin, for example. So it lets you experiment and incrementally evolve your technology stack. And obviously, these services, even the Java-based services, they don't have to use the same version of Java, right? Each one can evolve at its own pace. They don't have to use the same versions of third-party libraries. So you avoid all of the issues that you can get into with a monolith, which basically requires you to use a single technology stack that cannot be evolved incrementally. But there are some significant drawbacks of this architecture. You're building a distributed system, so you've got all the complexity of distributed system development, inter-process communication, for example, right? Complexity around testing. On the one hand, testing individual services is easier, but testing that they work together involves adopting some new techniques like consumer-driven contract testing. And then from a deployment perspective, there's many more moving parts in production that need to be orchestrated and monitored and managed and so on. So it's sort of like kind of the sort of like for small applications, you should stick with a monolith. But once your application grows, the benefits start to outweigh this complexity. And then, there are some issues as well, like correctly identifying service boundaries. I mean, that's an interesting challenge. There's no mechanical process for that. Yet at the same time, figuring out what your service boundaries are is the most important decision that you can make. Choices around technology are very secondary. And then if you have a monolith, refactoring that into a microservice architecture can be painful and time consuming. So it's they're not easy to adopt. But on the other hand, if you've got a massive monolith, you're most likely in a world of pain anyway, and you have to embark on this refactoring effort. So it boils down to, if you're developing a large, complex application and you need to deliver it rapidly, frequently, reliably, and sustainably, the microservice architecture is a good choice. But if not all of these things are true, then probably the monolithic architecture is a better choice. Okay, so I want to finish up by, that's sort of a discussion of the two architectural patterns and why they're relevant and when you should choose one over the other. I want to finish up by talking about architecting loosely coupled services, because this is key sort of requirement that often people get wrong. In fact, I mean, there's one blog post or one company, they built a tightly coupled set of services, and it was even worse than having a monolith. And they actually had to rewrite it back into a monolith, though they did get a conference talk out of it. So, but they sort of fundamentally, they ignored this point. So this all goes back to Conway's law, which is fantastic, right? I've been hearing of Conway's law for decades, and it turns out that he's on Twitter, which is so awesome. So basically what he said, paraphrasing, is that the organizational structure, or specifically the communication patterns in the organizational structure, who talks to who or who reports to who, mirrors the software architecture. And what that, and vice versa. And what that actually means, that if you want to have loosely coupled teams, you got to have a loosely coupled architecture. And there's actually, which is interesting, right? So services almost often have to collaborate. So in my example, when in order to verify that an order can be created, the order service has to reserve credit, which requires checking with the customer service. So collaboration is, inevitable, which introduces a certain amount of coupling, but you want to do it in a way such that they are loosely coupled. Turns out that there's two types of coupling, at least two types. One is runtime coupling, which is where one service cannot respond to a request until the other service responds to it. And I'll talk about that in a minute. And then there's design time coupling, which is where at development time, when you change one service, you kind of have to change another service in lockstep. And a key thing to remember is, just because you have microservices, you are not guaranteed to have a loosely coupled architecture. You have independent deployment, which sort of feels like loose coupling, but you have to design your services to be loosely coupled. And loose and tight coupling is a problem because it requires coordination between the teams, meetings to discuss API changes, which slows down development. People at ThoughtWorks have found that decision-making across teams is 10 times slower than decision-making within teams, and it can slow down development. In the worst case, you can end up with what's known as a distributed monolith, which is where multiple services are frequently changing in lockstep. So it's really important to prevent tight design time coupling. So there's a few things that you can do. So one is, this is an old concept of you apply the dry principle. Don't repeat yourself. So in other words, every concept should be represented in one place, and you translate that into the microservice. Every concept should be represented in just one service. If you have the implementation of a concept scattered across multiple services, whenever that concept, think business rule, changes, then all of those services have to change in lockstep. So that is a bad thing. A change should ideally only impact one service. You also want to design your services to look like icebergs. The saying goes that the visible part of an iceberg above the water is much smaller than what lies below. So you want to have services with relatively small APIs that are stable, that can encapsulate a much larger implementation, because what's hidden can be changed, right? And what's exposed in the API is much harder to change, because you're, if an API, worst case, if an API changes incompatibly, then that requires all of the clients of that API to be updated, which is, painful. So you want to design services with thin APIs that hide a lot of complexity. Great example of that is, say, like Twilio messaging, right? Like you want to send an SMS. It's like, well, it's roughly send message this from this number to this number, and here's the message, right? Incredibly simple API that encapsulates a massive amount of complexity. So, it's a key principle. You want to avoid having putting business logic in shared libraries, because whenever that business logic changes, all of the services that use that library have to be updated, requires them to change in lockstep. Now, if you do this, this could lead to a conference talk, as did the company I mentioned, but it's best avoided. Now, you also want to avoid sharing of database tables. Database schemas are implementation details, right? And so, if you give access to if you let other teams access your database, changing it is no longer straightforward. So it's best avoided. You should really encapsulate the database. So that's design time coupling, and a set of principles that can ensure that your services are loosely coupled and reduce the amount of coordination that's required amongst the teams. Now, I want to mention loose runtime coupling as well, even though that's it's sort of related, but it's quite different. But this is another common anti-pattern that I've seen when I've worked with various organizations. So if you think about, let's think about, well, we got a bunch of services. How are they going to communicate? And it's like, yes, well, they just use REST, right? So imagine like the order service handles a post request that creates an order by doing a put request to the customer service to reserve credit. Looks super simple, right? And then the response comes back. That enables the order service to create the order, and then it sends back a response to its client. Superficially, very simple, right? It's mirroring the communication pattern inside a monolithic architecture, but you've just designed a system where the availability of the create order operation depends on both of those services being available at the same time, right? Both being up and both being able to respond have a response time that's within their SLA. And so its availability is really the product of the availability of those two services. Now, in this simple case, maybe it can work. I mean, there's some actually other interesting design issues that you get into, but you've reduced the availability of your system. So it's sort of like this distribution is free anti-pattern. And I remember one time I visited a client. They had this critical API endpoint that was integrating with a third party, and there was really strict SLA requirements, right? Like around availability and around response time. And by the time I talked with all of the teams that were involved in implementing the services that were invoked, became apparent that like 10 plus services were being invoked, which, so they were risking, not meeting their SLA because if any one of those services was down, right, they couldn't respond. Or if any one of those services was exhibiting extremely high latency, they could not respond either. So it represented a major risk to the business. So you should be very wary of long chains of synchronous communication. So there's a really key concept, which is this idea of a self-contained service, which is a service that can handle a request without waiting for a response from another service, right? So the order customer example I had earlier, the order service was not self-contained, right? Because it had to interact with the customer service. So so it didn't fit this pattern. So one way of making it fit this pattern is to actually merge together the order service and customer services, right? That improves the availability of this critical operation, right? So that's good. But at the downside is that the team is much larger. Now, depends on the situation, this might be a worthwhile trade-off, or it might not. So, once again, it depends, right? But quite often, you can't, if you followed that path, you'd basically end up with a monolith. And we've agreed that in this situation, we want to use services, right? So you can adjust service boundaries, but ultimately you might have to have some kind of communication. And for there, it's actually best to have asynchronous communication. I highly recommend this book, Enterprise Integration Patterns. It's a great pattern language. So one way of implementing the order service using asynchronous communication that gives you high availability is as follows. So the post-order request kind of basically initiates the process of creating an order, and the order service responds immediately. And in the meantime, a bunch of events are exchanged. So the order service says, I've created this order. That event gets consumed by the customer service, which reserves credit, sends back an event to the order service, which can then change the status of the order to rejected or approved. And this specifically is a choreography-based saga. This is more available, right? The order service can respond to a create request without waiting for any other services. But you've got the downside is you've got the complexity of sagas. And another interesting thing is that it changes the meaning of the API. The response that comes back first cannot say whether the order was accepted or rejected based on whether there's credit available or not. So the client has to check back later to see whether its order has been approved or not, or maybe it could consume events somehow. So there's some super interesting trade-offs with this, right? But this is a very useful pattern to use. The other pattern that you could use, which I call, is command query responsibility segregation, which is basically a complicated way of saying, well, we're going to replicate data to the order service. Specifically, what happens in this design is the credit limit is replicated to the order service, and the order service is made responsible for tracking available credit. That responsibility has been taken away from the customer service. So that actually gives the order service the data that it needs in order to decide whether there's credit available. And we've made it self-contained, right? So it's more available, but the response does contain the outcome of the operation, but you've got the cost and the complexity of replicating data. So you sort of got these different sort of trade-offs, right? Between you can merge services together, right? Which means merging teams, which is problematic, but maybe a good idea sometimes. Or you keep them separate, and you either use sagas to maintain sort of data consistency across these services, or make them self-contained, or you can use replication. And each one of these approaches sort of has different trade-offs. Now, like for instance, you could replicate the credit limit to multiple services. That's okay, but only one service can be responsible for managing the available credit. So if there were multiple services that needed to maintain available credit, that would not work, and you'd have to keep that back in the customer service and use sagas. So anyway, so that's sort of it. So in summary, right, couple more slides. So there's some trends that are requiring IT to deliver software rapidly, frequently, and reliably, right? The fact that software is powering businesses, and the world, the marketplaces are unpredictable. You have to embrace DevOps. You have to embrace a network of loosely coupled teams as your organizational structure. And then another key trend is that software lives for a long time, so we need to be able to upgrade the technology stack. So that then leads to you need an architecture that's loosely coupled and modular and testable and deployable. Now, so, the monolithic architecture is a good choice for small applications that are developed by a small team. But once the application becomes large and you have a large team, often the microservice architecture is a better choice. And if you adopt the microservice architecture, you need to design your services to be loosely coupled, both from a runtime and design time perspective. So that's my talk. Thank you for listening, and I hope that you found it useful.
Thank you, Chris. Thank you so much for connecting today and presenting this talk and supporting Devoxx Ukraine. Dear participants, you can ask your questions. Thank you. You can ask your questions to Chris during Q&A Zoom room just now after this talk, and you can unmute, turn on your video, and have a discussion with Chris. Yeah. So thank you once again, and we hope to welcome you in Ukraine next year. Dear participants, Devoxx Ukraine is almost done, but don't hurry up turning off the streaming. We will have a closing ceremony soon, and at this ceremony we will announce the winners of all prize raffles from our partners you solved during these last 2 days, and of course the best talks and the best speakers of Devoxx Ukraine online. Stay with us, and we will be back soon. Okay, dear participants, thank you for these 2 awesome days you stayed with us at Devoxx Ukraine Online. We are very thankful to EPAM, our platinum partner and co-organizer of Devoxx Ukraine and the company who made this event happen.
Thank you very much, and we are very thankful to the FEST group who was also hosting this event and was organizing this event. Thank you very much.
Yeah, and of course we are also very thankful to the speakers who prepared their talks for the last several months, worked on them and joined this online broadcasting, online streaming, and was able to share their knowledge and competence. Thank you very much. Yeah, dear participants, stay with us, subscribe to our Facebook group, Twitter channel, and to our YouTube channel of Devoxx Ukraine. All videos from 2 days of the conference will be published at this YouTube channel within the next 2 weeks.
And we are waiting for your feedbacks. So if you were yesterday or you were today or you were both maybe days with us, you please scan this QR code that now you see on your screens and follow the link and please pass our little survey so we can get better and better each year.
Yeah, and if you enjoyed this conference today and yesterday, if you enjoyed Devoxx Ukraine for the last years, and if you want to be part of Devoxx Ukraine 2021, we have opened a pre-registration for the next year. You can fill in the form, just leave your email, and you will be the first one who will be notified when we start preparing Devoxx Ukraine 2021. We don't know the format yet, whether it will be online or offline, depending on the lockdown and quarantine, but we hope that we can meet you in person in a year, November 5 and 6 at Devoxx Ukraine 2021. Yes, and for those of you who have participated with our challenge and who have posted the photos how you watch Devoxx Ukraine online with hashtags Devoxx Ukraine and Java 25th anniversary. So if you see your photo at this slide, you are the lucky winners, and your photos were the best ones from all the posted in all social media. So we will contact you soon, and you will receive a prize from our gift partner, JetBrains. This is a 1-year free subscription to any product from their all-product pack. So stay with us. We will let you know, and we will send you the link to this free subscription. Yeah, we are also very thankful to our silver partners, companies who supported this event. It's DN Simple, iTerra, and Grid Dynamics. And if you have participated with a quiz from Grid Dynamics, here are the lucky winners of this quiz. There are more than 300 people participated, so the guys on the screen, you are the luckiest, you are the smartest, so you win prizes from Grid Dynamics. The company will contact you via the emails that you have specified, and they will send you your prizes. Okay, and now we would like to invite to our virtual stage our next partner, Sigma Software, who will also raffle some prizes for their activities they had during these 2 days. Kate,
Hi,
do you hear us?
Hello.
Yeah, I'm here. You're welcome. Happy to see you again. Guys, welcome to Sigma Software Prize Draw. This time it's happening online. We are really happy to support the Devoxx conference this year online. And previous year, we really happy to meet the Java community offline. And today, I want to say thank you for all of you who joined, who watched the speeches from our speakers, who participated in our giveaways, and who also checked their knowledge in Java history quiz. So it's time to announce the winners, and I will start from the Java history quiz. We have quite a lot of winners. with the people who have the highest scores. Then it's Бондаревский, Сергей Левицкий, Андрей Легедза, Евгений Скорый, Виктор Хаврилышев, Алексей Гнатюк, Алексей Янов, Леонид Остапенко, Дебакланч Дали, Игорь Гринев, Александр Калиничев, Варас Барбоса, Артем Козин, Александр Лукьянин, Тиаго Муси, Евген Воробьев, Нинель Чумак, Богдан Кубарь, Максим Тычина, Дмитрий Волошин, Вероника Стехненко, Alexander Stechnenko, Alex Kalka, Alexei Klitko. Guys, I'm really happy to congratulate you with the win. Sigma Software prepared some branded prizes for you, and we are going to contact you via email you specified in the registration form. So waiting for our email and congratulate you again. So let's move to the main prize from Sigma Software. It's Amazon Prime Year membership that includes thousands of video in Prime Video, 1 million free songs, free unlimited photo storage, instant access to email, ebooks, and free and convenient ways to get delivery from Amazon. So who is the lucky ones? Let's check. We have quite a lot of participants. So probably who is the lucky one? Ustinov. I don't know the name because there are all the last names. So we congratulate you and we'll contact you ASAP or via email and make this subscription for you. So thank you again and hope to meet you next time in offline format.
Thank you, Kate.
Thank you very much.
And thank you, Sigma Software, for support and for making this event happen today. So our partners, our speakers, our participants, you are the key of this event today. So thank you once again. See you next year.
Thank you again. Bye.
Okay, and we are glad to invite to the stage our next partner, NX company. Hello.
Yeah. Hi. Hello, everyone. So, as it was mentioned, I'm from NX company. My name is Alena. First, thank you to the organizers for this amazing conference. And I would like to say a few words about NX. We would like to mention that we have more than 1,000 professionals and are actively growing and looking for more talented people to join our team, and we hire remotely. So do check out our NX Career website and our social media channels to find out about these opportunities. And now, let's move on to a fun part to find out who are the lucky winners of present from NX. So we will have 4 lucky winners. The main prize is this Xiaomi robot, and 3 other people will win each big box of branded goods from our company, including a branded water bottle and blanket and a lot of other stuff. So we have a list of people who wish to participate, and now using random org, let's find out our 4 winners. Yeah, let's randomize it. So it's hard to read for me, but I'm sure you see the names on the screen. So congratulations to the 4 first people. The first person wins our robot, and 3 other win our branded goods. So thank you. Yeah.
Thank you so much, NX. And the winners, you will be contacted by NX company and you will receive your prizes shortly. So yeah, we are thankful NX company for supporting our event, and we would like to invite to our online stage our next gold partner, Svetla Systems. Hello.
Hello everyone. Nice to see you.
Nice to see you
My
too.
name is Diana. and I'm community manager from Svetla Systems. And I'm very happy and very excited to be here today because I'm going to announce the winners of our raffles. So we had two of them. The first one, participants just had to fill some information in our questionnaire. And the second one was quite harder because participants had to leave right answers in our Java quiz. So, among our presents, we have several thermocups, cups, backpacks, t-shirts, and also the main prize is AirPods Pro. We have 2 pairs of them. So, here are the winners. So, cups go to Власенко Ольга, Хуляренко Руслан, Бажанар Віктор, Ткачук Лілія, and Андрій Мельник. Coffee to go cup go to Наконечна Мар'яна, Підгорний Павло, Максим Тичина, Ірина Довгун та Станіслав Римар. And banana bag go to Devoxx Юрій, Кузьменко Ігор, Олександр Даниленко, Дмитро Альцванович, Андрій Новак. And t-shirts go to Ткаченко Андрій, Колєсніков Валентин, Володимир Максименко, Сергій Хоменко, and Artem Kozin. So we have a lot of winners. And from our Java quiz, so the winners are Thermocup go to Alexander Yanov, Alexander Butrym, and Mikhail Горбунов. Backpacks go to Іван Боярин, Василь Сержинський, Олексій Клочко, and the main prize, AirPods Pro, go to Nikolai Ivanov and Andriy Sit. Congratulations, guys. And if you misheard something, you can find the list of winners on our Facebook page. So welcome and check if your name is on the list.
Thank you. Thank you,
Thank
Diana.
you. Thank you a lot. I want to thank all participants for joining and also you organizers because you do great things now. You help to develop this IT community and also help us to gain some new knowledge and experience. And I really hope that we will see within the next conference in person and offline next time.
Yeah, we hope for that too. Thank you, Svetla Systems, for supporting our event this year. And congratulations to the lucky winners.
It was a pleasure for us. Bye, guys.
Bye. Okay, we are moving further, but before we will invite our next gold partner, I would like to invite on this stage the head of Devoxx Ukraine Program Committee, the guy who worked hard with the speakers for the past year, and the guy who not only the guy, but the team who worked hard, and the guy who selected the talks. And he will announce the best speakers of Devoxx Ukraine 2020. Oleg, welcome on stage.
Thank you. Hello, everyone. Yeah, that's been like two amazing days, I would say. That was quite kind of tough, I would say, but I guess it's worth that. And everyone, I mean, I like all the talks, all the speakers, but we have like top 5 based on the participants' votes, and I will just announce right now. The first one, Guy Rose. Congratulations, Guy. Second one, Victor Rentia. Third one, Brian Vermeer. Fourth one, Simon Ritter. And fifth place goes to Grace Jensen. Thanks a lot, guys. Again, I very much appreciate your conference attendance, and I very much hope that next year we will be able to organize Devoxx Ukraine probably offline and meet all of you in person. My pleasure. Thanks.
Thank you so much. Thank you, Oleg, and congratulations to the best speakers. Guys, we have prepared a small present for you from our Devoxx Ukraine team. And we will send you a branded hoodie of Devoxx Ukraine 2020. You know, it's a very, very limited edition. Only 5 of them this year. So you will be the lucky one to receive them. Thank you so much. And yeah, I would like to invite to our online stage our next gold partner, the company who supported Devoxx Ukraine this year and some of the years before, InfoPulse, and Alina, who will connect now to our stage. Hello,
Hello. Hi, I would like to be here with you, but now I'm a little bit nervous because I feel myself like a Santa in a New Year night with a big bag of prizes. And I have only a few minutes, and already we have a list of participants who won our prizes. And I can read it. So, power bank go to Harbalukov Oleg. Wireless charging. Yeah. Wireless charging.
Power bank.
Mini speaker Orlov Vladislav. Next mini speaker. Very interesting. Priya Vishnu. Mini speaker. Next one. Kadyrov Inam. Mini speaker, Chancellor Mitya.
Bravo!
And I think that Semenenko Dima can give from us travel set.
Congratulations!
And next travel set go to Yerusalimentsev Dmitry.
Congratulations, Dima!
So, next travel set go to Kapustnik Mikhail.
Woohoo!
And
yeah, go!
Last travel set go to Ivanov Yanislav. So, next our prize go to Mažejka Povilas. It's a gym backpack. And next backpack goes to Jenkan Yan.
Woohoo!
So
congratulations,
we have 2 umbrellas
guys.
today. Yes, we have 2 umbrellas today, and these umbrellas will go to Livik Oleg and Pindral Marcin. So, and our beautiful plate go to Izotenko Volodymyr.
So, congratulations.
Yep. But we have our main prize. It's Marshall Loader speaker, Stanmore Wi-Fi Black, and now we will see who will be the winner and who will be the lucker today.
We are intrigued.
Yep, I'm too. So, and our main prize go to Barma Dmitro.
Dmitro, yay!
So, thank you very much for this opportunity to be here in one of the biggest and main conference in Java world, Devoxx Ukraine. And I wish all participants prosperity and good luck in your doing. So, I will be glad to see you next year offline in one of the biggest and beautiful and superstar conference, Devoxx Ukraine.
Thank you, Alina.
Thank you very much for such warm words.
Yeah. Thank you. We wish you were here, of course, with us, but this year is a bit different. But we are very thankful to InfoPulse company for supporting our event this year. Yeah, and the next gold partner we want to invite to this stage is Lunatech company, and we will connect Antoine. Antoine, are you with us? Hello. We don't hear you, Antoine.
Can you speak up? We will reconnect.
Yeah, Antoine will reconnect. So while he's reconnecting, I would like you, if you have joined the closing ceremony not from the very beginning, I would like just to remind that all the videos of the talks, they will be published within the next 2 weeks on our Devoxx Ukraine YouTube channel. So you can subscribe to the channel. There will be a separate playlist for this year, and you will see all the videos of the talks you have missed.
And also, we will send you a letter with a feedback form on Monday. And please go by the link and submit the feedback form. This is very, very important for us because we want to make our event better and better each year. So please put your thoughts into the feedback form.
Yeah, and as it was mentioned on the opening ceremony, if you have any crazy ideas what we can do next year, just feel free to put it in the form, and we will be glad to hear your feedback and to see your opinion on the conference. Yeah, and while Anton is still reconnected, we have 1 more minute. We have opened a pre-registration for the next year, Devoxx Ukraine 2021. The link will be sent to you together with the feedback form in an email. So if you liked these 2 days of the conference and you want to be part of the next year conference, just feel free to fill the form, leave your email, and we will contact you once we start preparation. So Antoine, you are back with us. Hello.
Do you Hello, do you hear me?
Yes, we hear you well.
Fantastic. I'm so happy. So,
yeah, we are so happy you're with us, and thank you to Lunatech company for supporting our event. So what prizes you would like to raffle for our participants?
Hello, the prize is a light band reactive certification.
That's cool.
Yeah, there is 2 of them. So I have the name of the winner.
Yeah, we are waiting. We are looking forward to hear.
Yes, but later. First, I want to thanks to all the participants and the organizers. I hope that all of you guys enjoy this edition. Apparently, yes, because there's more than 200 attendees participated to our raffle. So we will send you an email very soon to give you the vouchers. Lunatech was very proud to participate to this Devoxx Ukraine edition. Do not hesitate to contact us if you want to have any further information about the company. And long life to Devoxx.
Thank you very much.
Thank you. Thank you for these warm words.
And then, yes, I will check the name of the winner because it's...
We are waiting for it.
So, big suspense. So the winner, correct me if I'm wrong.
Okay, go ahead.
Ilor Kisilevich.
Kisilevich. Ilya Kisilevich.
Ilor Kisilevich and Stanislav Rimar.
Stanislav Rimar. Very nice, very nice.
Yeah, guys, Dmitro and, Ilya and Stanislav. Congratulations, and you will be contacted by Lunatech company and maybe by Antoine in person, and you will receive your prizes. So congratulations once again.
Yes, the 2 names of the winners will be on our Devoxx page.
Yes, okay. So thank you once again. Yeah, thank you for supporting our event. We are very grateful to you and hope to see you next year, of course.
For sure, in real life.
Yes, in real life. Welcome to Ukraine.
Thank you. Okay, and I would like to invite to this stage, online stage, our next partner, gold partner, Luxsoft company, and Olesya, who will connect today. Hello.
Hello.
Hi guys, can you hear me?
Yes, we hear you.
Great. I'm very happy that my connection went through. And first of all, I would like to thank to the organizers of Devoxx 2020 for putting up such a wonderful event, 2-day online event, which actually turned global. This is an amazing thing you've done. Congratulations to you.
Thank you very much. Your words are very important to us.
And the second, you're very welcome. And the secondly, I would like to also thank the participants of the conference because none of this would have made sense if it all wasn't for them.
Yes, that's true. That's true.
They're the best, and I think they're the best.
I mean, they've made, even though we didn't see each other, right? But I could felt this vibe and the communication, the conversations, and the questions that were put to the speakers. People really made this conference, alive as it could be digitally.
Yeah, as much as we could do, it's alive.
Yeah. Well, it seems like we are forced today live in this like semi-real or digital. This is a new reality, right? So.
Yeah, that's true.
And the third, in a third turn, yes, but last but not least, I would like to thank the speakers because they, they were up for the event. They never resigned and were there, to deliver their best knowledge and share their experience. Great job to everyone.
Thank you.
So I'm basically done with all my thanks. And have to say that we were very happy to be a part of this event. And we hope that next year we will be joining all of you somewhere in the event hall where we can, shake hands and smile at each other and just have a good time together. And to wrap up this amazing experience of 2-day conference, I would like to share my screen and finish up our friendly giveaway. I want to remind to our participants that we had quite a few entertainments during the Devoxx. So there was a galactic IT quiz for the developers where they could test their knowledge and answer the questions on technology, and whoever was the fastest wins the prize. The names of these winners you can find in our Telegram channel. The link to it is in the partnership section, so if you are interested in who won, please go ahead and check it out. And we will contact all the winners via email, but still you can find your names if you want in our Telegram channel. And that was the first thing, yes, Galactic IT Quiz. The second thing, we had our Locks Up Friendly giveaway where we are awarding people with something to remember us by. These are super chargers for the gadgets, whichever gadgets you have. And the second thing is the backpacks. And the main prize of our giveaway is a bicycle, which I am about to find out who's the winner of it. So if you can see my screen, I'm using random.org, the very common tool for picking the winners. Let the destiny decide. And here are the topic in this window. There are over 6,000 names of the participants who agreed to participate in our friendly giveaway. And I will just, with one easy movement, I am pressing the randomize button, and whoever is the number one after randomizing this list will win the bicycle. So, da-da-da-dam, I'm done talking. And back to randomizing. Довженко Dmitro, congratulations!
Oh, congratulations! Congratulations, Dmitro. That's an amazing gift for our quarantine times?
Yeah, well, maybe it's still autumn, so while it's not raining, you can go ahead and enjoy the ride on a bicycle.
Yes.
Otherwise, it will wait for the springtime, for happy times to come, hopefully without coronavirus.
Yeah, we all hope for this.
Yeah. So congratulations to Dmitro. Once again, my name is Lesya. I'm representing Devoxx company. We are very happy to meet you all. We have plenty of vacancies in Java. So people who are listening to me now, please don't hesitate to go and check them out. If we are speaking about Java, right? So we will be waiting for you at any time, and we are really eager to open the doors to the new career opportunities to all of you. So thank you very much.
Thank
you. Thank you, Lesya, and thank you, Devoxx
Bye-bye.
company, for supporting our event this year. Okay, and we have just two partners left, and the prizes are getting bigger and bigger. So I would like to invite our next partner, Playtika company, and its representative, Vice President Nir Pinhasov.
Hi, how are you guys?
Hello.
I'm speaking all the way from Israel, so I hope that you are all good there in Ukraine.
How is the weather in Israel?
Oh, it's beginning to be winter, very, very cold, around 20 degrees, very cold for us.
Poor you.
So, first of all, great conference. I think taking into consideration all the complicated times that we have right now, it seems like you nailed it. And I want to thank personally for the speakers from Playtika on this conference and the overall speakers. It was very interesting, and thank you for organizing that. And we're very proud to be also participating in those. I will share a bit about Playtika and then about the winner. Okay, so for those of you who don't know, Playtika is a leading game and entertainment company. Our mission is to create infinite way of playing. We are based in Israel, the headquarters in Israel, but we are big believers of Eastern Europe, and most of our development is here in Ukraine, Belarus, Bucharest, Dnipro, Vinica. We are very proud of all the departments that we have. I'm personally managing the shared services, R&D and data development of Playtika. And I want to tell you that we have fascinating time in Playtika and a lot of vacancies and a lot of opportunities. So I encourage you guys to join, okay? So we are waiting. Today we are building like a platform that is basically being injected to all Playtika games. This is something that we are doing mostly in Kiev, and it's amazing times to join. With no further ado, I would like to announce the winner. The prize is huge. I want to tell you.
Oh yes, it is.
It
is.
It's a MacBook Pro. Okay,
Wow.
and yes, the winner of this MacBook Pro is Maxim Tichina.
Woohoo! Maxim, congratulations.
Yeah, that's an amazing prize from Playtika, and you're the lucky one. Thank you. So,
Yes,
thank you,
Maxim,
Playtika.
join us, Maxim.
With a MacBook, join with a MacBook.
Thank you for everything, and good luck.
Thank you, Nir.
Thanks.
Thank you, Playtika, for supporting our event this year. So, we are almost done, dear participants. We have the last partner, our platinum partner, EPAM company, who we invite on the stage Katerina from EPAM, who will do the final raffle.
Hello, teams. Yes, so great to have all of you at Devoxx Ukraine, and not only despite the circumstances, but mostly thanks to the team, the great teams who ran this online event for thousands of participants, scaling the conference on the global level. This is really exciting to see how the conference grows from year to year. So thank you, guys. Also, big thanks to our speakers, because thanks to you, this conference is being expected each year, and you bring the value. So thank you. And as I'm here to give away some presents, let me proceed with this. So let me start with announcing the winners of our online bot challenge that we ran for the 2 days of the conference. So we have 7 leaders who scored the most of the points, and the 3 leaders, the first 3 leaders, are going to receive the hoodies. They are Tanya Gavrilishina, Alexander Mularevich, Viktor Gavrilishin. Also, Sergey Zdorenko and Denis Kuzmenko are going to receive wireless charging organizers, and we have 2 more wireless charging power banks, and they go to Alexander Vovk and Alexander Reshetnik. Thank you guys for participating. Hope you enjoyed the game, and thanks to our EPAM teams actually who prepared this game for you. So thank you. And now I think we shall proceed with the raffle. So we have 5 kinds of the presents, and we're going to hit the button each time we determine the winners. And let's proceed. Let's start with the 3 more hoodies. We have them for the winners of the raffle, and let's see who they are going to be.
Yeah, just a small technical.
Yeah, we have a technical little issue, but we will fix it in a few seconds. You will see now on the screen.
Okay, we are ready.
So the 3 winners who are going to receive branded hoodies go to... No?
Still some technical issues.
It happens.
Let's try one more time.
It happens like every time to us during the raffle at Devoxx. It's okay, we're used to it. Just
But you see that this is a live session. It's not pre-recorded. We are live here, and you see how it's going.
Without it, I think I wouldn't be able to feel the atmosphere of the conference.
That is true. But we will do this. Yeah. Come on, Random Org.
I'm not sure, probably because a lot of names, but haven't tested it. It should work.
And what will be the price?
Okay, let me list while we're trying to fix the issue. Let me fix the prices. So, we have 3 hoodies. We have 3 wireless charging organizers. We have 3 wireless power banks. We also have 3 discount certificates for EPAM's master's degree program in software engineering. These 3 certificates give you discount to the program that starts next year. The duration of the program is 2 years. It consists of several modules on delivery management, solution architecture, engineering excellence, DevOps cloud, and big data. So this is going to be a huge contribution to somebody's professional profiles. And also we have 3 Amazon certificates for $300, $200, and $100. And we are going to raffle those really soon.
Sounds like very exciting presents, especially the certificates to Amazon. Like this is the biggest prize, I think. So, Kate, while we're waiting, let's talk a bit. We have a time. So, what did you enjoy the most during the conference?
Well, I really enjoyed that this year. As I said, I'm trying to accept this not like the circumstances that made us go online, but as a huge opportunity to make the conference global. And the target that we set for ourselves that seem even unrealistic to ourselves, I believe, that we managed to achieve it, and this is really, I don't know, this is exciting achievement, and I'm really proud of our team.
Yeah, that is true. We had participants from like very interesting countries, from Nigeria, from Trinidad and Tobago, from Lithuania, from everywhere, I think, any country in the world. So this is very exciting. I hope that next year we will have an opportunity to meet those guys in person here in Ukraine.
Yeah, me too.
Okay, so how are the things going with the random? Okay, we're still fixing, so I will remind you a few things about the conference. So the next dates of the conference will be 5th and 6th of November 2021. So we will share with you link for the pre-registration. Please register if you want to be the first who will get the news from us on the next edition. And also on Monday we will share with you our feedback form, so please go to the feedback form and put your thoughts here, like was saying, crazy ideas, some feedbacks, some just ideas that you think we can improve in our organization or in our content of the conference. Please share within your feedback form. We will be waiting for your answers. And also, please subscribe to our channels. We have a Twitter, we have a Facebook page, we have Instagram page, and the most important part, the YouTube channel, all the talks that we managed to record during 2 days of the conference, you will see them on our YouTube channel, Devoxx Ukraine, so please, please, please subscribe. And now I think we can go back to the random org.
Let's try. So the hoodies, 3 hoodies. Will we see the names? Yay!
Yay!
Come closer. So, Pindua Daria from Odessa, Shamarin Alexei from Kharkiv, and Porubai Artyom from Kharkiv. So, congratulations, guys! You're going to receive Devoxx branded hoodies by EPAM. Let us proceed with the wireless charging organizers. We have also 3 of them.
And we are waiting once again for the next round. You see that by the end of the day we are like our devices are getting get tired a little bit, so it needed to reload, but still we are waiting. And as a reminder, I want to say once again, then please subscribe to our channels, to YouTube channel, to Twitter channel, to the Facebook and to Instagram. And on the YouTube you will get all the talks that we got during the 2 days.
Okay, the next 3 presents. Ozan Beyza, Ankara. Sorry, just sorry if I misspell because I can't see well. Can you guys help?
Yeah,
thanks.
it is.
Thanks. Antipolas Andrius from Kaunas and Nevinska Yulia from Kiev. Okay, so I suppose, guys, to reduce the number of attempts, the next, let me read the next 3 names, and what we have? We have power banks. Okay, so Yaniga Dominic from Zhdansk, Krole Gregos from Krakow, and Linik Alexei from Kharkiv. They are going to receive power banks. Okay, and if we can hit the button one more time, let's see who are going to receive the master's degree program discount certificates. And starting from the From the first name, the person who are going to receive 50% discount for this program, and the next two 25% discount. So Гуцуляк Vasil from Ivano-Frankivsk, you are going to receive the 50% discount, and Romanchi Artyom from Odessa, and Vyzhnitsky Thomas from Lviv. Guys, you are going to receive this discount, and believe me, this is a really great opportunity for you. And what is great, you are in Ukraine, but even if we would have the winners from another countries, there would be not a problem, because this is actually possible online, but still, you're from Ukraine, so you are going to join the program without problems. So we will get in touch with you to provide you more details. And so we have the 3 more certificates on Amazon. Let us see who are the winners. So 300 Amazon certificate goes to Rana Puya from Herndon. $200 certificate goes to Mizoglad Henrik from Budapest, and 100 certificate goes to Baratula Vanaya from Mumbai. Wow, really great list of countries and the winners. I'm really glad that we're able to, to award so many people from all over the world today. So thank you once again, guys. And one more thing, I would like to encourage you to also register for one more exciting conference that is going to be held for 5 days from EPAM. This conference is organized by EPAM. It starts on November 30. And this is going to be 5 days full of talks, like more than 100 talks from experts from EPAM in different technologies. So join, it's also free, it's online. So the link is still in your cabinet, so you have a chance to register for it. Don't miss the chance. Thank you once again.
Thank you very much.
Again.
See you next year.
Thank you.
Thank you.
Thank you, Katerina, and thanks to EPAM, our platinum partner at this event. So the raffle was very intriguing, yeah?
Yeah,
we were very excited to see the winners.
Yeah, but you know, it also proves that we have a lot of participants from other countries.
Yeah, so the results are also very, very surprising. So, dear participants, Devoxx Ukraine is officially over. I would like to take this chance and thanks once again to our participants, speakers, partners, and of course to the organizational team who worked on creating this event for you for the last several months. It's a first group team, EPAM team, and Devoxx team, of course, and our technical staff who spent 2 days at this studio and venue together with us. So about 40 people worked on creating this event. So thank you so much, and I welcome you to join Devoxx Ukraine next year.
Yeah, it was amazing 2 days. I will miss those 2 days actually. It was unforgettable experience, first one, and we were the only from Devoxx family who were doing Devoxx online this year. So I will look forward to the next edition, but I hope it will be offline in Ukraine.
I hope for it too. So thank you.
Thank
Devoxx
you.
Ukraine is over.
See you next year.